Okay, good morning, everyone. Welcome to Rejekts. I'm Andy, and
I'm Marga, and yeah, we are so excited to have you here. Andy and I were talking about Rejekts last week, and we were just saying how excited we were to be here again. We were in Valencia last year, and it was an awesome conference, so we are looking forward to this one.
Yeah, although remembering back to Valencia, back then Marga and I were colleagues both at Microsoft, and since then, I don't know if it was Windows or me that she couldn't stand to work with anymore. But
of course it was Windows. I loved working with you, Andy.
Thank you. But anyway, she's now moved on, is impacting the industry in a great way at Isovalent, and we're very happy about that.
All right, so who here has already been at a Cloud Native Rejekts before? Show of hands.
A few.
Okay, it's not so many, a lot of newcomers. So welcome everybody, newcomers and old-timers as well.
Yep, and so we'll just go through a few minutes, talk through the logistics, let you know what's happening. But really, it's kind of amazing. This is now the sixth in-person Rejekts event, and so particularly given some of you have not been to a Rejekts at all before, we kind of thought maybe a couple of minutes just on the history of how did this thing come about might be interesting. So if you go back to 2018, the KubeCon in Seattle that time had about 8,000 participants, and this is crazy for people like me. I remember, I think less than 500 people at the first KubeCon I went to. So it was pretty clear this thing was getting to be something very different, much larger. A lot of great talks were getting rejected, and this led to a kind of aha moment for Chris Kuhl, who was the CEO of Kinvolk, a little software company in Berlin. And he said, well, why not create a forum that is just a little bit more intimate, gives a venue for those really good talks, because there are a lot of great talks that don't get accepted at KubeCon, and just kind of allows people to warm up and get into the week. So that was kind of the origin of it, and since then, we've been we started out in Barcelona, so with KubeCon Barcelona was the first one. I didn't quite make that. I turned up for the following day, but San Diego, LA, Valencia, etc. And then, of course, in the middle of all this, we had the pandemic, and we actually had one of the first virtual conferences, which went around the clock from India to the West Coast, and was pretty exciting as well. So, so we've had a long history, and we're really pleased to have this event in Amsterdam, because we actually booked this venue. That 2020 virtual one was meant to be in this venue. So the folks here were kind enough to let us keep the reservation for a very long time. And I mentioned that Rejekts started out of this little company, Kinvolk, and it's probably, for those of you who don't really know that the origins of that company and where those people came from, I think kind of knowing something about the culture that we had there really kind of informs Rejekts. So, if you go and look at the Kinvolk website, which is, we have a page which is what is our culture, and we talk about these values of, community and contributing, cooperating and welcoming. And, those were what we talked about as the company values, but I think you can see those really translate well into the Cloud Native Rejekts kind of ethos as well. So we're, we feel that's the kind of environment we're trying to make, and it's also what we see here too. Now, some of you may know, since we originally founded Rejekts, Kinvolk was acquired by Microsoft a couple of years ago. And at the time of that acquisition, we were very clear with the Microsoft folks, this was something we wanted to continue. But Microsoft also said, this is actually pretty consistent with our values as well, and the kind of things that we want to do. So, we've been really happy that we've had the support of, of all the folks within Microsoft, enabling our team to continue organizing this event. Also with the help and support of a whole lot of other companies who sponsor, and a number of volunteers, so the folks who will be running the rooms and staffing the desks and all of that. A lot of volunteer work goes into making this happen. So it's very kind of a grassroots event. talking of those sponsors, I just want to take a minute to thank all of these companies, organizations for the help that they've given us, in many cases financial, but also folks like the News Stack giving media and promotion coverage as well, and that's really helpful too, and we're happy to have them here. So I'd like to just everyone give a hand to the sponsors for their help. Thank you, because it really does make a difference. And if any of you have have contacts in your marketing departments with big budgets, then let us know, because we have more of these coming up. In fact, so just back on the conference, if you'll be having talks over the next couple of days. How do we get there? We actually had 144 proposals came in, so folks who had their talks rejected from KubeCon submitted them to Rejekts. Of those, we managed to get 51 speakers giving 42 talks. So I think it's a really varied program. I looked through it. There's a whole load of things I'm really excited about. But the irony is now that Rejekts has got so much awareness and attracts so many proposals that that's over 100 talks we had rejected. So there are a whole load of people out there who are rejects from Rejekts, and I feel really sorry for them. And if anyone wants to start the Rejected from Rejekts conference, they're welcome, but we're busy enough here. So with that, I'll hand over to Margot to tell you a bit more about the logistics for the next couple of days.
All right, so logistics. Or first, how do I...
Middle button, that's the most important logistic.
Okay, first logistic. Okay, so just a little bit about the space. We are here in the room that is called the warehouse, and this is where like the main track is going to be. So moving on, like the talks that are like the first track in the schedule is the warehouse, and then upstairs we have another very cool, like this space is really cool. I find everything like the lounges and another very cool space upstairs called the suite that has the other track. So please don't just leave the speakers upstairs alone. Like if you're interested in the talk, go up the stairs, because that's why we have two tracks. And then you probably already found it, but perhaps if you came a little bit late, across this patio area, there's the lounge where there's coffee and tea and fruit and some protein bars. We basically have the space for us, so enjoy it. Now, regarding the schedule, on your badges there's a QR code, and like it's the QR code is kind of everywhere. That leads you to the live schedule. It's kind of like a tradition at Rejekts that things get moved around. Some speaker missed their flight, and so we need to like rearrange last minute. So that's why the schedule is live. There's also a projection in the lounge where you can see like the upcoming talks. But the format that we have is, so we now have some talks, then we have a break, and then we have lunch. And this is important for those that maybe know other conferences. Here we don't have catered lunch. You need to go and get lunch on your own. And this gives you an opportunity to explore the city, explore like the local cuisine, and enjoy a sit-down meal with hopefully other attendees, where you can talk about whatever you do at work or outside of work. And then we come back for more talks, and there's another break in between. And tomorrow it's going to be a similar schedule. Lunch is a little bit earlier, but apart from that, it's the same thing, except that at the end we have lightning talks. So there's a board at the entrance, a whiteboard, with already a couple of talks there, but there's still space. So if there's a 5-minute thing that you want to share with other attendees, please go ahead and write your name on the board. Regarding COVID-19, as you probably know, here in the Netherlands, it's considered endemic, so we can't actually have any measures like masking or asking people to be vaccinated, but we do ask people, like, not ask, like, we invite people that if you have like your own desires regarding contact or not contact with other people, you can take one of these wristbands at the front desk, and then it's easier for the others to know how you feel about it. And Rejekts has had a great history of being an inclusive place where everyone is welcome, and we haven't had any kind of problems, and we want to keep it that way. So we do have a code of conduct, and we ask you to read it. In synthesis, we ask you to be kind to each other and behave professionally. If you see or experience a code of conduct violation, you can email coc@rejekts.io or speak with some of the organizers, either ask at the front desk, or if you know who the organizers are already, just contact us. And that's it. Thank you very much. We will start the first talks in 4 minutes. We have one talk about Gateway API, starting here in 4 minutes, and one talk about using AI for your APIs, a different API, upstairs, also in 4 minutes.
Great.
Thank you.
Thank you so much.
Hi, everybody. Thanks to be here for this first talk about the Gateway API. So first thing first, I shouldn't have been here. I was not the one to submit. So here is my colleague Navendo, who submitted, who was accepted. So he was not part of the rejects. But unfortunately, at the moment, he's in Singapore. So it was a bit hard for him to be on 2 sites at the same time. So it's me, and I'm also a developer advocate, but nobody gives a damn. I have 20 minutes, so I need to speed up a bit. I work on the Apache API 6 project, so it's an, as you can imagine, an API gateway. It's built on Nginx. Then you have OpenResty, which is a Lua layer. Then you've got the API 6 core that allows you to build plugins on top. I have a question. Who has no clue about like pods and services and not ports? Okay, one person. So I need to be very quick. Okay, sorry?
I'm kidding.
Okay. That's really funny. I have 20 minutes. My demo didn't work. I'm super stressed. Okay, so I will start directly from the ingress way. Just need to find the stuff, okay? So basically, with like services and node ports, everything was good. You could like get traffic into your Kubernetes cluster. The problem is you had to create one for each. Like, how do you route stuff? So Kubernetes came with this nice idea of, oh, let's create something called an ingress that can do some routing. That's good, but it's like path-based. So we can do some stuff, but it's path-based. So right now, I will try to demo some stuff. And as I mentioned, this morning it didn't work. Magically, it works now. So I beg for your forgiveness, because, well, you can imagine it's not really fun. So here I have, it must be a bit bigger. That already works, so I have aliased my kubectl to be K. Then I have updated my Helm charts, and then I have installed API 6, which also is an ingress controller for Kubernetes. So I'm using the Helm charts. I just configure a couple of stuff. I enable the API gateway for later, although here at the moment it's not necessary. I install 2 pods and 2 services, one left and one right. Amazing engineering. So basically, I want to show you this kind of crazy stuff. And now comes ingress time. So ingress, I install the ingress. Normally, if everything works as expected, I can apply it directly. F4 ingress, K-get ingress. Normally, it should work. So now I can try to curl because of the prefix. It's quite obvious. If I query left, it should direct me to the left pods, and if I query right, to the right pods. And normally, curl. Oh, yes, it works. Just to be sure, great. Amazing. Perhaps it's too small, so let's make it a bit bigger. Okay, perfect. Okay, but path-based doesn't allow you to do much stuff. For example, one of the most obvious way is to have versioning with path. So basically, you have v1/whatever and v2/whatever. And so if you directly forward, well, the pod will receive v1. And so you need to remove it before. That's not part of the normal ingress. So what do? We bring annotations. And annotations depend on your implementation. In this case, the implementation is API 6. So I have annotations for that. Some other might not allow it. Some other might have different ways to apply it. So here, I will do the ingress stuff. And yes, so now I want to curl again. Sorry. Whoop. Okay, so I will curl local hosts 3800/left/foobar or whatever. And okay, now my prefix has been removed and I'm happy. But the problem is now I'm tied to my implementation. Okay, it probably won't happen, but if I want to migrate to another implementation, I need to check if it's possible, how they do it, whatever. So basically, we invented the ingress abstraction, but now we are tied to the implementation again, which is not what we wanted to do in the first place. But we can do even better, because I mentioned versioning. We can do a lot of stuff depending on the implementation. So here, I will add this object called API6 route, which allows me to do like other stuff. For example, I can apply -f. I will probably need to delete my ingress first. Delete ingress. I don't remember how I called it again. It's called ingress, well, which is easy. And now I can apply API6 routes. Okay. And my routes are here. So basically now I'm leveraging all the power of the implementation through a CRD. I don't care about the abstraction. I just can query whatever I want. So here what I'm doing is I can do query-based routing, which is not possible in Ingress. Because for versioning, for example, you can have path-based, header-based, query-based routing, and Ingress only gives us one. So here, I don't remember if I applied it. Get. Thanks. Yeah, you see I'm stressed, right? So now I want to curl localhost 800. And here I think I should add this. And I say side equals left. Nope. I know there is something problematic here. No, this one. Yes. So here I have rewritten everything through the power of the Ingress controller. But again, this is not the abstraction, this is the implementation. So what can we do? Comes the API gateway. And the API gateway, like every new stuff, is supposed to cure all your issues, right? So it handles the organizational stuff. So you would have a gateway class that is under the responsibility of the infrastructure provider. You would have the gateway, which is under the responsibility of the cluster operator. And then every developer could handle their own HTTP routes, and everything is good. Sounds too good to be true? Probably it is. So here is how you can do it. This is directly taken from documentation. And the good thing is it should handle query-based routing. So you have exactly what I showed you with the API6 routes directly implemented in the HTTP routes. And you have no custom CRD to install. Because, of course, like when you install an implementation, you need to have your custom CRD. However, you need, at the moment, to install a specific CRD because the API, they are not part of the Kubernetes distribution, so I had to install the gateway CRDs. But at some point, hopefully, they will be part. So I can remove delete API6 routes, and I call them routes, probably. Yep. And I can apply HTTP routes, sorry, F. And I was so stressed that I went too fast, but it's fine. Get HTTP routes. Yep. And normally, at this moment, it should work. Yes, it works. Amazing. And this is the gateway API. So basically, the idea of the gateway API is to remove any implementation-dependent configuration to just rely on abstraction. You have a question, you will save my life.
Yeah, so the question I have is, so the Gateway API spec is standardized across Kubernetes, but what if you want more functionality?
You are a bit in advance. It's a very good question. So, for example, I want now to do...
Can you repeat the question?
Oh, sorry. So the question was, like the Gateway API is standardized among Kubernetes, across all Kubernetes implementation, but what if you want more like functionality? The answer is in the couple of slides. Because, for example, with the Gateway API, you can say some crazy stuff such as, oh, we can filter, like what I did just before. I can like rewrite the stuff completely. So let's try to do it. Oops. Oh, no. So the validation control tells me, hey, what you are writing is just not compliant. Because I'm using the version like 0.5 of the CRD, and here the filtering is 0.6.2 experimental. Okay, just upgrade them. Yeah, but the implementation doesn't understand about it as of now. And it's not the end, because actually the problem of the Gateway API, so here it works. Here, I showed you, hey, you install a gateway class, you install a gateway. Well, my implementation doesn't care about it at the moment. I just did it without any gateway classes nor a gateway objects. It just works. It's the implementation. So basically, again, we become implementation dependent because not everything is ready yet. So lots and lots of products and companies are working on the Gateway API. I mean, everybody who has an ingress controller wants, yeah, yours is not there. I forgot one.
It is actually there, but it's slightly incorrect. So Blue Edge no longer is our flagship product platform.
I was being so nice having all the provider, even my competitors, and you are raining on my parade, right? Okay, I probably won't do this talk ever again, but I will update the slides anyway. Yeah, my conclusion about this is, well, at the moment, specifications are still not dry. They are still evolving, so be very careful. As you can see, depending on the minor version, you can have like some stuff working and some stuff not working. The implementation is even worse. There are different stages. So depending on which implementation you are using, you need to be extra careful because not everything is supported. And well, the limitation, probably my feeling is it will be like Ingress. Like everybody will be super happy at first, and then we'll say, oh, but this use case isn't covered. So my gut feeling is that in a few years you will have a new object, completely new spec, and it will be the next one, like from like not port to Ingress, from Ingress to Gateway API, and from Gateway API to the new shiny stuff. Because you cannot, it's very hard to cover every new use case, and we need some way of extending it, and then you will be tied to the implementation. So I was like, wow, very, very fast. Thanks for your attention. You can follow me on Twitter. You can follow me on Mastodon. If you are interested about the demo, you can check the GitHub project. I have a bit.ly, so I can check if like it's really useful, because if I have demo that nobody looks upon, that's not interesting. And if you are interested about API 6, have a look. Now we have time for questions. Any question? It can be a very good sign, like I was super clear, super good presentation, the best ever, or it can be a very bad sign, like, oh, you don't want to shame me publicly. It's a good sign? Thanks a lot.
I mean, it's pretty clear what's providing, and just it's still not there. We're all waiting for it, so it's just a question.
I'm afraid, yeah, we will be waiting for it a bit more, we will get it, and then we will start complaining again.
I'm missing scripting now. All down the functions.
Okay, thanks a lot. Have a good day.
All right. For our next talk, we have Marvin Beckers from KubeCon, who's going to talk to us about how we can run a Go debugger as an ephemeral container in Kubernetes. So, welcome, Marvin.
Thank you very much. Good morning, everyone. I hope everyone had their favorite beverage of choice that brings them through the day. So let's get started on this Sunday. I want to talk about ephemeral containers, and in specific, I want to talk about a specific use case for them that not everyone might be aware of, and I think it's quite nifty. So let's take a look if you agree with me. Maybe, maybe not. I already got introduced, so I'm a senior software engineer at KubeCon, and if you want to reach out to me afterwards, you can find me on GitHub or the Kubernetes community Slack as Ambic. Let's take a quick look. So we're going to talk about some basics. So we're going to talk about ephemeral containers as a concept. We're going to talk about Go debugging as a concept, and then kind of an extension to that, remote debugging. And after that, we're going to put all the pieces together, and we're going to have like kind of a working scenario, prototype, workflow, whatever you want to call it, and that will end in a short live demo. And I wasn't aware there was a live demo before mine, so I hope that didn't like use all the luck. So fingers crossed, this one will work too. Okay, first of all, let's talk about ephemeral containers, because they are quite a recent introduction to Kubernetes, and maybe you have heard of it, maybe you haven't. Was that me? I don't know. So as a kind of a reminder, how it is in Kubernetes, a pod is kind of an immutable unit. That means the containers you have, well, once you have created a pod, you can change them. What's in your container is the definition of what will be launched as one single unit. Okay. So that changed a bit with Kubernetes 1.25. Well.
That's hot fixing in production, right?
Yeah. Thank you very much. Okay, great. So let's continue. So with Kubernetes 1.25, the feature ephemeral containers reach GA, so it's available to everyone, and it changes the whole ecosystem, or the whole situation a bit, because now you can launch, well, as they're called, ephemeral containers into your running pods. And that is a huge change from what we've seen before, because, again, once you created a pod, you can change its container and what it's supposed to run, unless you like go into the container runtime and mess with it, but let's not talk about that. This changed. This allows us to launch ephemeral containers that run alongside our main containers on the same node. So it's also part of the kind of pod unit that gets scheduled. Let's take a quick look at the implementation, because if you're writing Go code, this might be interesting to you. So ephemeral containers are implemented as a spec field on your pod spec. However, they are hidden behind a sub-resource. And if you ever wrote a Kubernetes controller, you might have dealt with updating a status sub-resource before. There's a special API endpoint that you need to call, and it's like called ephemeral containers. And using that, you will be able to update and to add ephemeral containers. And you can see here, there's a short code snippet here from the client Go implementation. So just be aware, if you use it, you need to call like special code. So now we've like kind of established, okay, ephemeral containers, that's something that can launch into existing pods. But how do I do that? Because I just talked about the Go implementation, but I assume you don't want to write a tool or like a command line Go application every time you want to launch an ephemeral container. So let's take a look at what's already available in the ecosystem. And that is mainly kubectl debug. kubectl debug is kind of a very nifty toolbox to troubleshoot all kinds of issues within Kubernetes. And one of its features, and it's not the only one, so there are other features, is launching an ephemeral container into a pod. So that's the good news. And I can quickly show you kind of how this works in action, because here we have kind of the syntax to launch an ephemeral container. You target a specific pod, so that's the pod placeholder. You choose an image. Ideally, you also, like in this case, I want to open an interactive shell, and I also want to target a specific container. And this is a very interesting feature in ephemeral containers, because it allows you to kind of break down the isolation between different containers in a pod. And why is that useful? Well, I can show you a practical example. So in this situation, I launched an ephemeral container into my main application pod, and I targeted the main application container. And now, when I just look at the processes I have access to, you will see there's a bin app, and I didn't launch that from my ephemeral container. It's the application running within the other container, which is my main application. So now I have access to, like, kind of, I broke through some like container isolation, in this case on purpose, because that's what I want. I want my debugging application or whatever, like my debugging routine, I want that to have access to the main application that I'm trying to troubleshoot. So that's what kubectl debug already offers. However, you can't configure all the container options on it. And we'll look at that and why that is important later on. But for now, let's just look at something that I quickly wrote, quickly hacked together. It's not pretty, but it works for this talk. And that is a simple kubectl plugin called kubectl ephemeral. And this allows us to do something very similar to what kubectl debug already offers, and something that kubectl debug probably is going to implement in the future, or at least in a similar way. But I can target a specific pod. I can pass a YAML file here, and that is the difference to what kubectl debug offers at the moment, because while it's less ergonomic to hack together a YAML file, and we'll look at an example later, it will allow me to give it all the options that I want. So this is kind of a workaround for getting to the target state that I want, and this is something that we're just going to use later. So yeah. If you just want to use ephemeral containers, go with kubectl debug. I'm not endorsing this kind of hacky project in any way, but it's just, I needed it for the talk, so, you know. Okay, so that was our first building block. So that was ephemeral containers. So let's now move on to the second one, and that is debugging Go applications. Because, well, oftentimes you add a logging line to your application, and that is kind of a basic way to debug your application. If you want to get more fancy, you use Delph. Delph is, I would say, the kind of standard or de facto standard Go debugger. So it's also mentioned in the Go documentation, and it's a really nice tool because it allows us to debug Go applications. And it has a fairly typical feature set. So when you think of a debugger, you probably often need something that allows you to set breakpoints, to investigate your application state when it hits such a breakpoint, and Delph offers that kind of feature. You can inspect variables when you hit a breakpoint. You can also set conditions on breakpoints, so you don't break on every occurrence, because breakpoints are usually like a specific code line in your application. So yeah, that is what Delph brings to the table, and it's a highly useful tool. If you haven't introduced it into your workflow, I would just highly recommend try it out. It helps a lot. Now, we need to we need to talk about something because Delph has two ways to debug your application. One of them is you just point it to your code, and your code gets compiled by Delph and then executed. And that produces a debugging binary that already has all sorts of options set that allow you to, that allows Delph to properly debug your application. Now Delph has another mode, and that is attaching to an already running application. So you have a process on your system. That process is running a Go application, and Delph allows you to attach to that. So it takes control of the already running process. And this is quite useful. We are going to use that later. But we need to have kind of preparations for that in place. And that preparation, or these preparations, are a few compile flags that we want to set when building our Go application. And that's the -N and the -L passed to the GC flags on Go build. So a bit of a complex syntax, but yeah, you hopefully get the gist from the example. And this is important because it will disable the optimizations done by the Go compiler. So usually you want those, of course. This is something that usually you shouldn't disable. In this specific case, though, it will, if you don't set them, we cannot debug our application properly. So if you have a build, for example, in a Docker file, then the recommendation here to kind of get into the whole workflow that I'm presenting is to set these flags, and that will allow the application to be compiled without optimizations, and that in turn will allow Delph to attach to it later. Okay, so we had 2 of 3 building blocks, and I'm faster than I thought. That's great. So the last building block that I want to introduce is remote debugging. And remote debugging is something that is really interesting because Delph, as you just saw, it's a quite nice tool. It has a command line, like an interactive shell prompt when you work with it, when you debug an application. But sometimes that is, it can be pretty far away from your development tools, depending on how you work. And remote debugging is mostly facilitated through something that is called Debug Adapter Protocol, or DAP, DAP, honestly, I have no clue. But essentially, the idea behind this protocol, it's a wire protocol, and it allows an IDE to talk to something that is called a debug adapter. And debug adapter, according to the whole proposal and the whole idea behind DAP, is that it's separate from the actual debugger, or at least it can be separate from the actual debugger. So that means it's kind of a shim layer between the debugger and its specific implementation, and an IDE that has a generic implementation for debugging. So if you've done debugging in a Visual Studio Code, for example, then that frequently uses DAP, and the UI kind of has a generic implementation for different programming languages. Okay. So now, Delph actually supports this protocol. So this is something that goes beyond actually what DAP suggests. Delph itself has DAP implemented. So you can start a DAP server with Delph, and the whole process is kind of like I'm trying to show here how you can go across network boundaries, because you have a running application process. You have the Delph binary, the Delph process that is attaching to that application and starts debugging it. And then you have Delph Connect. And this connection is, a network connection. It's connecting to a certain port where you expose the DAP server. So that means, for example, if you tunnel that from a remote system to your local system, you can cross network boundaries, and you can debug your application as if you were on the local system, while, I don't know, your system is running somewhere. there are always like a few snippets hidden here and there. And for example, here, Delph has a few arguments that allow us to start such a server. And there's we need to tell it where to listen, and we need to tell it, okay, I want a headless debugging session. So I want a client that connects later to my debug server that I just opened. One interesting bit here is that on this port, there are two protocol implementations listening. So one is DAP, so the standard that came out of Visual Studio Code. And the other one is a Delph homegrown JSON RPC protocol. Both work, and when you run Delph Connect, it actually uses the JSON RPC protocol. But yeah, if you use a client that uses DAP, that can talk the same protocol, that can talk a different protocol on the same port. Okay. So we have three components now that we want to build together for this workflow. So we had ephemeral containers, so that means we can launch something into an existing pod, and that will help us, okay, I have this specific instance of my application that might behave weird, and I want to debug that. We have the second component, which is a Go debugger, so we know, okay, I have a Go application, so that means I can debug my Go application with Delph. And of course, this is kind of the component that you can switch out. So if you're working in a different programming language and you have a different debugger, then kind of the whole situation works by replacing Delph with something that works for you. And the third component is the remote debugging, and that will allow us to use a generic protocol to debug essentially anything as long as it has a debug adapter protocol implementation. So that's kind of the important bit. If that is a debug adapter or the debugger itself, that depends on your specific situation. So now let's put everything together. So let's run Delph as an ephemeral container. And this is where we take a step back to the kubectl ephemeral plugin that I told you about. And this is what I want to pass to it. I told you can pass a YAML file, and that YAML file can have essentially all options that a container hidden inside a pod spec has. And in this specific case, the later part, the commands, that might be something that you're not really surprised about, because, well, it's the DLF attached command with a few options. It opens up the DAP server. It allows the headless mode. And now there's one thing here that is interesting, or that's important. I talked about kind of crossing container boundaries before, and this is another situation where we also need to traverse some security measurements in place by default in Kubernetes. Because, well, Delph attaches to a running process, and that is quite an operation, let's put it that way. And usually you don't want processes to interfere with each other. So there are numerous security limitations in place usually. And this is kind of where this situation might not work on your production cluster, because maybe you have tight policies in place. But the security context needs to set the privileged flag or the privileged option. And this is quite important because otherwise Delph does not have the necessary permissions on a very kind of low level to attach to a running process. So this will not work. And I showed you earlier that we had the application process running with in the PS output. And this is also something important because here you can see the last line, you see the PID that we're attaching to. And this only works, of course, if your application started that binary as its kind of entry point when it started the container, because that is PID 1 within that container. If it's a different PID, this might be more difficult. So if there's something in the container that launches the main application, then figuring out the PID might be dynamic and might be more complicated. And this is kind of a visualization of what we want to achieve in the end. So we have our example app here on the right side. We have a Delph ephemeral container, and that container is attached to our running application. And because we don't want to expose the ephemeral container port for Delph, for the DIP implementation, and you can't really do that with ephemeral containers anyway, we are tunneling into the port with kubectl port forward. So we're opening a local port to forward to that remote port. And once you've done that, it looks like Delph is running on your local system. So you can just use Delph Connect or whatever other tool you have. And yeah, that will allow you to connect and will allow you to debug your application while running in a Kubernetes cluster. And that's potentially very far away from you. But it will mostly, like, let's assume the network latency isn't too bad, but this will mostly feel like local debugging. And one last step, because I talked about Visual Studio Code a bit earlier. So DIP mostly came out of that to kind of bridge the gap between different debuggers. And well, that means we can use our workflow that we've built so far and use it in the editor of our choice, like imagine a little asterisk there. So any implementation, any IDE or any editor that supports DIP can potentially help you here, integrating this into your code workflow. And for that, you need a specific config file, at least for Visual Studio Code. It might be different for other implementations, but Visual Studio Code allows you to configure default custom debugging options. And this is on a per workspace level. And there's this file that is called launch.json. And there are a few interesting options that we need to pass. One is the port and host, where our DIP server is listening. And because we are tunneling that into localhost, that's where we need to point Visual Studio Code to. It doesn't know about the network tunnel that we've established. And another interesting part here is the substitute path option. This is something for Go specific, because Go by default compiles like the whole file path into the binary. And we're using that kind of path to set the breakpoints. We need to teach Visual Studio Code that the environment that the Go application was built in looks different from what we have on our local system. So essentially, we're changing workspace folder, and this is a variable here that Visual Studio Code will replace for you, to the folder that your application was built in. And in this specific case, it was /build. We can take a quick look at the Docker file that I used. And there, like, kind of everything comes together. You can see that there's this work dir build. I copied all my Go code into that, and then I passed the flags that I talked about earlier to build the application, and then I copied it from that stage into like the actual container image. But it's important to note that the folder is important where you build. So it's not where the binary ends up, but it's where the application was built. And we're going to look at this in the actual live demo. But in case it doesn't work, I just wanted to have a screenshot here to prove it. So this is essentially Visual Studio Code that ran into a breakpoint. You can see that, okay, I have my code. I hit this breakpoint, and I can inspect my variables. And this is actually connected to that local debugging session. So this is running in whatever Kubernetes cluster you would like. But for me as a developer, it looks like I'm debugging my local code. And as I said earlier, it doesn't need to be Visual Studio Code if you're not a huge fan of that. I'm personally more of a NeoVim guy, and I have a quick screenshot here from NeoVim with a few plugins that also speak DIP. This is kind of like the same UI you just saw, but it's running my terminal, and I don't know. That's essentially our target state that we want to get to. And now, before we go into a live demo, I just wanted to quickly show you there is a repository that you can access via this QR code. It's like a companion repository. It has the slides, a few information about this, like the sample application that I'm going to show you later. So yeah, if you're interested, take a look there. It's available on my GitHub profile. Okay, and now let's jump into the quick live demo. Let me knock on wood. And it's the other way around. Okay, so I have a Kubernetes cluster that I am connected to. I have a sample application running here, which is a simple web server. Usually this would probably be exposed through like an ingress or a gateway. In this specific case, this Kubernetes cluster is running on my local machine. So yeah, I don't need that really because there isn't really like a load balancer implementation or something. So we're gonna just get a fresh pod because we want to make sure that nothing has tampered with this. So we're gonna make a new pod appear. And we actually need to go into this folder. So I have a pod here running. And what I want to do now is I want to use, and I'm just going to spell it right out. So kubectl ephemeral. I want to pass it the pod name, because that's where I want to launch my Delve container into. I am going to pass the YAML file that you saw earlier. We can take a quick look at that again if you want. So here is the Delve YAML file that I showed you, and we're going to use that to launch our ephemeral container. So we're going to do that. Here we go. And then we also want to break isolation between containers because we want to attach to the application. So we are going to target the sample app container inside the pod that is already running. And you can see it's a self-written tool. It doesn't give you any output. So let's check if this is actually working, because we can take a look at the pod, and you will see that it just created a new container here, and that is my Delve ephemeral container. As you can see, okay, it tried to pull the image, it created the container, and it started it. So yeah, the ephemeral container is now running. So the next step that we want to take is we want to port forward into it, and I need to get the name again, apparently. So here we go, and we're going to tunnel the DIP port that we just opened, and we're also going to tunnel the application port because, well, again, we don't really have some way to interact from the outside. Okay, so the network tunnel is established. So now let's take a look at Visual Studio Code here, because that is my application code. I am going to run the debug option here, and you can see that here the remote attach is available from the file that I showed you earlier, the launch.json. So we're going to attach. We don't have a breakpoint yet, so we're just going to quickly go over here and curl the application. Oh, yes, thank you. And we get something back here. It's a string. It says bad override. So let's assume your application was more complex and you don't know what's going on. So we go back. We set a breakpoint here because this is where the response is being written. And now the breakpoint is set. And now we're going to curl this again. And we're back in Visual Studio Code. We hit the breakpoint, and we are now in the debugging session within this kind of situation, within this breakpoint. And if I wanted to play around with things, I could even override what is going on in the variables. So I'm just going to replace this with good overrides, and I'm going to continue. And you can see here, I changed the variable, something different was returned, and yeah, that is our debugging session. And with that, I am done. So thank you very much for your attention. And yeah, have a great day. And maybe you have time for questions. I don't know if there are any.
Is there a pathway forward without security context privileged for this kind of remote debugging? Like, is there an idea on how this might work in future?
So I was looking a bit at documentation, and honestly, I think not, because it uses features within the Linux kernel that are just that generally you don't want that to happen. Like, you don't want someone to be able to like kind of interject itself into your process. So I think per kind of design, and maybe Delph changes this in the future, but I would doubt that. So I don't think there would be a way to do that.
I experimented with ephemeral containers in the past, and I got mixed results. Maybe, well, one of my thoughts was that I was trying to debug, let's say, Ubuntu container with Alpine tools. So, do you need to be cautious about that? Because I'm not really clear how do they actually merge to each other.
Pretty good question. I think that depends on the tools you want to use. So in general, I mean, lots of the Linux primitives are the same across like Ubuntu or Alpine, but depending on the tools, you might see a mismatch, yeah. And in this specific case, it's a Go application, so it's like statically compiled or fairly statically compiled. But yeah, it's a valid concern, so you need to watch out for that.
Yeah, just to add that, yes, I guess Go helps a lot because, let's say, the underlying C library in Ubuntu and in Alpine are different, and that possibly gave me that strange results.
Yeah, no, that's true. And you saw maybe in my Docker file that I was using CGO enabled set to 0, so I don't really have any dependency on the underlying Linux distribution. So yeah.
Any more questions?
What's pretty impressive to see you like set up the tunnels and starting the ephemeral container. Would there be any possibility to automate those steps from, for example, VS Code with the debug script to like select a pod and container and like do the starting of the ephemeral container and port forwarding all automatically to make it easier for the developer?
Yeah, I mean, sure, you could script this, or like I would kind of suggest to use the stock tools that we have, so kubectl pod forward and that. I'm not sure you would want to re-implement that, but yeah, there could of course be a script that like takes a few options and runs through all the steps. That would be for sure possible. Yeah.
All right, last question.
Well, I was playing it with Kubernetes 1.24, and at that time it was necessary to kill the running pod after you actually use the ephemeral container, because they're saying that it's not stable. And you mentioned 1.25. Did the situation change, or you still need to destroy the pod after the debugging session?
Actually, good question, and that was in my script, and I forgot to talk about it. The ephemeral container, like, it will not actually terminate on its own, you're right. Like, it shares the pod lifecycle, so if you delete the pod, the ephemeral container will be gone too. But if you don't, like, if you let the pod running, the ephemeral container will also keep running. So you can, like, either the ephemeral container terminates on its own because it, like, searched for debugging information, uploaded that, and was done. Or if you have a continuous process like with the Delph attach that we're doing, you would need to kill that process, for example, by opening a shell into the ephemeral container and killing it or something. But yeah, it's a good point. This is something that is still something that you need to do. Yeah.
All right. Thank you very much.
Thank you.
It's break. Our next speaker here is Alex Ellis, and he will talk to us about VMs versus containers versus Firecracker.
That's right.
Welcome, Alex.
Thank you. So, yeah, thank you very much. Very kind. We just saw a talk, if you were in the room, about using Delve. And the first thing that the guy did was run a privileged container. So I don't know if anyone else in the room here has done anything naughty like that, a little bit like, I hope, I wouldn't do this in production. And this is why I brought this talk. So Firecracker is a new approach to doing VMs. It doesn't have a lot of disadvantages because it was built in a cloud-native world. And things like privileged containers, you don't necessarily need them. And for those kinds of use cases where I'm not sure if I should be doing this in production, this might be the tool for you. So we're going to weigh in, and I know for a lot of you here, I'll be sort of preaching to the choir when I tell you about containers, but let me do that just to set the context. We'll see the pros and cons. We'll also look at the users that I know of Firecracker, so people that I know from the community, people that I've spoken to, and that I'm aware of, but there are other use cases too. Now, the reason why I know all of this about Firecracker is because I've been building a product that does CI, and containers just weren't good enough. And I'll explain why we needed VMs instead. And then we'll look at how do you actually use it, when should you use it, because this is how you might go off and equip yourselves, do a bit of experimentation. What do you actually need? So, getting straight into it. I worked at a payroll company called ADP. Some of you from the US here are still paid by ADP on your payroll. And we had these very large VMs. They were Windows VMs. They were about 20 gigs compressed, 60 gigs uncompressed. And the idea was that every week the engineering team would build this. You would download it. It would have the latest platform on it, right? And this all took far too long. And nobody was ever on the right version. Nobody knew what was going on. But we were able to run it in a traditional hypervisor, and that meant Windows, and everything just worked. Mac OS, Linux, Platform 9, no limits really. But they're very slow to start up. You're talking a few minutes to boot it. The images were huge. And also it was emulating a lot of stuff you probably didn't need just for hacking on a .NET application, like a CD-ROM drive, floppy disk. But they're really easy to use. Anything works with them, and you get an isolation level, right? When it comes to containers, really, we should probably call them formerly known as Docker, because they really did everything to bring them to this industry. And we're really probably talking about Linux containers here, rather than Windows containers. The real proposition was that at ADP, I used to have to go and ask, I'd be on a call, it'd be 5, 6 o'clock in the evening by the time the Americans had deployed to production. I wanted to go home, but instead I was asking them to email me a DLL so that I could open it and see if my change was there. So when I heard about Docker in 2015, I was really excited because it would solve that problem for me. I knew that what was built on my machine or in CI was guaranteed to be in production, right? And that's why this was so important for the industry. And then it did give us a level of sandboxing, but as we know, it only takes one container vulnerability, and there's a lot of those for that to all come undone, right? Maybe that's not a problem if you're running your own software within your own small team, running your own product in production. But for multi-tenancy, it's a bit trickier. You just don't have the level of isolation because we're using one host kernel. That's great because we're just a lot faster, right? You can even find software like Postgres pre-packaged by Bitnami, or Docker themselves, download it, run it, you're up and running in no time. Containers are also great because of the reuse, right? So you may find that one layer that has all of the Ubuntu code is already in your remote registry, and you just added Redis, and you just end up pushing 20 megs instead of 2 gigabytes. With traditional VMs, you have to push the whole thing. We have almost an instant boot because it's not really booting a system, it's just running a program. And the last thing that probably we don't talk about much is copy on write. And this is what allows us to take one image and spin it up 100 times without using any disk space, because it only the things that we change, right? Now, you might think, Alex, we know all this, we're at KubeCon, but there's a reason I'm recapping this, and you'll see that soon, all right? Okay, entry point, that's the program we're going to run. In a container, we don't need systemd. In fact, you can't really even run it properly without privileges. You then have your root file system layers, copy on write, and chroot in the Linux kernel is quite interesting. It just sort of pins you at a directory and doesn't allow you to go any higher. We get a process namespace around this, and then cgroup limits would allow us to limit RAM and CPU consumption. And then we need some kind of Ethernet bridge. So this is really what we're thinking about as a container. Now, AWS has a different view on multi-tenancy to perhaps people that have adopted Kubernetes. They're not really comfortable with taking one host kernel and putting 2 customers' code into it. In fact, what they used to do was give each customer an EC2 instance and try and deploy all of their Lambda functions within it. And then if they needed to scale, they'd have to boot up a whole one, reserve all of that VM for that customer. And then when they had relinquished control, they would wipe it with a script, kind of hacky, and they didn't like it. So they adapted something called a virtual machine monitor, or a VMM, that would allow them to start really teeny tiny VMs that didn't have all of those downsides of the traditional hypervisor. And then we get these guest kernels back, and that's what makes us feel more secure than running in a container where we're one vulnerability away from a very bad incident. So how is a Firecracker different from a traditional VM? Well, this project's at 1.0 now. It's actually a few years since it's been released, so you may know some of this. It is an instant start, almost like the container, even though it does start a kernel. If you install systemd, you can probably boot up in maybe 500, 600 milliseconds. If you go directly to your own process, you write your own init, maybe 100 milliseconds. This is quite quick. It's API-driven, whereas something like VirtualBox and ESXi are not strictly API-driven. They're very legacy. They need tools like VRO, VRA, these very expensive product suites. But here you have a HTTP API. And then rather than having a CD drive and a floppy disk, you only have virtual network, virtual disks, a keyboard that can only press the reboot key, and a serial console. Now, this might sound great. It is great because it's really limited, but actually a lot of people want to do things like GPU processing with all the interest in AI, and you can't because it doesn't have a PCI bus available, right? Finally, you can run it like a container, and I'll kind of explain what I mean by that. But like the container we had, host kernel, separate guest kernel, operating system, user land, application. Yeah. Now, Firecracker go one step further and say, right, what we'll do is we won't just run a VM, we'll run a VM in a container. How many people knew that? Just a couple. Now, this is special. So what they do is they would start that micro VM by saying it's not enough. We're also going to wrap it with a C group so we can limit the RAM and CPU it consumes, which is ideal. Platform like Fly.io, they have this shared CPU resource, and maybe you could say, like, I'm going to give you a 2.5% of a core that way. You can also allocate a separate network namespace just for a bit more belt and braces, and then it drops down into a non-root user. So normally VMs are run as root, so it can actually drop that as well. So you get belt and braces. You can go very, very locked down. So in terms of users of this technology, you may have heard that AWS are using this in Lambda now. and also in their Fargate serverless containers product. Kata Containers is an open source project that helps you run micro VMs a bit more like a container. You can actually go into Kubernetes and configure it to eventually run a micro VM instead of run C. So if that's of interest, have a look at that. Fly are trying to create a CDN for containers. So if you upload your image into their registry, they're using Firecracker to run it, not Docker. Even though you provide them a Docker image, they actually have their own system there. Koyeb is from Scaleway, or the ex-founders of Scaleway went off and built something and they thought Kubernetes wasn't the right thing for them. And they might be right. One thing that Firecracker can do is a snapshot restore in about 5 milliseconds. Imagine that. It's very, very quick, even quicker than booting up. AppFleet do edge hosting, and Liquid Metal have taken a slightly different approach. So they worked as a collaboration with Weaveworks and Deutsche Telekom to virtualize Kubernetes nodes. So I was talking about the pod and the workload, but they're actually doing the whole node. So then within that node, those pods aren't isolated from each other, but they had a different problem to solve. And this is why at KubeCon event, I'm trying to kind of show you that there's other things out there that might suit you better than Kubernetes itself for solving some of your problems. Astronomer, in early days, but they wanted to provide hosted Apache Airflow for customers, right? So this allows them to isolate it off. And again, it was better for them than giving the customers that through Kubernetes. Don't know if you know Ivan. He's got some really good container, low-level container work on blog posts. He recently created something that will probably remind you of Katacoda. Instead of using containers, you get a temporary lab with Ubuntu, K3s, anything you want to try out. And he's running them in Firecracker VMs as well. Now, as I said, there's a reason I know all of this stuff, and that's because I've been creating a product too called Actuated. And this is really trying to help people around GitHub Actions and CI. Frederick, I don't think he's here right now, is from Berlin, and he has an open source project called Parker. What he was trying to do was just build his code. That's it. Simple request. But he needs to build it on ARM and run the unit tests, the Go unit tests. Nothing special. It took 33 minutes on a hosted runner to do that. Whereas if he'd run it on his laptop, it was about a minute. So what I did is I just changed the runs on label and had that launch a Firecracker VM on a real ARM machine, and it was a 22x improvement. Right? And this is something that we keep hearing. Ed also had the same problem. He's a distinguished engineer at Cisco and works on the Network Service Mesh project. Now, separate to this diagram, there's another one I didn't include where his build took 6 hours and timed out on ARM because of the emulation, and GitHub Actions was just too slow. In that case, we got it down to 9 minutes. But I wanted to show you this isn't just about ARM. And he said that on his powerful laptop, he could build this project in 20 minutes. On GitHub Actions, it was an hour and a half. Who submits pull requests here? Nobody. Nobody wants to put their hand up. A lot of us do. Would you work on an open source project where you had to wait an hour and a half to get feedback? It would be painful, right? 20 minutes is a lot, but maybe it's viable, right? And that's what we're able to do here. Now, this is the basic idea, because this is a product. It's not an open source project. It just uses one. And it's a SaaS. The actuated control plane up there is something that we run. And as people commit, GitHub sends us webhooks. We then look at the webhook and decide what customer that is. We'll look at your fleet of machines. And just like the Kubernetes scheduler and the kubelet, we're going to score the machine for where we should place that VM, launch it, pass it a bootstrap token, and that's then used to GitHub registers, and then we're out of the way. We don't do anything then, right? GitHub's runner will do the whole works, clean it up. And finally, the thing that's great about this is it's one shot. So all of the Kubernetes solutions tend to keep reusing the same container over and over again because it's slow in Kubernetes. This takes 1 second, you're in the machine, jobs are good. And now, as I say, Firecracker's running there, and Containerd is being used to pull down the root file system for the VM image. it's quite tricky to get all of the right tools in a container image to run a GitHub action. You can ask me how I know that, if you like, later. You think you're there, and then you run your build, something fails, you add it, you run it again, it fails. And then you get a new customer, and it turns out they want headless Chrome, and there's 10 libraries missing. And so actually building and maintaining the root file system is a job on its own. But Containerd makes that very easy to pull down new versions. Copy and write file system means we're not flooding the disk. And so this is how we start to combine CNCF projects that are using Kubernetes with Firecracker to make something that looks similar. Yeah. And finally, CNI is a great way of just getting very easy button networking for Firecracker. So I've got a demo for you, and one of the things I wanted to do is regression test custom resource and see if it worked on different Kubernetes versions. Simply by changing the runs on, this will be on an ARM machine. We're going to have, we'll have 4 or 5 versions of Kubernetes, and we'll just install K3s and apply the custom resource. So this is my GitHub repository. These are my versions. I actually have a few more that I've gone for. And normally it's something that you wouldn't necessarily be able to do on hosted because it is using ARM. I'm going to commit those. And then what I've got is 2 ARM machines here. At the top, we're doing a watch for the Firecracker process. And the bottom, we've got an FS tail. And this is the VM that was it. Boots up that fast. You can't even start a container that quickly on Kubernetes. Now, we've got the 2 processes running on that machine. I've got another machine over there. We can see that's got 2 VMs on it as well. And in a moment or two, you'll see the systemd output will load the K3s service. It's doing its job. Okay. And then we start to see all of the statuses complete, sort of 30 seconds odd. Now, I've built a little bit of management around this, again, because when you don't use Kubernetes, you find that you're actually missing a lot of the things Kubernetes does for you that are really handy, like visibility. So we have a dashboard for this as well. And then to add a little bit more value, insights about how your team has been using actions across the organization. There's one other thing that was really handy for us, though. Ivan at DAX Swiss, he was having a hard time with GitHub Actions, and actually before we even met him and brought him on as a customer, you've probably had this experience too. Red, trying to get to green. He really could have done with being able to debug his GitHub Actions, and so whilst we were here, we built something that effectively connects to an SSH gateway, a managed one, and just allows you to get a SSH session into that. And it's been really handy. So when he wanted to run headless Chrome, I was able to get a shell in less than 30 seconds, go in there, install some packages, try it again, get what he needed, and solve the problem very quickly. It's also handy because I can do this on a hosted runner and then compare what GitHub is doing and kind of reverse engineer it a little bit. So far we've run 20,000 VMs for paying customers, and this is very different from the kind of work you will have known me for, if you do know of me, for OpenFAS and things like that. This is a paid product because we want to make a profit, we want to run a business that's sustainable, and that's around 60,000 webhooks over that time because you get 3 messages, it's queued, it's in progress, it's finished. Yeah. Now, the ideal user profile for this probably wouldn't be a hobbyist. It probably wouldn't be a one-man band, really probably looking at a team of 5 to 50. And the kind of person that reaches out would be a DevOps lead. Yeah. So if you want to know a bit about what we've learned, there's a blog post on actuated.dev that explains, even things like recent reliability with actions has been a bit of a thorn in our side as well. But yeah, you can find out more there. So you might be asking yourself, well, I've heard that GitHub has bigger runners. What about them? Sergey used to work at Mirantis, actually, and he found that using Docker in a Kubernetes operator, so your own self-hosted software, was actually quite hard to maintain. And we have another customer like that too. One of the reasons is the version of Docker on the host can be different to in the container. You have to make sure you've got the right permissions on it. It's a privileged container, or it's mounting a socket. Both are very bad things to be doing on company time. But GitHub would bring out faster runners, actually. And he found actuated was still quicker. So that's enough about what we're doing with it. Over to you. There is a downside to all of this, is that you're going to need a machine with KVM available. The easiest way to look for this is dev/KVM. And you may be thinking you need expensive bare metal. Bare metal can be quite cheap, actually. Hetzner have 128 gigs of RAM, 16 cores, 32 threads, NVMe for about £100, €100 a month. It's nothing. You wouldn't even get an EC2 instance with half of that for that price. You can also use nested virtualization. So DigitalOcean, Azure, there's one other cloud as well, Google Cloud. They all have nested virtualization on their VMs. So you can run this there, and it will be a little bit slower, but it will work. You do need a kernel, and you may find, as I did, that the pre-supplied kernel doesn't have what you need in it. So if you want to run Docker inside of there, you're going to have to build your own one and customize it. Not too hard, might take you a few weeks. Your init system could either be like systemd, if you want to run it like a server, or if you want a very fast boot and you just want to run a customer's workload, you can make your own simple init system for that instead. The root file system, I would suggest that you like we are very much aware of, is get a container image, get a Docker file, build it out exactly how you want it, and that is the easiest way to work with Firecracker. The two options to boot it up, one is a config file, and the other is API calls. They're just HTTP curl statements to a socket. It's very easy to play around with, and then decide what works best for you. For networking, there's a lab. If you look at the bottom here, you can also find this by Googling it and my name. CNI is great. It just works. It's very easy to use, but you can just set up an IP address as well. Yeah. And then you'll have a VM, and you're in it. It's running on KVM, and you do what you like with it. But here's the important thing. You may be missing a lot of things if you go down this route. Kubernetes is very feature-rich, and we've probably come to realize how much it actually does for us, even if, at times we complain about it. High availability, for one. Service discovery, auto-scaling, even just the capacity planning. These are all things that you will have to implement yourself if you want to use Firecracker like we're doing it. Okay. It's a very, very low-level tool. So I think one place it should be used is where containers don't work very well. So the CI, because of the security boundary, isn't really sufficient. Short-lived workloads, so this is basically what AWS say, like we built it for serverless workloads. But it has been stretched into managed hosting, as I mentioned earlier, Apache Airflow. Training and labs, we're seeing a lot of that kind of use case, so ephemeral environments. If you do need GPU support, there's something very similar actually forked off Firecracker called Cloud Hypervisor, and this is more developed by the team at Kata Containers. gvisor can also be an alternative for you if you don't need a full VM, but you do want to lock things down a bit more, right? And that will just replace itself into Kubernetes, and you may have already heard of it. So, just a very quick overview of what we talked about. Legacy VMs, we're thinking VMware, or maybe something like VirtualBox. Isolation is great. The boot speed is slow, right? And there's reasons for that. There's a lot of devices we're emulating. The disk images are huge. We have to buy expensive VRO products or VMware Tanzu to be able to use it. But the only requirement is CPU virtualization, right? Solely hypervisor, you're good to go. When it comes to cloud VMs, EC2, this kind of thing, again, similar boot speed, maybe 15 seconds to 2 minutes, depending on what cloud you're using. You have to build a bespoke image. So you may need an AMI and a VHD and something else. With Firecracker, And with containers, you can build an OCI image, and that works on every cloud, which I think makes this a lot easier if you're going to deploy onto multiple clouds. Tooling, again, like you could probably use the API of a cloud provider, a node autoscaler, or even Kubernetes itself to manage VMs. With Firecracker, you're basically completely on your own. Like, you don't have an auto-scaling group. You're going to have to do a lot of work if you're going to use it. But the only thing it actually needs is KVM to be available, right? So the nested virtualization or bare metal. Okay. All right. So if you want to send me an email about this, you want to talk about Firecracker a bit more, that's my email address. The lab to try this out and just drop into a terminal with networking is at the bottom. And there's a talk I did quite a long time ago that a lot of people have come and spoke to me about. That's available on YouTube as well, if you want a bit more information about this stuff. Okay. Thank you. So there's 5 minutes if anybody has any questions here. I will also be at the back afterwards, if you're too shy. Got one at the back first.
Great question, great presentation, Alex. Do you have a demo by chance that you can show us? Or am I putting you on the spot right now?
Did you see the demo?
No, I haven't. I might have missed it initially.
Yeah. So we did a demo of Actuated, and rather than showing you the hello world, although you can go to this repo, and you'll see blow by blow a sample Docker file, a boot script, how to set up the networking. These are the kind of curl calls that you make if you set up Firecracker on your own. You're setting the VM size, a root file system, where your kernel is, and then telling it to start. So yeah, that's what the quick start looks like. I thought it might be more interesting to show you what we built with it. So what we did is we ran a build on GitHub Actions. That scheduled a load of VMs. We saw them running on there, ran the jobs to completion. Yeah. Yes, there was another question at the front. Yeah.
Is it any harder to debug what's inside a Firecracker VM than, say, a container? Because there you would have NSEnter, for example, with containers.
Yeah, so how would you debug Firecracker process? One thing that we've been able to do here is simply, set up SSH, and then you're directly into the machine. Right? So simple solutions sometimes the best. Now, with a container, you don't usually do things like install SSH. Particularly for Firecracker, it's great. You just drop it in, start it, you're in, do what you need to do. Yeah. Alternatively, if you're running it on your own machine, you can attach to the process, standard in, standard out, and just type in. You actually just sit there and log into it. Right. Anybody thinking they might want to have a play with this at some point? Got some ideas going? That's good. That's what I wanted to do with this talk. Yeah, Ralph.
Hi, Alex. That was great. I loved it. One of the things I sort of wanted at the end was, I'm thinking through your examples of pros and cons and so forth, and since you go from things like what happens at GitHub to things like what happens in Firecracker to containers and so forth.
Yes.
At the end, I sort of want to like a generalized sense of when is the sweet spot for this? And it seems like super fast, lightweight things that happen in GitHub are really not the thing you have to worry about. It's really like the things that take a long time.
Can we put the screen back on again? So I don't know if you saw this bit, but where a container doesn't work, so there are alternative things that we might think of, like WebAssembly. I know you're really into that. But a VM is going to solve security problems where there are things that we perhaps shouldn't be running in Kubernetes, where the multi-tenancy isn't good enough, where gvisor, we still think that you might be able to break through that. And you do want that hard tenancy. So hard tenancy is a definite one. You can run those actions for 6 hours if you want, but people are running them for managed hosting. So Apache Airflow is something that Astronomer.io are trying to run as a managed service rather than using containers, because they and their customers feel better about the way it's isolated. Just like maybe a Fargate container could run for like 12 months on AWS.
Right. Okay. Thank you. That's actually a critical case that I hadn't really I was sorting out, like, you've got number 2, the short-lived workloads, and I keep thinking, okay, short-lived workload, if it's not, too much nested virtualization or something, GitHub is probably fine, except for a couple of examples that you showed where, it clearly isn't. But in clearly isn't, then the layout here makes a lot of sense. I'm like, it's an instant winner, right? So I'm not really thinking about the short-lived workloads, but the multi-tenant, hostile multi-tenancy is absolutely one of them, for sure. Thanks.
No worries. Welcome.
All right. We are out of time, so thank you very much. microphone? Yes, thank you. All right, so people in the back, we can hear you chat. They are not taking the hint. People in the back, we can hear you chat. If you are going to keep chatting, can you go chat somewhere else? All right, thank you. Our next talk, Simon will talk to us a little bit about how we can manage securely our Kubernetes secrets. So, welcome, Simon.
Yeah, hello everyone. My name is Simon Pierce, and I've come here today to talk about managing and securing Kubernetes secrets. So I work for a company called Sys11, situated in Berlin, and we're a managed hosting provider. We've been managing various types of Linux containers for the past 15 years, roughly now, and running Kubernetes since about 5 years. We've got about 400 Kubernetes clusters that we run for customers, and this number is like rapidly growing. And we do a lot of workshops and consulting with customers. And one of the questions that often gets asked is, how do I go about managing secrets in Kubernetes? And yeah, this basically brought me onto the topic to speak a bit about this and to put some research into this. How can this be done? I mean, there's multiple ways, of course, of doing this. And of course, my talk is opinionated because I've made a choice. But I would like to show you like different ways how you can do this. So yeah, let's get started. So first, a bit about me. So I already mentioned that I've been working for Sys11 since 2013. And my hobbies are anything Linux related, so automating stuff around Linux and building stuff on top of Linux. I really like that. Tinkering with my Raspberry Pis at home, so I do a lot of K3S, building containers and home automation and all that sort of stuff. And if I'm not doing that, I like to get really muddy in the forests of Brandenburg, doing cyclocross and participating in gravel events. Okay, so the agenda today is going to be Kubernetes secrets, the current situation, where are we at the moment? Securing secrets, how can you do this currently? Options for managing secrets in Kubernetes. External secrets, KMS, so key management systems. And last but not least, I would like to show you a quick demo if everything works out. So let's start off with Kubernetes secrets, the current situation. So the current situation, as most of you probably know, we have base 64 encoded files. So this basically gives us no form of encryption. It's basically anyone that has access to these files can access your secrets. So they can gain access to any tokens you may be using for repositories, access to any clouds that you're using if you're using any API tokens there, and maybe even certificates and build a phishing website or something with your certificates. So this is bad, right? They are also stored unencrypted in the Kubernetes key value store, etcd. So a lot of managed providers have already addressed this issue. They've started to encrypt etcd, which I will speak about briefly later on. But if you're running your own Kubernetes out of the box, if you're just using kubeadm or the majority of other tools to set up your cluster, you will have an unencrypted etcd. And you normally take snapshots of your etcd. Hopefully you do. I mean, I hope everyone does. And these snapshots might be in an S3 bucket, on a disk somewhere. If anyone can access these, they can theoretically gain access to your data. Anyone that can theoretically create a pod can also read secrets. So this could also be an issue. And anyone with API access can theoretically also retrieve or also modify a secret in any way. This could also be bad. So how can you go about improving this situation in securing secrets? So the number one, of course, is using RBAC. So you can use like role-based access control, you can enforce a least privilege concept, and you can use this to improve the situation. You see a lot of people, and I've also seen this, I'm afraid, a lot with people I've been talking to that just decide to hand out like cluster admin privileges. Yeah, it's easy, it works. It's definitely a really bad idea. Don't do this. Ensure that the only place I believe that you should really have like cluster admin privileges is for your CD tool or for your CI CD tool that's going to deploy and create namespace and other things. The majority of developers and people interacting with your Kubernetes infrastructure do not need cluster admin permissions to do this. You can also restrict secret access to specific containers. This is also, of course, possible and should be done. You should create your own service accounts and make sure that these have the correct permissions that they need to do whatever they need to do, but they definitely shouldn't have full access to everything within the cluster. And you can also use encryption at rest for your etcd. If you look at the Kubernetes official documentation, one of the first things you'll come across when you see encryption at rest will be to create the actual keys to encrypt etcd on the API server. I kind of consider this as something that you can maybe use for testing, but otherwise I think every attacker that gains access to your system is going to think this is a joke, right? I mean, you've gone all the way to encrypt your data and then you put the keys on the same system that you've used to encrypt. This is definitely not a good way to do it. The only thing you're really solving there is that your backups are going to be encrypted. Everything else is definitely not solved. The proper way to do this would be to have your encryption key in an external system and not within your cluster. This can be done. There are various ways of doing this. It's not scope of this talk, but there's definitely ways of doing this. And some of them are already outlined in the official Kubernetes documentation in case you're interested. So you can use an external secret store. And this is what this talk is going to be about today as well, using external secret stores for your secrets. So which options do you currently have for managing secrets? So I basically tried to split this into two, because I believe there's like two general or generic ways of doing this, which you can decide off at the end. I also favorize one, which I'll tell you in a minute, but you can, number one is you can store the encrypted secret in your Git. I mean, you have to store it somewhere. It's definitely an improvement on putting the unencrypted version into Git. In my opinion, it's still not perfect, but we'll go into detail with this later on. So it's encrypted when it's stored in Git, so you can't read it. Ooh. Okay. You decrypt it with a sealed secret in your Kubernetes cluster. So at some point of time, your CI tool is going to deploy, and then you basically need to decrypt your secret, otherwise no one's going to be able to read it. Software you can use to do this is Mozilla SOPs, or you can also use Bitnami sealed secrets. The trade-off probably here is you need to deal with another set of keys somewhere. So also Bitnami is going to need some form of key to be able to decrypt the secrets. And Mozilla's got a similar approach. So you're probably going to back up these keys somewhere else as well. So you've got something else then to deal with. It's definitely a feasible option, and it's a lot better than just like storing your base 64 encrypted secrets. But in my opinion, there's a better way of doing it. I think the best way of doing it is to only store a reference to your actual secret in Git and not the secret itself. So only the reference of the secret is stored in Git, and the secret, the same as in the first example, is then created in the Kubernetes cluster when you need it. So in general, the values are then fetched from an external secret store. So there's various ways of doing this, and I will show you one later on in the demonstration. So where would you actually go about storing external secrets? So in general, but there's multiple ways of doing this. And if you're running on one of the large hyperscalers, you're probably lucky. If you want to use these things and you're not afraid of any form of vendor lock-in, then you could definitely use something like AWS, KMS, On Google Cloud, there's something similar. There's the KMS GKE. And Azure also have a key vault service which you can use. So these will take the burden away from having to sort this out yourself and deal with it. But of course, you're basically locked in with that provider. So if that's okay with you, then fine. And another option, which I would like to show today, would be to use HashiCorp Vault. So you can use HashiCorp Vault also, of course, with Azure. They have an HCP offering as well now. But you can also use it on-prem, anywhere where you'd like to install it. It can be used. So that's like really helpful. And it's also fairly simple to set up as well. It's not like super difficult. It takes a bit of time to get your head around the way it actually works, but it definitely works fairly well. So next up with how are you actually going to synchronize the secret that you've now stored in your KMS system? So we've got it in Vault. How do we actually get it into the Kubernetes cluster itself? So also here, there's multiple software that can help you do this. There's the Vault Agent sidecar injector. I haven't actually used this myself because I don't really like the sidecar approach, because you need a sidecar, of course, in every pod to be able to do this. It definitely works, and I've talked to a few people that use it, so it's definitely good. You can also use the Argo CD Vault plugin to retrieve your secrets from Vault, or the external secrets operator. There's also going to be a talk at KubeCon about the external secrets operator, so if anyone wants to get some more information about this, please go and visit that talk. It's something about protecting your crown jewels or something. So this could also be a very interesting talk. I originally built up my talk around the external secret operator as well. But I decided to change it after a colleague pointed out to me in a meeting that there's a part of the Kubernetes SIG group is the secret store CSI driver. And there's one function that I really like about the secret store CSI driver, which I'll point out during the demo, which I think is like a huge benefit that you have here. So secret store CSI driver, as I pointed out, it's a Kubernetes SIG, so it's got a good chance of actually staying there and becoming a software that you can actually adapt and use. It's still in beta at the moment, but it works very well. So it allows you to synchronize with Kubernetes secrets if you want to. It mounts secrets to a pod using a CSI volume. And this is one of the takeaways I would like to give you. I find this very interesting and also a nice way of actually solving this problem. You can mount multiple secrets store objects as a single volume. So if your pod requires multiple secrets to run, you can do all of this in one volume. So you don't need to like configure multiple volumes to get this job done, which I also really liked. And it also supports multiple external secret providers. So all of the secret providers that I showed you in the prior slides are supported, and you can use any one, or you can even mix them as well. So you can interchange between the two, which can also make like migrating to a different cloud platform or running infrastructure on different clouds a lot more easier, because there's not much code that you need to change. And you also have Linux and Windows container support, which can also be interesting for anyone that's running Windows containers. And it's still an alpha feature, but you can also do automatic secret rotation. So if any of you have got like the needs to regularly rotate your secrets, this can also be done. And I'll show this during the demo. So this is basically, what's this happening all the time? Oh. So this is basically what it looks like, the secret store volume. So on the right on the left, we've got our kubelet running on every compute node within the cluster. This can then communicate with my secret store CSI driver. And the secret store CSI driver then can use gRPC to communicate with the secret store CSI provider, which in my case is Vault. And then you have a service account, which your pod is generally started with. And this service account can then be utilized to authenticate against HashiCorp Vault. So HashiCorp Vault has like a built-in mechanism called Kubernetes authentication, which you can then use. When the secret comes back, it is retrieved. hand it back over to the secret store CSI driver. The secret store CSI driver creates a tempfs volume. It gets mounted into the pod, and the secret is written to that volume. Once you destroy your deployment, everything goes. So this is also really good. You directly deletes everything, and there's no secrets left, which I think is like awesome. And as I said, the Vault bit can be interchanged. I just like focus on Vault here in this talk, but you can definitely change this if you would like to. Okay, so otherwise, if I didn't do some preparation work, this demo would have taken like way too long, and I would probably be standing here an hour showing you things. So I did a bit of preparation, and just to make sure that you know what I've done, I quickly want to go through what I did in the cluster. So I used the lab cluster that we have running in our cloud, and I used the Helm chart from Vault to install Vault with CSI secrets. So we have 3 replicas of Vault, and CSI secrets is enabled. I use the Terraform module that HashiCorp also provide to configure Vault. So I basically run Vault with OIDC enabled. I activated the Kubernetes authentication. So the Kubernetes authentication basically takes the public IP, your outgoing IP of your masters, of your control plane components, or the load balancer that's in front of your control plane components, and it uses this to authenticate, and it also has the CA certificate of your Kubernetes cluster. So it can verify that this is the correct cluster. Then you have an authentication role, and this authentication role is then mapped to a service account in a specific namespace. And this, again, then is tied to a policy to access the actual secret. So these can be very fine-grained, the policies in Vault. You can set them even up so you can only read a single secret. Okay, so let's try and show you a demo then. Okay. So I'll switch to the command line. I'll probably have to make this a bit bigger. Is this big enough? Yep. Okay, so first off, I'm going to install the Helm chart with the CSI secret store. This will give us the daemon set. And I'll quickly show you the values YAML. There's not much to it, really. So I just ensured that the CSI secret driver doesn't go on any of my storage nodes, which I have in the lab. And I also enabled the secret zinc, which I said was an alpha feature. And I also changed the rotation poll interval, because it's normally 2 minutes, and if it only polls the secret every 2 minutes, it may take too long until we actually see the changes if I update the secret. So just to make sure that the demo runs smoothly, I changed this. Okay, so now we should have a daemon set. So let's have a look. So we should have some pods here. Yeah, here's our daemon set. We should have a CSI driver. Oops, sorry. CSI drivers. So if you look here, there's the secret store CSI driver. This is then responsible for creating the actual volume. And next up, we also have a CRD. So we have 2 CRDs, which we also installed. So this is basically the whole installation. And I've prepared 2 mini applications. Well, actually, it's a lie. I didn't actually build them myself. Actually, ChatGPT built them. I thought I'd give this a try, and it actually worked. So, and I just deploy both of them, and I'll show you the YAML afterwards, so we get them deployed, because I need to create a certificate in the background. And I've got basically 2 versions of my application, which I would like to show you. So I'll deploy this first, and then the volume version afterwards, and then I'll quickly show you the actual YAML. So let's have a look at the YAML. So what have I got here? So I've got a deployment file. There's the Docker Alpine, which is just basically the image which I'm using with a bit of Go code. There's an ingress rule and a secret store. So ingress rule is fairly standard. I'm not going to go into this. I'll just show you the deployment YAML first. And so you can see the service account that I'm going to use in Vault is already outlined here. And you can already see that in this version, I'm actually using an environment variable, so basically standard that you already know from Kubernetes. I'm reading the web app secret value from a secret key ref, and it's web app secret, and the key is password. The new thing that you probably have not seen yet is the volume. So if you look here, I have a volume which I'm mounting here to MNT secret store. And this volume, yeah, of course, sorry. This, okay? Yeah? Okay, yeah, I can just about still see. So you can see here that I am now using the driver secret store CSI for this volume. So this is basically my deployment. And the only big change to a normal secret is this part next to the volume. So we have like a new API resource, which we deployed with our CID called secret provider class. And you can see in the spec field, if you look, I'm using a provider vault. So this can be changed against any other provider. I'm writing a secret object with the data key password, and object name is going to be web app pass. And the secret name is web app secret. You can see my vault address where I'm reading it from, and the bottom is the data that is going to go on the actual volume. So the secret path here is going to be my path in vault. This is what I actually forgot to show you, which I wanted to show you first actually, but I didn't do this, so we can quickly have a look. If you look at my vault installation, then you will see this is basically the Vault installation. And if you look at access, I have configured the Kubernetes authentication here. And the Kubernetes authentication has the 3 applications. So these 2 we're currently looking at today. And you can see that this is bound to the service account that I just showed you. So you've got a bound service account name, and you've got a bound service account namespace as well, which we're using. And underneath, at the bottom, you will see to actually read the secret, you have the policy that I was speaking about. The policy in this case is like super simple. It's just like a reader policy which allows me to read any secret. So the beginning is like the secret engine in Vault, and it allows you to read any secret underneath this. You could, in a production environment, you would restrict this. You would not allow all of the secrets under KDS. I just did this for this demonstration. So at the end, this is my secret. Here it is. So this is a secret KubeCon 2023 that we're going to see. Okay. So let's see what our actual deployment looks like. So number 1, we should have a pod going, right? So let's have a look. Deployment env, get pods. Yeah, we should have a secret. Yeah, we have a secret. Let's have a look at this. Secret. Oops. And decode it. You can see if we're decoding the secret in the namespace, you can see it's the same secret that we were using before. And we also should have, so a look, sorry, okay. And we should also have a volume here. This, of course, is the wrong one. We have a volume here, and we can also read the secret from the volume. So if we basically do a cat onto the file system, then we can see that you will also be able to see the secret, which is written to a file to this tempfs volume that the external secrets provider created. And we also should have the environment variable as well, because I said, please write it to the environment. So if we have a look at the environment, we should also be able to see it here. So this basically works as a regular secret that you would have deployed into a Kubernetes cluster as you're already doing at the moment. There's nothing different except like that you've got this specific volume here. This is the only difference. Okay, so this is done, and now I would like to show the second version of my brilliant application. And the second version is the only difference is we're also using a service account, the same as in the other one. It's only got a different namespace. It's got a 2.0 version, and the only big difference is the volume mount. So I'm just using the volume mount, but I'm not like exporting a secret here. There's no environments, there's nothing else involved. So if you look here, you can see this is basically also the same. So if we look at this, then you will see there's going to be one big difference. The big difference is that we don't have a secret, or we have like one secret, but it's like the TLS certificate. There's no secrets involved, so nothing has got written to Kubernetes. But we also have the same volume, right? So let's see. We also have a volume, and we've written the secret to a volume. So we can see the secret here and retrieve it. So the takeaway here is we have not written the secret in the second iteration of our application to Kubernetes. We've only written it to a volume. So it's not landed in etcd. There's no way of retrieving this from etcd because it's not there. The only big difference is that you're going to have to maybe change the way that your application retrieves the secret. If you're building your own applications, this should be possible fairly easy. There's also, if someone can't access into the pod, there's also no way of retrieving this secret either. So it's definitely got a higher grade of security than the first solution. But sometimes it may not be feasible. Sometimes you may still want the regular Kubernetes secret object. Then you've got both ways that you can use. The last thing that I would like to show is how can you rotate the secret. So we've got the secret here, and I'm just going to create a new version of my secret. And Kubernetes. So create a new version. And as you can see, I have like these two applications also in a browser. So here you can already see that the secret has not been updated. It's still on KubeCon 2023. It takes like a few seconds as well till it does get updated. On the second application, I'm basically just reading the file. So we should see this change in a few seconds' time. So depending on when you deployed it, of course, when I did the rehearsal, it worked really quickly. This could take up to a minute. So if the minute's just gone over, then it could take a few seconds more. But we should see this secret getting updated. So what is the big difference? The two differences are the secret in Kubernetes will get updated. But because the pod has already mounted the secret, the pod will not reflect the change. If my application is reading the secret regularly from the volume, then you will get the change without having to restart the pod in any way. So this is possible. So let's have a look and see if we can get... So you can already see here, here's the secret that I showed you from the pod number 1. So it already knows about this new change. If I go back to the browser, you should see that this application will have the new version of my secret. It's been automatically updated. But this is, of course, also, the way I built this, also bad style, because if you would do something like this... Oops! So don't do this at home. That's only for demo purposes. Here, you won't see any changes on the secret until I actually restart the pod. So there's basically, you can roll over your pods, of course. Let's roll it out and change it. Or there's also another option that I came across while I was doing some research for this talk. I can't quite remember the name of the software. It starts with an S, but I can't remember the name. Sorry, I can post it later on though. There's a pod which actually watches secrets, controller within Kubernetes, and then automatically restarts deployment. So there's a lot of software around on GitHub that actually addresses these problems as well, if you actually need to. So here we should also see the change being reflected now. Okay, so now we've done our password rotation, and all of our pods now have the new password. So this is basically the end of my demo. And thank you very much for listening and for being here today. It's been really nice to be able to present here. And do you have any questions? Is there anything that someone would like to ask? Yes?
Sorry, I guess it's a silly question. In the second... I guess it's a silly question. In the second case, when the password stored only on the volume, the password actually changes on the volume and just the application doesn't see it, or?
So the controller changes the secret on the volume, but the secret, which is also like synchronized in the first case, is mounted into the pod, so it doesn't get changed until the pod restarts and mounts the secret again. In the second version of the application just reads the secret from the volume, so it automatically gets the change straight away without any restart. Okay. So anything that's mounted statically into a pod needs to restart, otherwise it won't work.
So it's like a snapshot of
well, it's basically, I just changed like the way to retrieve the secret, basically. This is the only difference. So you probably have to, or you would have to make sure that your application does this. Either it would do it on start, and then you would also have to restart your pod, or it would do it like every 5 minutes or something. Then
okay, so if application is smart enough to change it.
Yeah, then it could just read it every 5 minutes and notice a change. Or you can even use one of these controllers you can find, and then you would also have like the same change. You just put like a label onto your secret. The controller watches the secret. When it sees the secret has changed, it just restarts the
You can monitor file events for the...
Yeah. Any other questions?
So as part of the motivation of your talk, you have mentioned that storing secrets in Kubernetes is not a good idea, right? But now you have the CSI driver running that somehow needs to communicate with the vault. So how do you manage the secret then?
It doesn't actually need a direct secret to communicate. It basically uses the Kubernetes authentication mechanism in Vault and the CA to verify that it's coming from the correct cluster. So Vault is then basically your source of truth. And then it only allows, through the policy and through the role, the app role which is configured, it only allows that service account from that namespace to communicate with and retrieve the secret. And it would be read-only anyway, so you could not change anything there. Because as you saw in the policy, I made sure that everything's like read-only. My policy was like a bit loose. It could be made tighter than I did in this example.
Hi, it's actually a follow-up question from that. How does that add security then? Because it kind of resembles sealed secrets. So if now we have a separate problem of handling that service account token, right?
Yeah, of course, you don't actually need the token itself. You only need the service account and the Kubernetes authentication. You can use the service account token on top. Otherwise, it uses basically it can use also the token API to do this. So I think the major benefit is that you're basically making your secrets external, so you can like reuse them in multiple clusters if you need to. So sometimes you have like common assets, like maybe pull secrets or certain cloud API tokens that you might need in multiple clusters. And you basically, if someone breaks into your cluster, he can't directly access everything. It's a lot more difficult to access the data than in Vault for the attacker, than having like all the secrets at once, and you can just like read them and then write them into a YAML file and take everything.
Hi, I have a question. If I have a policy of enabling a key rotation as per compliance regulation, in that case, what would be the best practice to adapt?
You have like a backup.
Just a key rotation. For example, as per the policy, the keys needs to be rotated in a certain life cycle time. Probably 3 months once or 6 months once. We need to enable the keys should be renewed as.
Yeah, so you can basically either use Vault API to renew these, or you can basically use the UI as I was using now. You would basically rotate them and ensure that the new version then gets synchronized to your Kubernetes cluster, and then you could use it there.
Okay.
So that's like one of the like major benefits, that it's like a lot more easier to rotate secrets, which I'm afraid most people don't actually do, because it becomes like a big operational task, and everyone's like, oh, what's going to break if I rotate the secret? And people just leave them like that, and yeah. Workers change, they leave the company, they may have had access to this. It's definitely a bad idea.
All right, it seems to be quite a lot of questions, but we are kind of like
invading on the the next speaker. So one last question.
So I know there are some limitations, and I will just follow up a previous question. So not every application are able to read it, let's say, from that. When there are applications, for example, with subpath, you mount it as a subpath, the volume, then I know there are limitations. And I'm interested in what is the solution to restart the pod in order to take the rollout of the new password.
So what ways are there? What solutions there are to restart?
Because this is a limitation of the CSI.
Yeah, definitely. So either, as I said, you use the second example and you are able to retrieve it from a volume, then you don't have to restart the pod. If you're using a secret which is mounted in, you're not going to get away with restarting the pod. So hopefully you've got multiple replicas, so you start them one by one, and then you can either do it like I did, which probably you don't want to do in your production environment, or you use one of the controllers I suggested and put a label on your secret, then automatically your pods are going to get restarted. Or you redeploy a new version of your deployment and add an additional label, a git commit hash or something. This will also have the same effect. It will restart the pods if you add an additional label. You can do it via CI, but there's something in your GitOps workflow, of course, that you're going to need to build in. It's not going to take care of everything. So this solves part of the problem, but it, of course, doesn't solve everything. There's always some glitch. Yeah, the CI can do it. That's why I don't really believe it's like a manual task, but it's like kind of, something additional that you have to do.
All right, thank you very much.
Okay, thank you very much. Yeah, sorry for hijacking the next talk.
Are you ready or no?
I am ready, yes.
Almost.
Just you can fire up. Are my slides up? Okay, cool.
Well, yes.
Cool.
Awesome. All right. So Abdel here is going to tell us all about the many different acronyms regarding software supply chain and what they mean and why we should care about them. So,
sure. Thank you.
Welcome, Abdel.
Thank you. Hi, everyone. So this is going to be I'm going to do a demo at the end. I'm going to show one of these tools that exists in the software supply chain security ecosystem. But really the goal of this session is to sort of level set and kind of make sure that everybody understands what we mean by SALSA and SIGSTOR and SBOM and software supply chain security and all these like buzzwords that we've been using in the last two years or so. And I'm going to try to cover the basics. This is not going to be a comprehensive talk. It's a huge ecosystem. There's a lot of tools. But hopefully you will be able to at least be able to understand what these terms mean. My name is Abdel. I'm a cloud developer advocate at Google. I'm also the Kubernetes podcast co-host. I don't know if there are any people listening here. 3 people? Okay, I'll give you a minute for the others to sign up. I'm just kidding. I've been at Google for like almost 9 years. I've done quite a lot of implementations on Kubernetes and software security, on service mesh. And this is kind of my main area of focus. Every single slide that talks about security starts with, hey, there are challenges, right? Everybody knows this. So I'm not going to talk here about challenges in terms of securing systems, because pretty much security or system security or IT security in the last 10, 15 years have mostly been focused on how can we keep the bad guys out of our system, secure in production, right? What have happened over the last couple of years is that malicious attackers or bad people who are trying to get into your system are trying to find new ways to do so, right? We all heard of these incidents in the last couple of years. SolarWinds is an incident that impacted the Intercontinental Pipeline, which is a gas and oil pipeline that supplies the US East Coast with gas and oil. And it just wreaked havoc. Long lines in gas stations, people trying to get their hands on gas because they were afraid there will be a shortage. Log4j, everybody knows that one. Next Gen, everybody knows. Everybody knows that one. I think one that is pretty much more closer to us in Europe, it specifically happened in Sweden, where I live. So in Sweden, we have a supermarket chain called Coop. They have about 500 stores across the country. And last year, I think around November 2022, they basically had to shut down the entire, all their supermarkets for 24 hours. Because what happened to them is they were using a company, a random IT company, that manages their self-checkouts and their cashiers, right? And that third-party company used a software called Kaseya, which is like a patch management and asset management software. Kaseya is a third-party company that just makes software, so that's basically off-the-shelf software for you. And Kaseya, what they did is that they basically pulled a dependency from the internet for one of their Node.js application, and they just packaged it into their app, tested it, it worked, they shipped it into their customers. So they shipped it into that random third-party company, which then just shipped it into all the self-service checkouts and cashiers of Coop, which is the end customer. And what happened is essentially that vulnerability had a backdoor, and somebody managed to get into Coop system through that backdoor, forcing them to shut down. So the reason I'm mentioning this specific example is because software supply chain kind attacks are becoming so complex in the sense that software is inherently complicated because you are depending on other people who depend on other people who depend on other people. And instead of a malicious attacker trying to attack you in your system, in your production system, which you are already spending a lot of money and resources in securing, they can just go and try to, inject a backdoor or inject a vulnerability in one of the dependencies that they know you are depending on or somebody else depends on. And the effect of this is like a nest and doll type situation, is that by injecting the vulnerability into one library, you can basically multiply your attack surface by an order of magnitude. So let's see how software is built today, right? Well, you as a developer, you basically have your editor that you use to edit your source code. Then you depend on dependencies from the internet, npm packages, APT packages, Maven, Java, whatever those packages could be. Docker packages also, or Docker dependencies, those are all dependencies. And most developers, and this is not to say that developers are lazy, because they are, but most of developers don't really give it a second thought. You just pull dependencies from the internet, you need a library, you pull it because that library allows you to do your work, and you don't really think about it too much. Now, then you package your application, and then you send it to your runtime, and then you go have a good weekend, right? The issue here is that even your dependencies have their own dependencies, right? Even the way a library is shipped to you so you can use it also uses some sort of CI/CD pipeline to be able to be available for you. It's not, the end result of that CI/CD pipeline is not an application that you run in production, it is a library, it's a dependency, right? And so that's why I meant when I said this like nesting doll kind of effect. And so this can be problematic in many ways. You could start with a vulnerable package. You write your own code. Your code is good. You're a good developer. You do good work. You have a clean development pipeline. You have a legitimate channels. By legitimate channels, I mean you have a legitimate way to take your software and then distribute it to your production systems. Hopefully, and I'm going to put you probably on the spot here, you're not rebuilding your artifact between dev and stage and production. Anybody does that? All right, good developers in the room, good. And then you end up with a vulnerable software just because you had the vulnerability to start with in a package you depended on. You could start with a vulnerable package, then get it through like a clean pipeline, but then eventually you do an update, right? How many of you have an apt-get install -p in their Docker file? Right, 1, 2 people, because why not, right? So, okay, how many of you have dependencies without tags? They don't pin dependencies to like specific version or specific commit SHA or specific. No one, really? Okay, I find that very hard to believe. Or you can start with like clean code, and you basically have a vulnerable source code. You have an internal malicious attacker. This could happen, right? I'm not going to mention cases when this happened because they are sometimes a little bit sensitive, because you end up hiring a right person, but they end up to be a rogue employee, which have happened before. But I can give an example where somebody actually managed to demonstrate that. I don't remember the names. I don't remember it was like 4 years ago. A researcher, a security researcher, managed to get commit code to the source code repository of Homebrew. Homebrew, the software that you use to install stuff on your Mac. So this researcher, in an effort to demonstrate that it's easy to become a malicious attacker, started committing legitimate code toward the open source repository, toward the Git repository, and then eventually the maintainer of Homebrew trusted this person, and they were like, well, this is a good actor, so we're just going to give them a maintainer access. This was back in the days when branch protection was not a thing on GitHub, so you could not actually say, my main branch cannot be committed to unless it comes through peer-reviewed, pull request, blah, blah. So once that person got committer access, they managed to prove, well, I could basically just commit code directly into the main branch without having anybody review my code, right? So that's an example of a malicious internal attacker or malicious internal actor. Or you could start with a clean package. You have clean code, so everything looks good, but you depend on a third-party CI software, and that third-party CI software gets hacked. Everybody remember Circle CI last year? They got a bunch of their AWS keys, and their customer AWS keys leaked into the internet. So you are dependent on somebody that you think they know what they're doing, but they don't. So there are actually, basically what I'm trying to say here is there are multiple ways to screw things up. That's because the way we supply our software from the developer laptop all the way into production is an increasingly complex system which can have multiple attack vectors. And I'm going to pause here for a second. The reason why we say software supply chain, and the reason why people use the same terminology in the supply chain for food, is because it's pretty much the same analogy. So assuming I am a bad actor and I want to intoxicate an entire city, an entire village, well, all I have to do is go to the source of water and then put poison there, right? And then eventually that poison will be filtered through the filtration distribution system and get to people, bottles, and tabs, and then I can poison them, right? I'm not saying that I have tried to do that before, but I'm just giving an example. So the analogy here is that you are starting with code that you trust. but through the process of getting your code from your developer laptop all the way to your production, you have steps where every single step, something could potentially go wrong, right? So that's the whole point here. So the question now is, now what? So I've been telling you all the problems, so how can we potentially solve these issues? This whole software supply chain security and potentially being vulnerable to packages and software that you depend on the internet started an entire movement that people called shift left movement or the zero trust movement. I dislike the term zero trust because that's coming from networking, and when you use it in the software world, A, developers don't understand it, and B, it doesn't make any sense. I like more the term shift left. So what does shift left mean? And I know every single time I presented this slide in front of developers, I see their eyes wide open because they go like, hey, uh-oh, here comes more work, right? Basically, now as a developer, I have to care about security. The point there is not that you make your developer responsible for security, but you make them aware of what they are doing. You provide them with tools that can allow them to see what they are doing, see what code they are writing, if the code they are writing is clean or not, if they are depending on vulnerable dependencies. And then also, you make sure that when they write code and package it, that they sign it so you can trust that the source code came from the right set of people. Right? My demo is going to be about that at the end. But essentially, the idea here is instead of just trying to focus all your security effort on the runtime, you try to shift some of those efforts toward the developer, right? So a few years back, a bunch of companies got together and they decided, well, one way we could solve this is try to make open source safe. And an effort called SigStore got started. So SigStore is essentially a community of developers working for different companies, Google, Netflix, etc. And then one entity called the Open Software Security Foundation, the OpenSSF, they got together and created an effort called SigStore. So SigStore does multiple things. They mainly work on tools and frameworks, right? So they have a set of open source tools that you can use to implement trust, zero trust, shift left, scanning, etc., etc. And then they have a set of frameworks or best practices. It's just a community effort. It's a lot of companies. ChainGuard is one of the main founders of SigStore, and then a bunch of other companies joined them over time. So these are some of the components they release in terms of open source tooling. Cosign is a tool for signing and verifying the signature of OCI images. That's the tool I'm going to demo later. Recore is a transparency log. So with Cosign, the way Cosign works is that you can take an artifact and you can sign it with a key. The key could be coming from anywhere, but they have a Felucio, which is a free root certificate. So you can actually use Felucio to generate a key, use the key with Cosign to sign your image. And once you do that, then the logs for this signature will be stored in Recore. Recore is just a public ledger for signature and verification. OpenID Connect is an identity server that you can use to be able to authenticate as Cosign. They have a certificate authority, obviously, if you want certificates. And then they have a root of trust for all their PKI infrastructure. So these are some of the components that SigStore releases in terms of open source tools. This is how they think their stuff should be used in the open source space. Essentially, if you're a developer doing open source tooling, you can use Felucio as the certificate authority, using OpenID Connect to authenticate to it. You use that to sign your certificates, to sign your artifacts, your libraries. The signature or the logs for the signature will be stored in Recore. Then your end user could either use Recore to search for evidence that a specific artifacts have been signed, or they can actually use Cosign with Felucio to verify the signature, right? So this could be a way to establish trust between open source developers and open source maintainers and people who depend on those open source tools, right? If you are a Kubernetes user, starting Kubernetes 1.26, every single Kubernetes image, so every single image which is component in the Kubernetes ecosystem is signed using this tool. You can go into Recore. Recore exists is like, I think, SigStore/Recore, and you can filter by Kubernetes version 127, which was just released last week, and you will find the evidence of signature of every single version. Or you can just use Cosign, and then you say, this is the image I'm trying to deploy. Was this image signed? And it will be verified for you, right? They also came up with something called SLSA. And it's not really SLSA, it's SLSA, which stands for Software Level of Something Assurance. I always forget what SLSA means, so I always have to look it up. Supply chain level for software artifacts. So what is SLSA? SALSA is essentially a security framework, a set of standards, a set of best practices that says if you have a CI/CD pipeline, a CI/CD system, which is your software supply chain system, if it meets certain criteria, then it could be identified as SALSA level 1 compliant, level 2 compliant, level 3 compliant, level 4 compliant. Obviously, the higher the level is, the more secure your system is. What does effectively mean are things like, so SALSA breaks down the software supply chain security into 4 different components: how your source code is stored and controlled, how is your system built, how do you generate provenance? Provenance is essentially adding metadata to the artifact that says how these artifacts have been built and who built it. You can think of provenance as a recipe for if you are making food. Provenance is your recipe, and then the ingredients are the dependencies. When you take your source code and your dependencies and you put them together in a build system, that's the ingredients. Provenance is the recipe that tells you how these artifacts have been built, right? Essentially, in other terms, if you have the provenance of an artifact, you can reverse engineer and go back and see who built this tool and how it was built. And then you have a bunch of common tools. And then for each level, it essentially has certain checks. Like, for example, is your build system scripted? Yes. Is your provenance available? Are you attaching metadata to the artifact that says how this artifact was built? Yes, then you are SALSA level 1 compliant, right? Level 2, your code has to be version controlled, so you have to have some sort of Git repository. Your build is scripted, but it depends on a build service, so you're not running it locally, you're running it on a remote build server. Your provenance is available, which means it's attached, but it's also authenticated, so it's signed. The provenance itself is signed because it's metadata, it's a JSON file. And then is it service generated? In other terms, you're not writing the provenance yourself, you're using a tool to generate it, etc., etc. So essentially, the more, the higher you go, the more secure or safe is your software supply chain, right? And I want to stop here if there are any questions. Actually, I think I'm going a little bit ahead of time. Go back one.
No.
Yeah?
What's the O in reproducible?
Optional. Doesn't have to be there. Because the problem with reproducible is that if you have the entire provenance of an artifact, reproducing it means you have access to all the dependencies that have been used to build that artifact, and you might not have access to those dependencies. Right? So if you're depending on a third-party software by a third-party company, they might or might not make their dependencies available for you so you can reproduce the artifact. Make sense? Then we have something called SBOM, which stands for Software Bill of Material. How many people have heard of SBOM before? How many of you generate SBOM? 2 people, 3 people, 4 people. Okay. What do you do with it? I'm curious. Like those who generate SBOM, why do you do it?
I'm in DevRel, so I talk about it.
Oh, okay, good. I am also in DevRel, so I talk about it. But the people in the back, do you generate it just because it's a compliance thing, or?
It's for the compliance and also for you get a nice overview of the basic licenses.
Okay.
You also need to ensure that what kind of third-party libraries and what licenses you're using in your application.
Awesome. Okay, so SBOM, basically, the idea of SBOM is you generate metadata of how a certain artifact have been built and you attach it. The metadata is what library have been used, where is it coming from, who built it, which license have it been deployed. Everything is in the slide. I'm not saying anything. I'm not bullshitting you. So essentially, all the package information about the dependencies. They can be generated into different formats, Cyclone, DX, SPDX. SPDX, I think, is what the format that Docker generates. So Docker has an experimental command. If you do Docker X SBOM, it will build an artifact, but it will also generate the SBOM and attach it. And so SBOM is still very early in its existence today. In Europe, there are actually some regulations called NIS 1 and NIS 2. Those are European Union regulations for certain sectors, like companies doing oil and gas, healthcare, blah, blah. They're actually forcing them to generate SBOM. They're not telling them what do you have to do with it. They're just telling them generate SBOM and just leave it there for now. There are multiple ways you could use SBOM. One of the ways I have done before with customers I worked with on SBOM implementations is basically generate SBOM and just treat it as a data pipeline issue. SBOM is a JSON. If you have a tool that can read SBOM from all your artifacts, then it can allow you to query those metadata to say, am I using a license I'm not supposed to be using? Which vulnerability, which libraries I'm depending on, which version of which libraries. It can give you a nice overview of your entire artifact store, whatever, like what am I using, right? So SBOM and Salsa work together. There are actually certain requirements in Salsa for generating and storing SBOM. So these are not separate from each other. They complement each other in a way. And I want to leave a little bit of time for my demo before I move on to the last picture, the big picture. So I'm going to show you a very, oh, sorry about that. I have to, see, this is the joy of doing things over SSH, right? Let me, give me a second. Can you see my terminal in the back? It's very small. What about now?
A bit bigger.
Bigger? All right, give me a second. Okay, cool, I have my cluster. So what I have here is I have a Kubernetes cluster, just a standard GKE cluster running on Kubernetes is 1.26. And what I'm going to demonstrate is cosign, right? So I told about cosign earlier. Cosign is a command line tool that can be used to sign artifacts. You can either use certificates from Felucio, or if you are using cloud, you can use basically any KMS, any key management system. All the cloud providers have some sort of KMS. I'm going to use Google KMS, but it would work with Azure and AWS and all the other ones. So I'm just going to export certain environment variables here, which will make my life easy. And I'm going to start by doing something. So let's say that my CTO tells me, hey, can we deploy a Docker image? So my first instinct as a DevOps person is just go and do a Docker pull, Nginx, right? And I'm going to ask you to tell me what I'm doing wrong here. So what I'm doing right, I'm just pulling Nginx from the internet, right? From somewhere, right? The most trusted place of anything you need. So, but because I am not allowed to deploy stuff from Docker Hub directly into my Kubernetes cluster, I can, my cluster can, but let's just assume I can't. So what I'm going to do is I'm going to download the image to my laptop, and I'm going to tag it to push it to my own artifact registry, right? Every single enterprise has an artifact registry, so I'm just tagging it, and then I am pushing it to my artifact registry, right? So I'm just going to wait a second and show you my image here. It's going to be pushed eventually. Yes, please. And I'm going to go, I think it's here, if I'm not mistaken. And I'm going to go to my artifact registry. So I have a container here, and I have my Docker container, which I just updated, right? So I pushed my container image, it's there, right? So now, well, technically nothing prevents me from just going here and doing something like kubectl create deployments -- image, boom. So I'm just creating a deployment, deployments, should be like this, no? You have to give it a name. So, nothing too fancy. I just pulled an image, pushed it into a container registry, and deployed it, right? I should be able to go to my CTR and say, hey, job done. I've just closed the Jira tickets, all good. But obviously, this is not how it should be. I pulled a random image from the internet. I don't know where it's coming from. I don't trust it. And just pushed it into my container registry, and then I deployed it into my GKE cluster. Now, if I want to do this properly, obviously, and I'm using Nginx because I don't want to have an app that I'm building. I'm just assuming this is an app you are building, right? So it's your own container image. So what I'm going to do instead is that I'm going to use cosign to sign my image. So cosign has a sign flag. It takes a key. You see that it says GCP KMS. That's just like a key management system for Google Cloud. It could be AWS. It could be Azure. It's just like an asymmetric. So it's a key that can be used for encryption and decryption. I'm using it to generate a signature. And then I'm passing the key name, and I'm passing the container name, right? So I'm going to do this. This is going to take a little bit of time. So basically what it's going to do is going to generate a signature for my image, and it will upload the signature and attach it to the image as metadata, right? So if I go back to my artifact registry here, I should be able to see that I have a signature which was just pushed right now. And if I look into it, it's essentially a JSON payload which has a signature, right? Just a random SHA-256, thank you, 265. So now I could verify it. I could use cosine to verify it. So this is what I mean when I said earlier the shift left movement. So when I took that image and I signed it, this is me as a developer establishing trust. I used the key to sign the artifacts. I pushed it to container registry. Now anybody who wants to deploy that container can basically verify that it was signed. So they could use cosine with the same key to see, can you verify this image signature against the key? And it says here, the signature were verified against the specific public key. So my image have been signed properly. So now I can actually, cosine has an admission controller. It has a tool for Kubernetes where you can deploy an admission controller, and then you can deploy a policy to say, before an image gets deployed, please verify the signature against the key, right? So I'm just gonna create the policy here. You can see, you don't have really to know, to be versed on Kubernetes to know what this thing does. Essentially, it creates a policy that verifies that all the images have been signed against my KMS key. It's the same key I've been using all the time. So now my policy have been created, good. I think it's probably existed before, but it doesn't matter. So now what I'm gonna do, for the sake of testing, I'm gonna create a new namespace. And you can see here, I created a namespace called test, and then I put a label on it called policy.sigstore.dev/include is true. So basically the policy exists on the cluster, but the verification will only happen on namespaces where the label have been applied, right? So now what I'm gonna do is I'm gonna try to redeploy a random image from the internet. So again, sorry, I probably have to delete that Nginx deployment I have. Yeah, then I will just do this. I will just try to deploy a random Nginx image. It should fail because that Nginx image, again, is coming from the internet. It's not going to be able to deploy because it's not signed. But what I can do is I can try to deploy the image which I signed earlier. So this is my image in my container registry. And that should go through, right? And no, so this is in the...
Can you sign it again with a different key and then try to check that?
You can sign it with as many keys as possible, and it will have to be checked against all the keys. You can use one key to sign all the images. You can use one key per namespace. In the policy here, I used a selector which says glob ***. So this essentially will apply this policy on all the images in the namespace that was tagged, but you can have multiple policies that point to multiple keys if you want each namespace to be signed with different key. Make sense? That's it, my image is running. So I have generated and I have assumed or simulated I'm a developer, wrote an app, produced a container registry, pushed it to a container registry, signed it, and then used the signature, used an admission controller to verify that that image have been signed before it's deployed to GKE. Now, I have only a few minutes, so I'm just gonna show you one last thing, and like warning, a fair warning, I'm gonna show a Google slide. It's because I'm lazy, I don't like to write diagrams, so this is gonna be our vision of how this whole thing could look like. Like, honestly, I just could not find something that has open source tools, so I'm just gonna show you our version of how this look like, but every single component here can be replaced with open source. That's what I'm trying to say. Starting with source control, Git, right? Cloud workstations, that's basically how do you prevent your developers from cloning code into their laptop. Gitpod, there is a tool called Gitpod, it's a service. Gitpod, P-O-D, literally. It's a workstation in the cloud. You clone your code in a workstation, you destroy it when you are done. No code is cloned in a developer laptop. No one can go into a developer like hotel room, steal the laptop and take code from it. Which have or might not have happened before. Cloud build, any CI tool you want to use, right? Store into artifact registry. Harbor is an open source version. Using cloud deploy, any CD tool you want. Using cosine as an admission controller, deploying into Kubernetes, deploying into Lambda, deploying into Google Cloud, deploying into whatever, right? So all of this stuff could be replaced with open source tools. For artifact registry, you can use Harbor as a way to store your images, and then you can use GraphIS, which is an open source project, to do container analysis, to look for vulnerabilities. And pretty much every other tool could be replaced with some sort of open source tool that uses something from SigStore to implement the SLSA level compliances. And I talked earlier about shift left. This is essentially what we mean with shift left, is trying to make your developers safe in their development environments. With that, thank you very much. I hope it was useful. Any questions?
So I guess you maybe explained a little bit there at the end with the shift left. But I guess for someone coming a little bit from cloud operations or platform manager, I guess I do fail to see a little bit how some of these things are responsibility of the developer. Wouldn't it be more a task for kind of like app ops or even platform engineering to build this kind of automations in the build pipeline?
Well, it's definitely, if you are doing platform engineering, it's probably platform engineering team responsibility to build the entire system, to put it together. But it's also the responsibility to make developers aware of what they're doing. Providing them with tools that can tell them, okay, you are pushing software, or you are using vulnerability, or you are using dependency, but dependency is vulnerable, right? So it's a shared responsibility. That's kind of the typical way we would answer this question. Typically, this kind of like end-to-end secure pipelines, they would fall within the responsibility of platform engineering slash DevOps team, essentially. Right?
Perfect, thank you.
No worries. Any other questions? Yeah.
So if I use GitHub, shouldn't I be able to just tick a box and say, hey, I just want Salsa 4 level, you know, and then everything is done for me?
GitHub specifically? Yeah. Or, I don't think GitHub does Salsa level 3 compliance. I think, very good question. I think part of the generating the SBOM and adding the provenance and stuff like that, GitHub and GitHub Actions doesn't do that. You will have to do it yourself.
There's a lot of automation that we know we can put in place with GitHub Actions and the CI and so on, but wouldn't it be super useful if we could just, you know, let's tick a box and, you know, everything gets signed, published, and...
It would be very useful. I think we have to ask Microsoft what they're doing. I mean, GitHub belongs to Microsoft, so maybe they know, right? But it would be useful, I agree with you. It would be useful for you to just like tick a box and have the stuff figured out for you. Yes, there are 2 questions in the back.
Where Microsoft?
Okay. Yes. Please tell him the answer.
No, I was just going to say, about 2 weeks ago, we released a tool in GitHub that allows you to generate an SBOM. Okay. That's not in toto provenance or something along those lines, but there may be that soon. But you can get an SBOM just on your repo right now. If you go into your settings, you can say generate and export an SBOM directly out of your repo. So I advise you to use that.
There you go. Happy to do some advertisement for you guys. Just kidding. All right, okay, so cool. I'll give you my bank account later. There was one question.
Oh, where?
No?
No.
Okay. Oh, okay, cool. All right, cool. All right, thank you very much.
All right, thank you. Can I have the mic? Yeah. So, folks, now we break for lunch. As I explained in the beginning, no, am I wrong? Yeah, we're breaking for lunch. Yeah, okay. Lunch is self-organized, so you have to go out, find some place to eat, and then come back for the next session. Come back. That's the only message. See you in the afternoon.
presentations. Yes, it's time. The mic. All right, welcome back, everybody. I hope you enjoyed your lunch and you had some interesting conversations with your lunch partners. Up next, we have Chris, who...
Name only.
Why?
No. That makes me more
I've been introducing people first name only, like all day. Who used to be my boss when I was at Kinfolk. His last name is Cool, because he's so cool. All right, so Chris is going to tell us about Inspector Gadget and everything about it, and how, like, using eBPF, you can learn more about what's going on in Kubernetes and not Kubernetes as well.
Okay. Thank you, Marga.
Welcome, Chris.
Who used to be the engineering manager for the Inspector Gadget project. And so, but I think this will even have new stuff for you, Marga, okay? Okay. So let me figure out how to advance. There you go. So I am Chris Cool. My wife makes fun of me because I took her name and I can't actually pronounce it correctly in German. I just say cool. But yeah. I'm a technical program manager at Microsoft. I was formerly founder and CEO at Kinfolk. What is it?
I think your mic is too far away.
Is it too far away? Can you hear me? Can you guys hear me back there? Timo? Yes. All good? Okay. So yeah, I was formerly founder and CEO at Kinfolk, and I'm one of the founders of this conference. So there we go. Today we're going to talk about Inspector Gadget. We're going to do a quick introduction, but that's not really the focus of this talk. It's we're going to look at some of the fundamentals of what Inspector Gadget does and why that has driven some of the recent features that we have been introducing. And then we'll talk at the end about some upcoming enhancements and updates that have not yet landed but will. And then we'll have some Q&A where hopefully you have some questions. So along the way, you can either ask them directly or you can wait till the end. Let's get going. So you can't do an eBPF talk unless you're at a specific eBPF conference, unless you actually introduce eBPF a little bit. So eBPF, they are programs, basically bytecode, that's loaded into the Linux kernel. They're attached to different points, trace points, kprobes, etc., and they run when events happen. eBPF programs can place data in eBPF maps, ring buffers, and then that data is then pulled out on the user space side from a user space program. Inspector Gadget takes care of quite a bit of that. eBPF programs stay in the kernel context. That means they're very fast, so there's no context switching there. And eBPF programs are safe. They run in a VM. They're basically guaranteed not to crash your kernel. They are kind of restricted in what they can do. They used to not be able to run loops. Now you can run some types of loops, and that's being expanded as they find safe ways to do that. But yeah, in general, eBPF programs are not always, but usually running only in the kernel, and they're very fast, and you can get information that you normally cannot get from the system. So, quick introduction to Inspector Gadget itself. We call it Inspector Gadget because we call the BPF programs that you use gadgets. And so you load different gadgets, and you use those with Inspector Gadget. It collects low-level kernel data, and very importantly, it enriches this data. We call it enrichment because basically when you get information from the Linux kernel, it gives it to you from its perspective. The Linux kernel does not know about containers. It does not know about Kubernetes. These are higher-level concepts that are not kernel concepts. And so Inspector Gadget enriches what it gives you by mapping these. And a little bit of history. If you've, we saw this project by Brendan Greggs from Netflix called BCC. It was basically a very large collection of eBPF programs that do many different things, and we thought that would be really good to have in Kubernetes. And like I said, eBPF doesn't really understand containers and Kubernetes, so you need some kind of mapping. And so that's why we created Inspector Gadget. And here is, for example, the famous diagram or a graphic from the BCC project showing many of the programs they have and how they are basically, the points at which they are attached inside the kernel. And you'll notice that some at the top are actually outside of the kernel because you can't have user space probes. But generally, I'm going to be talking about kernel probes or eBPF programs that run in the kernel. So we have a similar one that obviously doesn't have as many things because not everything is needed inside of Inspector Gadget, or we haven't gotten to it yet. And this shows how the gadgets that we have are, how they are associated with things inside the kernel. So let's give a little example. This is a very simple one. It's showing how you can use Inspector Gadget to see the new processes that are being started. Here we have a pod. It's called my pod, and we are running the trace exec gadget. And you can actually filter on certain columns. And so here we've basically are running we're basically running a loop that's sleeping. And so you see that in the output. We'll look at it one more time so you get another chance. Dun, dun. We're running for 4 seconds. So very simple. You can do this across a large cluster, though. Here's another gadget we have. This is a profile gadget. As you can see, we have different categories for these. The profile gadget will give you basically statistics. You can see here we're running the block IO profile on the worker node, and we're running this for about a minute, and then when you quit it, it will output this histogram. You can also get this in JSON format. So that's just 2 examples. Basically, the gadgets are built-in eBPF programs. We have 6 categories. We have the advise gadget, which is, it basically observes the system, and then it will output for example, a YAML file. We have a network policy advisor that will observe the traffic in your system, and then it will generate a network policy for you to apply. And so that's the kind of thing that advise does. We also have one for a SecComp. We have an audit category, and currently we only have 1 gadget in there, but we will be expanding that. And for example, the one we have in there will tell you when a call gets blocked due to a SecComp policy. So it's kind of the opposite of the advise one. We have profile gadgets, and these observe the system like you saw with the block IO example, and it returns some kind of statistic on it. We have one profile CPU one, which will give you the information that you need, for example, to create a flame graph. We have snapshot, which is one-off, like if you want to see the sockets that are open, the files that are open, things like that. We have a top category, which is sorted, incrementally updated table of information like you would know from a Unix top command, but we have this for different things. We have trace ones, and now the trace category is the one that is the most populated with gadgets, and it basically provides a stream of events that are happening on your system. For example, TCP connect or something like that. And then we have 2 standalone gadgets. We have a very new one that I'll be getting into a little bit later. It's called script, and that is a domain-specific language for Inspector Gadget. And we'll jump to that, so I won't say much more about that. And then we have one of my favorites called trace loop. So everybody familiar with strace? Yeah, hands, nods, good. Yeah, so trace loop is basically like strace, but it can run... It basically runs as an eBPF program. It puts the information into a ring buffer. This is kind of, we kind of think of it as a black box for your cluster. You can, because it puts this information into a ring buffer, even when the application stops, you can still pull it out. That means you can automate this, for example, to say, I'm running trace loop, my application crashed, and then you can pull that out, and you have basically the, like a black box for that application. So. And it's very fast because it's running in BPF. But I started that talk kind of like we usually talk about Inspector Gadget. We go into demos and things like that. But we've been making a lot of changes, and which has been reflections on the fundamentals for what we provide. And so I want to get into that more. So let's take a look at what the fundamentals are that Inspector Gadget does. So we have a mechanism for packaging and distributing eBPF programs. We have plumbing for collecting information from the kernel and presenting it. And we have enrichment of kernel data with high-level Kubernetes container information. This is because you don't want your information to be shown in the perspective of the kernel. You want to see it in the perspective of how you know your system, of Kubernetes, containers, things like that. And so, with these fundamental things, we basically stepped back and we started asking some questions. And when we were asking these questions, it kind of motivated us to think differently about Inspector Gadget. So, for packaging and distribution, what if we were to focus on Inspector Gadget as a means to package and distribute eBPF programs, and not only the ones that we build in? How would supporting, would supporting only Kubernetes be enough if we were to do that? And how could users create custom gadgets? So they can basically create their own gadget and then use the plumbing, the enrichment that we have to basically plug into that. Plumbing. How could we make maximum use of the plumbing layer? And how can we provide additional ways of interacting with it? And again, why only Kubernetes for this plumbing layer? And lastly, enrichment. How can we make this enrichment as general as possible? And many eBPF tools exist that know nothing about containers and Kubernetes and are very useful. So can Inspector Gadget be a general enrichment tool for eBPF programs? And so, from that thinking, we actually have been adding features, and all of this actually landed in. Actually, 2 of these have landed already. One of them will land in the next week or so, and another one within the month. So we have custom eBPF programs, which we are introducing. We have a domain-specific language, which we have introduced. We have IG, which is the CLI tool for Linux host without running on Kubernetes, and Prometheus metrics and gRPC API. And so let's talk a little bit about each of these. And warning, like I just said, this does contain forward-looking statements. Not everything is stable. Not everything is. Everything I'm talking about is actively being worked on. And so even the things that have landed are in an early stage, and I'll point that out. Or they are in, it's basically a development branch and will be in the main branch soon. So, custom eBPF programs with the BYOB gadget. It's not bring your own beer, it's bring your own BPF. And this allows you to write your own eBPF programs and use them in Inspector Gadget with the enrichment, etc. It uses Solo IO's Bumblebee project, because what Solo IO's Bumblebee project does is it basically can take BPF programs and put them into OCI images, which we thought was pretty interesting. And so this uses OCI images, and it will, we're first implementing this in the trace gadget. So each category that I was introducing before has a certain way that it works, a certain behavior. And so we need to make sure when somebody creates a custom gadget that they identify which behavior that should match with and put it in the right thing. So generally what you'll see is the category trace, for example, and then with BYOB for the gadget, and then just like this. So, and you actually notice here in this command line, this is using IG, which is the Linux command line tool, and not the kubectl gadget, which is what you interact with Kubernetes with. It's just easier for testing. And so we use IG trace BYOB, and then you define the OCI image, and in this case, it defines the example image that the Bumblebee project has called TCP Connect, and it's defining it as use the Docker runtime. And so it is loading this, and then here you can see their destination and source addresses. And so this is a custom eBPF program running in Inspector Gadget with the needed enrichment. So there's quite a bit of work to do there. That has not landed in main yet, but this is one of the things I'm quite excited about. So, because eventually this will also be plugged into the Prometheus exporting, and other ways of interacting with it. So scripting via the BPF trace integration. So there's a project called BPF trace, which is anybody familiar with dtrace from Solaris? Yeah, so BPF trace is a way to kind of relive that on Linux in the Linux world. And you know, there's a project called KubeCTL trace, which also provides this functionality of it basically exposes BPF trace, a scripting language for BPF programs. And the kubectl trace basically exposes that to Kubernetes, right? But even the kubectl trace doesn't have any concepts of containers or Kubernetes. It just basically gives you the process ID and things like that. And so in this first, what we already have in the main branch, it's basically just using BPF trace programs, just like the kubectl trace was. But this will in the next phase of this, we will be adding the enrichment so that you can you reference containers, you'll get back information about the Kubernetes cluster, etc. So this will be, you know, basically a scriptable way to interact with Inspector Gadget and use its enrichment and plumbing.
So it's not its own DSL, it's BPF trace DSL?
It is currently, the question was, is this its own DSL or is it just BPF trace? It is currently one-to-one BPF trace. The next phase will add a container and Kubernetes enrichment, which will then diverge, and we, you know, and then we are actually, the last line here says we'll build this out based on feedback. So I think there's going to be a lot of interesting stuff that we can build actually on top of that, because we have multiple gadgets working here, and it might be that we want to tap into another gadget, or I don't know how that's going to work, but we'll, you know, that's something that I think is already very useful to just do the scripting with the enrichment. Just that is very useful. Anything we add onto it will just be, you know, the jam on top. All right, so here's an example of this. So this is like counting the syscalls for a program, by program. And so here we do gadget script, -E is basically giving it the script, and here's like a one-liner. You can also have files with longer of these. And the BPF trace project has a bunch of these. And so you can just copy-paste and use those as is. So, you know, this is just an example. It's script, so you can do what you want to with it in the limits of, you know, what it has. And we're learning more about those limits as we go along and trying to expand that. So, and the last main thing here that I have is IG. It's very confusing in the project because we often refer to the project as IG also, but we've started referring to big IG as the project and small IG as the CLI tool. So it's a little bit confusing. But now you can run this. This basically works on Linux hosts. The previous only way you could use this is with kubectl gadget, and that would basically send an API call. It basically works over the Kubernetes API server. This now runs directly on Linux hosts. It does the enrichment with containers and Kubernetes. There are some limitations now, but this is very early and being built out. But in general, it works very nicely, and you have access to the gadgets that make sense. There's some that don't make sense, and so they're not included in the IG thing, like the advised ones, because you should be running on a Kubernetes cluster for that. But in general, this is quite nice. So yeah, we had people asking us, okay, how do I use this when the API server is down? Of course, if kubectl gadget relies on the API server. And at first we were saying, well, yeah, you can't use this. But then we started thinking, and we had this tool called local gadget, which we were using for debugging and testing, because a lot of times you don't want to spin up a Kubernetes cluster just to test a change in one of the gadgets you rewrote. And so that conversation and that tool that already existed, you know, kind of those ideas came together, and that's where IG came. And so, in the converse to the other tools where we're trying to add enrichment, with this tool, because we want to run on host, we are actually doing the opposite. We are going to be adding host process support because, you know, for those who know about containers a little bit, host process is, you know, similar to containers, is running also in a namespace in C groups. They're just the default for the system. So we should be able to, you know, this is very interesting because basically it gives you one tool that understands host processes, containers, and Kubernetes. And so that's going to open up a lot of interesting things. And for the last release, we packaged this for Debian and Fedora-based systems. If you are a maintainer of a distro and you would like to include this there, that would be, please talk to me later, or just do it. So yeah, with these changes, and the introduction of these, especially IG, Inspector Gadget project will have support across Linux hosts, processes, containers, Kubernetes. And, we had a conversation the other day in the project about, you have these tools like, you have top, you have kubectl top, you have Docker stats. They're all specific to these domains. With this kind of functionality, there's no reason why we can't have something like IG top that basically gives you all that same information across every single bit of this and understands if it's running in a Kubernetes cluster, or if it's just running a standalone container, or if it's a host. So it's quite interesting what this is opening up, just starting as we start down this road. So, and the last thing, which is being actively worked on, because we're trying to make sure we do the Prometheus metrics part right, is that we're trying to add, expand how users can interface with Inspector Gadget. We've added a gRPC API to make it easier to, build things on top of Inspector Gadget. And then we had a lot of people, Inspector Gadget was originally an interactive tool, and usually that's often how you use it, on the command line or whatever. But there's no reason why you can't get that information from these gadgets in a long-running process and collect metrics from them. And so what we're trying to do now is we're well on our way actually, is adding Prometheus support. And so we're quite excited about this because we've had a lot of folks asking for it. And it will support like the filtering, like how you can filter columns. You can just say, okay, just give me this information, and it does the enrichment. And we want this to work also with the custom BPF programs, the BYOB stuff. And so we are actually, it's kind of selfish because we have another project we work on called Headlamp, and we're going to be using Inspector Gadget under the hood to get a lot of information on that Kubernetes UI. So these are the kind of things that we need in that, and other folks have been asking for. So, and some other small, or not small, because all of these are a lot of work, we are still expanding the, what is it? Is all good? Okay, so we are still expanding the collection of built-in gadgets. Network gadgets are something we're focused on right now. We just added one for TCP drop, for packets that are dropped. And these are things we add, like you usually get like once every month or two, because we're working on a lot of other stuff. And this is, we work on those and make them, kind of expanding the scope of the built-in gadgets that we have. But one very interesting thing, because we work at Microsoft, we have some folks with very large clusters, and so we want to understand, for example, where Inspector Gadget breaks. What's the performance limits? How can we improve those and optimize them? So we just added benchmarking to the CI, and so we want to use that as a baseline for making optimizations going forward and measuring, so that we can see how this improves or degrades over time. So. And Inspector Gadget has been submitted to the CNCF, and we actually got the votes we needed, but there was another process after that to make sure it's all good before it can actually enter. So we're happy about that. And basically, we want to make Inspector Gadget a uniquely complete tool for eBPF systems inspection. Thank you. Q&A. Questions?
Yeah. It reminds me of Sysinternals by Marko Zinovic. Have you been able to talk with him or, maybe sit with him? He might have some ideas.
You mean our CEO? I mean CTO?
I don't know what his role is, but I know he wrote
I have not myself, yeah.
Okay, well, he might be, from his personal perspective, I think he would be interested in this project.
Yeah.
I don't know about his role. I left Microsoft a long time ago. So.
Okay.
And another question is, do you still need another kernel for this? Or is there, you mentioned something about Debian?
Yeah, it's pretty easy nowadays because a lot of people are using eBPF, and it was a problem that was like, okay, is this going to work on this kernel? Do I have to compile it for that? Nowadays, and Marga knows this just as well because you were leading the project at the time, we had some engineers who basically were part of the team who were basically improving the situation. So now you basically have this like compile once, run anywhere kind of thing, and so it's not really a problem anymore. We have what's the tool called, Marga? The
BTF.
What Mauricio was working on.
Yeah. So the tool relies on BTF, and the tool is
yeah.
BTF lib.
Yeah, so we've integrated with BTF tool, and that's all upstream, and like it's like a whole. It's not just us; it's the whole ecosystem is working off of that. So, yeah. Alex.
Of your end users that you're talking about, what are they doing with Inspector Gadget or with eBPF programs that they're writing through this?
Say it again. Sorry.
What is the use case for Inspector Gadget? What are your end users doing with it?
Well, a lot of it's troubleshooting, troubleshooting issues. If they suspect something's happening, you can basically, if you pull up, I don't have the list of gadgets here, but we have gadgets. We have like 20 or so, and they can all look at different things, right? You can see, Block IO will tell you if you got something slowing down. You can, So it's basically a lot of various. Debugging and troubleshooting is what they're using now.
Is this only sort of reactive, or are you going to have like proactive monitoring? Think about what
So this is what I would
does, for instance. Are you going to be playing in that space?
Yeah, that's what I was saying. It's been traditionally more of an interactive thing, or something where you fire when you want to inspect something. But with the introduction of the Prometheus stuff, then that's going to be more of something running in the background and collecting information. And also with IG, we are already talking to teams who are looking to use this as part of an agent that's running. So yeah.
Last question. I'll let this microphone go. Are there any privileges that you need to be able to install that eBPF program?
Yeah, I mean, these run as privileged
containers.
Yeah, you have to. Yeah.
So you can just have eBPF on its own. You don't need a privileged container, or is that a Linux capability you can just add with a granular level, or do you have to go for a privileged pod?
Yeah, Margaret, you want to answer that?
So to install BPF programs, you need CAP BPF, and then you also need CAP sysadmin. So basically you need privileges.
Yeah, you're not going to get around that. So we do run it in our gadgets, and the Kubernetes cluster in its own namespace. So that's a little bit isolated there.
So if I understand that correctly, you're trying to actually ramp up transparency, making it more convenient on Kubernetes level to monitor and debug all the stuff that's lying on infrastructure levels. Have you found any boundaries there yet? I mean, there are a lot of stuff in infrastructure, storage, all that stuff. Is it just like on a VM level right now?
Well, I mean, anything that's happening in the kernel that you can get from a BPF program, you can, if it doesn't exist, you can access it. So, I mean, that's a lot of stuff. So if you're creative, you can usually get your hands on what you need if you're looking for something. And generally, BPF is so popular now that generally there's something written already that you can pull from another project or collaborate with other folks to, expand existing stuff. So, yeah.
Any more questions? Looks like that's it. Thank you, Chris.
Thank you, folks.
Stickers on the tables.
So.
All right, it's time for our next talk. Dotan will tell us about what's new in open telemetry. So welcome, Dotan.
Thank you very much. Hey everyone, glad to be here and see everyone here at Cloud Native Rejekts, and in general a great way to start the KubeCon week. And today I'd like to talk to you about what's new in open telemetry. But just out of curiosity and to get to know you, how many of you are familiar with open telemetry project? With a show of hands. Amazing. Leave your hands up. How many of you know what it's about, the main component, specification, protocols? Very cool, very cool. That's a great improvement from last year when I was at KubeCon on stage talking about open telemetry, much less familiarity, so great to see that. And a word about myself. My name is Dotan Horvitz. I'm the principal developer advocate at Logs.io. Logs.io provides a cloud-native observability platform that's built on popular open source tools such as Jaeger, Prometheus, OpenSearch, and obviously also OpenTelemetry. I'm an advocate of open source and communities. I'm a CNCF ambassador. I co-organize the local CNCF chapter in Tel Aviv. If you come around, do join our meetup. Kubernetes Community Days, DevOps Days, and many more. And I invite you to check out my podcast, Open Observability Talks, about open source, DevOps, observability. If that's your thing, check it out. And let's talk about why, just briefly about why we need open telemetry to lead to the roadmap. And obviously, the story starts with observability. We all know observability as the ability to understand the state of our system based on the telemetry, based on the signals that it emits. And typically, people talk about logs, metrics, and traces, although these are not the only signals, as we'll soon see. So across different signals, but also across different sources. So think about your front-end application, back-end code. Think about infrastructure components, I don't know, your Kubernetes, your Docker, your Kafka, Redis, whatnot. Essentially, even cloud services, and then fusing them all together to gain insight into what your system is doing. That's the essence, that's the vision. But the reality is, unfortunately, much more fragmented. And the reason is that most of us use many tools for observability. If we look at recent surveys, people reported their organizations use between 5 to 10 different tools. On average, some more than 10. And the problem is that each vendor and each tool has its own API and SDK for instrumenting the application. And then and think about your Datadog SDKs and your Splunk and your whatnot. And then its own agent, daemon, collector, each one with its own name for collecting, aggregating, doing some sorts of processing, manipulations. Then its own data model and the protocol to transmit it to its backend. And all of that creates, first of all, a headache operationally, running so many tools, but also creates vendor lock-in. It creates tight coupling between the collection side, the telemetry collection, and the storage and analytics backend, so you don't get to choose what's right for you. And most importantly, going back to the observability, unified observability, it creates data silos, which makes it very difficult to ask and answer questions across your system that cross these data silos. And this is exactly what OpenTelemetry comes to solve. So OpenTelemetry, in a nutshell, is an observability framework for generating and capturing telemetry data across logs, metrics, and traces. So essentially, one framework to rule them all, if you like. On the collection side of things, it doesn't have any stake in the backend analytics side of things, so just generating and collecting. It's an incubating project under the CNCF. In fact, it started off as a merge of Open Tracing and Open Sensor. So if there's anyone who's familiar and still using, time to move to Open Telemetry, they're deprecated. It joined the CNCF sandbox back in 2019, then to the CNCF incubation back in 2021. So it's been around for quite a good few years. And now that we have the baseline of, okay, we understand what's Open Telemetry, let's start the what's new with the project adoption and activity. And actually, there's a fascinating report that is supposed to be published this week. At least that's what the CNCF's CTO promised me, Chris Anacek, that talks about the project journey for Open Telemetry from since it joined back in 2019 and until today. And I'm going to show you some nuggets of that. I think the most impressive thing that I saw out of this report was that this is today the second most active project in the CNCF. And you know how many projects there are in the CNCF, right? And it doesn't fit the screen. But that's the second most active, the first being Kubernetes itself. So you see this little circle here, the blue circle is Kubernetes, and that one is Open Telemetry. I don't know if you see my laser point, but never mind. The red one is Open Telemetry, very impressive. And indeed, for those who did something with Open Telemetry, you probably saw that. It's been adopted by all the major vendors. Adopting it to their own offering, and also getting involved in the project itself, which leads me to another very interesting thing out of the survey. You can see here the company's contribution to the project, and you can see here all the major players. You see all the cloud vendors, obviously Microsoft, Amazon, Google, and others. You see all the monitoring and observability players, the big ones, Splunk, Datadog, Dynatrace, New Relic, whatnot, and many others, even end users. So you see all of them definitely active, and in general, this is an immensely active project. So very, very encouraging. If we want this to become a de facto standard in the industry, that's a good indicator for that to become a standard. And another interesting thing outside of the report that I mentioned, the CNCF's report, is actually this one. This is this to show that analysts starting putting it on their radar. And this is from last year's Gartner report, the Hype Cycle for Emerging Technologies. And you can see here Open Telemetry with the arrow on the innovation trigger. And more interesting, you can see that Gartner foresees that this will reach the plateau of productivity, that area, within 2 to 5 years, which just shows you how fast Gartner believes that this project is moving forward. So that's very impressive. And I know that many of us here are engineers. What do we care about analysts? What they're saying? But I have to tell you that in order to get buy-in within large organizations, enterprises, and so on, for new technology, not the IBMs of the world, you need to show something written from analyst reports to show that this is backed by something written by the authorities. So I hope that this will help push OTEL also into enterprises and large organizations. So really, lots of good stuff. As I said, the report is coming out soon, hopefully this week. And until then, if you want, you're all invited to check out my latest episode with CNCF's CTO on Open Observability Talks. He gave off quite a bit of interesting bits about Open Telemetry as well as others. So all invited to check it. And now, before I move to the technical updates, I want to just level set the knowledge of the main components so that I can refer to them in the updates. I'll do that briefly because I see that most of you are familiar. But essentially, Open Telemetry, in a nutshell, is what you see here. It provides a unified set of APIs, SDKs, and tools for generating telemetry out of your project. This is the bluish part on the left-hand side. And then a unified collector, a way to collect telemetry from application and from infrastructure and process. And this is the green part. And then a standardized way to represent and to let's say, transmit it to any backend that you wish. So that's OpenTelemetry in a nutshell, and let's quickly go over each one of these pieces because it's important to understand. First, before the components, there is the OpenTelemetry specification. That is not a component, but it essentially governs all the, it provides sort of the specification for the cross-language requirements that each and every implementation needs to adhere to. So it includes the API spec, the SDK spec, and the data spec, things such as semantic conventions and so on, for traces, metrics, and logs, so across the signals. And this comes to solve the pain that we talked about before, the fragmentation problem, that each tool and each vendor and each programming language has its own way of doing things, non-consolidated. And another thing that it comes to solve, once you have everything under one data model, it's very easy to correlate. Okay, so this is not a component, but it's very, very important to be familiar with that. Then there are the client libraries. The client libraries, essentially, OpenTelemetry provides you with one API and one SDK per programming language, with which you can manually instrument your code. So you add bits into your code like you do with logging, if you remember, just putting a line saying, send this log line into this. So this is the manual instrumentation way of doing things. In addition, the client libraries provide language-specific integrations with popular web frameworks, RPC libraries, storage clients, and so on. So they can instrument these libraries that you use within your programs. And also, some languages offer auto-instrumentation agents that can automatically instrument your code to a certain degree without you having to modify the code. So that's in essence, and as you can see, OpenTelemetry aims to provide the full range from fully manual to fully automatic and anything in between, essentially. So that's the client libraries, and by the way, the automatic instrumentation is not just a nice-to-have way of starting to instrument your code with a low barrier. Sometimes it's a must-have. If you use, for example, third-party code or libraries that you can't actually modify the source code, this is a must-have. So auto-instrumentation is a lot of emphasis is put on auto-instrumentation, as we'll soon see. So that was the client libraries. The next component is the OpenTelemetry collector. And the collector essentially can collect data from the SDKs we talked about before. It can transmit them to the collector. It can, and you can see it's built like it's a general purpose protocol. Okay, it can collect from the SDKs and also from infrastructure. You have Kafka, you have Redis, you have MySQL, whatnot. It can collect it in a uniform manner, and it's built like a data processing pipeline essentially. So you have multiple receivers in multiple protocols, multiple processors, and then exporters in multiple protocols. So if your application emits distributed traces in a Jaeger format, you just plug in a Jaeger receiver. If you have a Kafka, you plug in a Kafka receiver. You have a Redis or whatnot, Prometheus receiver, and so on. Then you have processors to do all sorts of processing, filtering, batching, sampling, anything you'd like. Of course, you can also chain different processors to get more elaborate logic. That's the processors. And then, depending on your backend, you will plug in the right exporter. So you have exporters to cloud services like AWS X-Ray, Azure Monitor, Google, obviously the traditional monitoring tools, Splunk, Sumo Logic, Logs.io. You have open source, of course, Prometheus, Jaeger, Zipkin, and many others. Just plug in the right exporter, and you're done. So that's the collector in a nutshell. And the last component that I would like to talk about is the OpenTelemetry protocol, or OTLP, which is a general-purpose telemetry data delivery protocol. You can use it to send data, the telemetry between the SDKs and the collector. You can use it between the collector and your backend analytics tool or any other intermediary nodes. It's really general purpose, client-server, request-response protocol. As you can see, it supports either gRPC or HTTP 1.1 on the transport layer. So you have OTLP over gRPC or OTLP over HTTP. It supports binary protobuf encoding or JSON protobuf encoding for the encoding side, and obviously the encoding is done based on the data model in the specification. So we use the same semantic conventions, the same data model that we defined in the specification. One note that's important to say, using OpenTelemetry, you're not mandated to use OTLP. We saw before, I showed you before, that the collector supports multiple protocols on the receivers, multiple protocols on the exporters. Also, the SDK, by the way, knows to export in multiple protocols. So you're not forced to use that, but OpenTelemetry, as a mission statement, wants to provide a holistic framework that includes the protocol and to enable the correlation. And in general, that's the philosophy of OpenTelemetry as a project. You can use the SDK without a collector. You can use the collector without the SDK. So it's a loosely coupled project, yet a holistic framework for generating, collecting, and communicating the telemetry. So that's really much in a nutshell the main components. And now I would like to talk about the let's see. Yeah, now that you understand the components, let's talk about some updates, and let's start with the main signals, the logs, the metrics, the traces, and understand where each signal stands. And the most mature signal of all is traces, that is already generally available or stable in the CNCF terminology, which means that the API, the SDK, the protocol, the collector are all stable. There are many client libraries that are stable, that version 1.0 or above. You see the languages here, Java, Go, .NET, Python, and more and more. And the most important thing for you is that stable means that it comes with guarantees for long-term support, backwards compatibility, dependency isolation guarantees that are the things that you'd be looking for if you want to run this in production environments. So that's traces. Next up is metrics, that is in a release candidate. It's been announced at KubeCon last year. And so it's expected to be generally available very soon, so stay tuned. And it means that the API, the SDK, the protocol are already stable. The client libraries are already stable in multiple languages. You can see here Java, .NET, Python, JavaScript, C++. The collector supports metric pipelines. And very important, we all know that Prometheus is the standard way of exposing metrics, essentially, open metrics for those who are familiar. So it supports fully the in collaboration, by the way, between the groups, between the Prometheus community and the OpenTelemetry, they reached a very nice collaboration. So the SDK of OpenTelemetry can export Prometheus format. The collector has receivers and exporters in Prometheus format. There is a Prometheus to OTLP data model specification alignment. So we're there. The least advanced is logs, that is still experimental. Although some pieces are already stable, like the protocol. And logs, because logs is the most well-established, let's say, telemetry. Everyone has logs from everywhere and from third parties and libraries and tools, and we can't really decide that we're reinventing the wheel. So the first phase and the first focus was to integrate with existing logging systems, logging frameworks. So that was the first focus of the OpenTelemetry project, meaning that you can, for example, fetch logs and transmit them over OTLP protocol. You have log appenders under development that allow essentially to append trace data like trace ID, span ID, appended to existing logs. So this is the first focus. The second focus is to actually create, the longer term, is to actually create a new strongly typed and machine-readable logging format. And that's very important, because for true observability, these flat files, unstructured, is not really, doesn't lend itself for observability. So this is what the project aims to do in the long run, and this is already in the making. As I mentioned, the protocol is already stable, which means that the data model is there, the OTLP already incorporates the log piece into it in a stable fashion, and this is something that is going to be very interesting. If you are interested in logs, I would get involved in this discussion. Very, very interesting. So these are the main signals, and now let's talk about what else is new beyond the main signals. And first up is going beyond logs, metrics, and traces, and venturing into new signals. And the first signal that the community identified is continuous profiling. Continuous profiling, just so you know, traditional profiling, getting the CPU, memory, disk usage, but on a continuous fashion, so that you can identify trends, and then you can segment and break down by instance, by version, by function, and so on and so forth. This is the next, and there's already a very active working group looking into incorporating that. Next up is the wrong button, is real user monitoring support. So up till now, the main focus was around server-side telemetry. And obviously, you could do client-side instrumentation. You could take the JavaScript SDK and instrument your client-side code. But we didn't really have representation of entities that are client-side by nature, like a session ID and things like that. And the typical questions that you would ask around real user monitoring, such as how many new users versus number of returning users, identifying pages that generate high number of errors, counting conversions from homepage to purchase, all these sorts of questions require entities in the schema, in the model, that are not there at present. So there is this work around the client-side telemetry, very interesting to look into. Next up, and glad to be after the previous talk talking about eBPF, because now you're all experts in eBPF. So eBPF, you understood, is a program that we can inject essentially to run in the kernel space, in a kernel level. And in the context of observability, that opens up a whole realm of opportunity to do auto-instrumentation without having to modify the code, in the code level, in the programming language level. And the first success story for that is the Go language, Golang. For those who know, how many know Go? Okay, we have a bit less than half. So Go, for those who don't know Go, is a very, very problematic language in terms of injecting. It doesn't have any hooks or ways to inject. Where essentially the program in Go just packages everything in it. It comes bundled, but then if you want to, for example, introduce an auto-instrumentation agent, it's not trivial at all. So, for example, having the eBPF as an option to do that one floor underneath, let's put it this way, that was a great success, and there's a SIG, special interest groups for Golang auto-instrumentation that makes use of that, and and more languages are looking into that. So eBPF auto-instrumentation, very interesting. Next up is ease of operation. So as more and more organizations get to use that in production, we need to think about day two. We need to think about how we manage that. And obviously, we have already, for those who don't know, OpenTelemetry already has an operator, a Kubernetes operator, operator. But this is just the deployment side. Next up is to get remote agent management. So we want to be able to update configuration of the agent. We want to be able to monitor the agent and see where they stand, what's the status. All of these are elements that are part of the remote agent management. And the most important activity around that is what is known as OPAMP, which is Open Agent Management Protocol. I wrote it down so I make sure that I remember what the initials are about. And a lot of active work around that. It's already the specification, the protobuf schema already available, version 0.7.0, implementation already in Go, in Golang. There's the OTel operator already supports OPAMP, so a lot of activity around that. So if you are looking for ways to deploy in production at scale, this is a very interesting initiative. Next up is OpenTelemetry demo that has reached GA. So now you have a full-fledged demo of a distributed system that is 100% instrumented with OpenTelemetry for traces and for metrics. Very interesting and a very good way to start engaging with the project via this demo. So lots of more updates. I won't get into that, but essentially, if you want to read more about that, you can check out my post on the CNCF blog that summarizes these and gives more information, also where to follow up, what's the working group, relevant working group, Slack channels, and so on. I also invite you to join now during KubeCon Thursday. There's going to be the project update talk. So check it out. And also, day after tomorrow, Tuesday, I think it's around 4 p.m., we're going to have the maintainer meeting where you can actually join. You can discuss the roadmap, talk about how you use OpenTelemetry, what you need out of the project, and so on. So definitely interesting. So Tuesday for the meeting and Thursday for the project update talk. Highly recommended. And the last point that I want to say is how to get started with OpenTelemetry. And I know it can be confusing. I keep hearing that from everyone. Even in this talk, we heard so many things. We talked about different signals, metrics, logs, traces, continuous profiling. We talked about different components, the collector and its receivers and exporters, and Java and .NET and API and SDK. And okay, so I need to instrument. I need to start with my own organization, my own system. How do I get started? And I would like to offer my bit of advice, and it starts with something very basic, which is know your stack. Answer these basic questions to understand your system and what you need. So first of all, obviously, which programming languages your application is implemented in, especially if you're a polyglot organization. And preferably also which frameworks and platforms you use within it. So we use Java with Spring, we use Node.js with Express. So sorry, apologies. So understand these frameworks as well, because that will help you determine the client libraries that you will need to use and what kinds of maybe framework support and auto-instrumentation capabilities that you will need for your application. Next up, which signals? What are you going to collect? Logs, metrics, traces, and also in which protocols, which is especially important if it's a brownfield project and you have some sort of you have a Kafka communicating in a specific protocol that you need to adhere to. You have an older piece of code that uses Zipkin for the tracing or whatnot. You need to identify, because this will help you determine the receivers that you will need to use in your OTel collector. And lastly, which analytics backend you're going to use. It doesn't have to be one, it could be multiple, but you need to understand, because this will help you determine the exporters. So if you use Jaeger for your tracing, then Jaeger exporter. You need Prometheus for metrics, Prometheus remote write exporter, and so on. So these are the questions, and once you have that mapped out, then go and check out the status of each. There's a very useful page in opentelemetry.io/status that gives a high-level status of each. That's a good place to start. Next up we have the docs, very useful, and the registry, which is essentially a search engine across the massive GitHub repo. So you want to search, I don't know, .NET instrumentation, just type in .NET, it will take you already to the relevant part of the repo. And I would like to invite you all to check out also the guide that I created for OpenTelemetry. That it gives a good hello world overview of all the components, all the protocols, or all the things that we talked about in great depth. Also has a sub-guide per programming language. So you have the Java sub-guide, .NET, Go, Python, and so on and so forth. And from there carries on to the relevant links within the OpenTelemetry docs. So it's a good starting point. Check it out. And if you have any questions, if you have any feedback about this guide or anything else, do feel free to reach out to me at Horowitz, Twitter, Mastodon, LinkedIn, whatnot. And I remind you, this is an open source project, so get involved, get your hands dirty, and also get into the discussion. As I mentioned, even this week, if you don't know where to start, this week is a great opportunity. Tuesday, meeting the maintainers and mapping out the different working groups and tags, technical advisor groups, and so on. And we're looking forward to seeing you and together making this the best project for all of us. I'm Dotan Horvitz. Thank you very much for listening. And if there are any questions, then happy to take a few. Wow, I did a really good job. If everyone understood everything that I said, that's a good status. Last call, going once, going twice. Thank you very much for listening.
Thank you.
So we are going to talk.
All right, we are ready for our next talk. Shivei is going to talk to us about security and observability using Cilium and the kernel, and another eBPF talk. So it goes along the theme. All right, welcome, Shivei.
Thank you so much. And again, thank you so much for inviting me to speak over here. Super excited for Native Rejekts and KubeCon. Of course, my day didn't really start off idly. I lost my baggage, so still kind of worried about whether I'll be able to get it, but all good. My co-speaker couldn't make it because of visa, so we have pre-recorded his part of the talk. But yeah, I mean, going along with the theme of eBPF, we'll have another application of eBPF specifically towards service mesh over here, and we'll see how service mesh and the use of eBPF complement each other in order to achieve security, reliability, and observability for your applications that you deploy to the clouds. That's what the main takeaway will be for today's presentation. So a very quick introduction about myself. So my co-speaker will be giving his introduction in the recorded video. But I'm a developer relations engineer at Millisearch, and I've also been a Google Summer of Code mentor for the Mesh Tree project, which is currently incubated under the CNCF. It's a service mesh interface hub, and you can basically load, test multiple different types of service mesh on Mesh Tree. So I also co-founded the MeshMate program, which essentially allows developers who want to get started with service mesh to take their first ever journey into the world of service mesh. So we kind of do one-to-one mentorship. So it's completely open sourced. Yeah. So if you want to connect with me, feel free to reach out to me on Twitter. But the agenda for today is that first we look at some of the main issues that we commonly see with microservices. Now, of course, a lot of you coming in from a cloud native background might be already aware of them, but just wanted to set that as the starting context for those who might not be aware of them. And then we'll be moving gradually towards understanding some of the limitations that come with service meshes and how tools like ePBF and Cilium really help with those. But at the same time, we'll also look at some of the issues that we face with ePBF and Cilium and how we can complement them with the help of the service mesh and the combination of ePBF and the future road ahead for these technologies. So starting with monolith versus and microservices, right? I'll not go too deep into it because I assume that a lot of you might be knowing regarding these, but on a very high-level context, microservices are an advancement to your monolith concept. So with monolith, all of your different application layers, whether it's like the different functionalities, were bundled under one single application. And of course, the biggest issue that we found with that was that if there was even one single point of failure with one of the services, it essentially impacted your entire application. With microservices, since each and every application or each and every service is standalone and it's having its own database, its own networking, so you can really make your application much more manageable. So even if one of your particular services goes down, you'll still be able to run your application without having a major overhead by having that one single point of failure. So of course, service meshes, these microservices were a huge advancement in comparison to these monoliths, right? And of course, there are some limitations that do come with the microservices, especially when you start to see not just one, but you might have 100 or 200 different types of microservices. And primarily, if we take a look at the three major challenges that we'll also kind of look at and tackle with the help of technologies such as Cilium and ePBF. So the first one is security, right? So typically, whenever you are interacting with multiple microservices, you're using something like MTLS, which allows you to very securely transfer the information, encrypted information between your microservices. Now, it's all good if you're having 5, 10, 15 microservices. But let's say if you scale it up to 100, 200 microservices, then it will become very difficult to keep track of the different security parameters of the private keys that you might be using in order to be able to successfully do that secure transmission. And that kind of then relates to the reliability as well. Because if you are increasing the number of microservices that you have within your entire infrastructure, then reliability of maintaining these services will also become difficult, because let's say if there are some issues when it comes to some of these services, then it can become very difficult to track which particular service might be causing that issue, right? So as you scale up your microservices, it becomes difficult in a regular context to maintain the reliability. And that, of course, then also boils down to monitoring and logging of your services, because you need a robust tool that can very easily manage between all the different microservices that you have in your infrastructure, and then also reliably ensure that you get your logs and metrics from each of these microservices, and then also from the intercommunication that takes place between the microservices. So what we see is that as you scale up these microservices, the three fundamental issues that we see are in the space of security, observability, and reliability. So as we process, or we kind of go further in today's session, we'll see how each one of these particular major issues with scaling up your microservices are addressed with the help of tools like ePBF and Cilium. So with this, I'll move on to the pre-recorded part. So I'll request if we can run the video.
Hello folks, how are you? So we are going to talk more about security and observability for all applications and how you can combine the user kernel powers So we know like various facts are recently shared by my good friend Shiva. So going forward, let me introduce myself. So I'm platform advocate at Solo.io. I'm founder of various communities like Keep Up, DevOps community, Developer Relations community, and my goal is to just create a community where everyone can get solve their doubts regarding anything like DevOps if they want DevOps and cloud native doubts, and if they have any queries about the same, they can directly reach out to DevOps community. Same for the developer relations, same for the keep up for the trainings and jobs and opportunities. So I'm also available on the Twitter, YouTube, LinkedIn portfolio, my own, and like if you have any doubts and if you have any questions regarding the cloud native today's talk and various things, you can directly reach out to any of handles. So I host some podcasts on YouTube and Spotify, Apple Podcasts, and different websites, which is known as Cloud Native Talks. I had various folks from all over the world. You can go and check it out. So moving forward, so as we know, like our Shiva has already introduced you to the cloud native security and observability, and what is the monoliths, microservices, and what is the challenges in the microservices. So introducing service mesh. So service mesh is something you can say like it is a transparent infrastructure layer that manages the communication between your microservices. So what actually it is that? So when you are dealing with the microservices, it is like there are various things to handle. Like you have to make it secure. You have to why use the service mesh to better use the better capabilities of these things. You can increase security. You can use you can use the visibility. You can use the reliability, and it provides everything. So if you have large number of microservices kind of a infrastructure and something, then yeah, service mesh is something for you. And so previously it was like you have so what happens when service communicates with each other, then it was really tough, like you can't actually implement the business logic into it. So what is business logic? So if you are familiar with Kubernetes pods and structures, and if you have deployed the application services, you might have seen the pods attached to it where capabilities are shared, right? So that pause where you share the capabilities is called as business logic. So while operators work independent of dev cycles to provide a more resilient environment, as we know. So moving forward, as we can see, so what actually is Istio networking and what actually is Istio service mesh, right? So when why we are talking about this? So when you see the diagram of our Istio, so what happens? It talks the control plane, then the data plane and different data planes. So control plane is sitting outside and it checks everything. Like it is the only one who handles everything. Like if you want to track the matrix, you can go through it. Uh, uh, if you want to put some capabilities, you have to just contact to the Envoy proxy, which is attached to the your services in the data plane, and that capabilities will be add on. So similar kind of a thing we are explaining here. So your entire like entire application container, traffic flowing, and various capabilities are done through the Envoy proxy. So Envoy proxy is something which was introduced by the Lyft, and now it is open source, available on the CNCF projects. As you can see, it is the one of the best proxies around the world, and it is widely used everywhere. So what actually is the Envoy proxy? So it allows you to add the capabilities to your application through the sidecar, which we say. So network traffic is transparently redirected to proxy every time it is same. So you can add the TCP UDP connections. So in this TO, for now we are dealing with the TCP connections, but we can add UDP also. It is not different or something. But talking more on this same side, if you want to communicate to the IP tables, if you have to mention something, you can do it easily through the issue. So traffic redirection is achieved via iptable rules, as we say. So created a pod startup. So what we are seeing here, so if you have the use case around like creating the init container, and So if you want to redirect the your traffic through the IP tables, then init container is the one. But if you don't want to deal with the same, and if you want to go through the CNI, what means like CNI traffic redirection kind of thing, then Istio CNI is for you. So there are other things also. So redirect rules in the pods network namespace point inbound and outbound packets to the correct ports opened by the sidecar. So what it actually saying? So if your sidecar is opening for your services and kind of thing, so we can mention the inbound and outbound packets into the your network namespaces, and for we can redirect some rules whenever we want. So sidecar processes the request, handles policies forward to the correct destination. So what actually it is saying, like if you want something reliable, if you want something visible, if you want something more secure, it is easy to observe the things, then yeah, this is the way you can go with the Istio service mesh is for you. And Istio service mesh is the one of the service mesh which is widely used everywhere, and it is most popular one. Recently, it is actually got into the incubating project for the CNCL. So it has a vast future and various capabilities, and as we can see, like there are numerous things are launching day and day. So moving forward, we can talk about the service mesh, issue, benefits, and limitations. So what actually it is. So as you can see, Envoy is the most powerful, and it is really rich in the L7 proxy. So that is the only thing, right? You can get entire things from the your L7 proxies, and native support for various application protocols, end-to-end encryption with strong workload identity. So what actually is mutual TLS, MTLS, what it is? So as you can see, like you have application one, application two, and if you want to, so application one is like say like slash dog, and application two is a slash cat. So if you don't want to access the application 2/cat, then you can easily mention some policies, and application one will be accessible to your get request and post request kind of thing. But this can't be accessible. So yeah, it is then easily be done, and it is the most secured way if it works. So fine-grained security at L7, as we discussed. So rich telemetry. So what is rich telemetry? You can easily get the scrap the data and metrics, and you can use it whenever you want, and you can use it for the various protocols. So easy lifecycle management with sidecar proxy architecture, as we can see. So whatever capabilities you want to add, you can add it easily on the proxies. If you want to do any new things, like if you want to so one thing only, like most so things are like all features are reliant on the sidecars, so not getting bypassed. So what happens, actually it means, so it is one kind of a limitation which I think, yeah, it is there. So whenever you want to add some capabilities into your application, then you have to highly reliable on your sidecar, because entire traffic will go to the sidecar only. Similarly, for the IP tables, redirection only works for the TCP traffic. So as we said, like issue recently works for the TCP only. But in the future, yeah, UDP can be added. It's not like big issue. But injecting sidecars require application pod restore. It is not actually the use case, I would say. But thing is, like you need to restart your pod whenever you want to add any application. If you want to add any new sidecar or something, then you have to restart your pod. But as we are dealing with various clients and various customers, we never face this problem, because they keep their applications running, like they do IST or service mesh running, so they don't want to restart their pods. So yeah, but still it is a kind of a limitation. High resource consumption. So if you are using the sidecar on the application one, application two, different services, different jobs, then yeah, for sure your resources will be consumed more, your latency will increase as you are so think like this application one is traveling or talking to the application two through the Envoy proxy to the service. So Envoy proxy one, then Envoy proxy two, and then to the application two. So it is like long latency required. So that is the thing. So what actually is the eBPF? So Linux technology which enables users to run custom programs sandbox in the kernel. So what actually it means? So as you can see, uh, if you want the capabilities of the users kernel user space and kernel space kind of thing, if you know, so think about this. There is a JavaScript program, there is Python program kind of thing. So if you want only the user space like kind of a capabilities, then yeah, you go there, right? So if you want both, if you want kind of a thing where you can achieve both of these things using the kernel capabilities, then yeah, eBPF is something for you. So eBPF is just the extended BPF. So what is a BPF? It is a Berkeley packet filter, which is used for the filtering your packets. You can remember there is a TCP dump command you use in the Linux terminal, right? So that is the one. So it based on the test hook point. So whatever you want to trigger in by like certain events, which we call as a K-prop type programs, which you can attach to the kernel functions. And when it is executed, then when the function is called, so that is your, yeah, you can call the hook points and stuff. So BPF programs are verified to be safe, won't crash the kernel, guaranteed to return, no infinite loops, and only access specific sections of a memory, etc. So yeah, as we can know that. So why BPF? So as we are dealing with the istio service mesh, as we are dealing with the Cilium, as we are dealing with the Enva proxy, we knew that, right? Networking, security, observability, we are already using it at the user side. Yeah, so why not to look for something for the kernel side also, right? That is what we are looking today, right? So yeah, eBPF is something where you can use the classic BPF, means like it is TCP term. Yeah. So you can use a Linux networking stack. So it is there for the networking. It is there for the TCP UDP, and it is there for the your capabilities on the what do we say layers in your OSI, right? So security is something you can use it to like do allow the GET request, not allow the post request kind of thing. You can monitor the sensitive information. You can track the metrics. For the observability, you can get scrap that things. You can put it whenever you want. You can specify some hook points and trace points, and yeah, that kind of a thing you can do, and we call it as a eBPF based monitoring, and it is really efficient. Like you can specify the raw events as they happen in the terminal. So it is the best capability we can see. And talking on the telemetry side, it is just I think eBPF is something we will focus more towards in the future and from now only, right? So talking about the eBPF architecture, as we can see here, eBPF program has like it generates it goes to the compiler, LLVM compiler, and it generates the eBPF byte course. That course is loaded to the verifier, your kernel space, and then it goes to Java, your JIT compiler, and that is converted into your machine code. After that, and that machine code is something like you can call it that it happens like props, tracers, sockets is something you can look out for the traffic things and stuff in your networks, right? So that maps is something which converts these things and gives you to the output. So output is generally available to the user space, and you can use it as a user space. So generally, eBPF is written into the various languages, C language, and your Rust. Rust people are using it, right? Nowadays, people are looking for the better capabilities. So we will discuss this in the next talks and somewhere, because I'm really excited on talking about that things also. But Cilium, yeah. So talking about the leveraging user and kernel powers together. So that is today's goal, right? So what can happen when you can use the users and kernel powers together, and you can achieve the various things, right? Because now
All right, perfect. So, of course, you heard from my co-speaker about what exactly is a service mesh and how that actually helps overcome some of the limitations that we usually see with microservices, and also introducing ePBF into this entire mix, and some of the security capabilities that you get in hand from the kernel capabilities that come with ePBF. So, talking about Cilium, right? So, talking about an introduction to service mesh, an introduction to ePBF. This is kind of the natural transition into understanding why not create a service mesh or a tool that leverages the power of ePBF that helps us to bring capabilities such as your security, observability into the service mesh directly. And that's what Cilium kind of really started off as. And one of the primary goals that ePBF kind of targets is that, A, it will provide a lot of scalability as well, as we'll cover some of the features of Cilium. But the biggest one is that it can actually inject network security policy without having to make any changes as such to your entire code or to the configurations that you may run in your Kubernetes nodes. So talking about some of the major advantages or the major features of Cilium, right? So the first one is the service mesh load balancing. So Cilium essentially provides you load balancing right off the bat, and again, because it's using a standardized Kubernetes ingress controller, so that allows you to basically very easily set up your Cilium agents inside of your individual Kubernetes nodes, and you can very easily manage them inside of a distributed Kubernetes cluster, and there's no limitation in terms of setting up multiple clusters. So it actually scales up pretty nicely as you scale up more number of nodes in your cluster, or you might have a multi-modal cluster. And then the second one is that it also provides a lot of different network policies as well. So it has the standard Kubernetes network policies and the Cilium network policies that allow not just for identity-based policies, then also for your global set of policies, but also for the policies that are enforced on your application layer, such as like your HTTP requests or gRPC-based requests. So you can get policies not just for the application layer, but also for authentication, identity as well. And also, you can define global level policies for your entire architecture. And then, of course, when it comes to scalability, so I think the biggest one is that when we want to scale up your regular microservices, we found a lot of issues primarily when you're hosting them on a Kubernetes cluster. But the great thing with Cilium is that since it comes inbuilt with a CNI, then what that allows us to do is that it has full capability with scaling up any of your Kubernetes clusters. So essentially, you can run your Cilium agents on top of each and every node. And the more, if you want to increase the number of nodes inside of your cluster, you can very easily just spin up new agents that will be able to manage your multi-cluster network. And there will not be scaling, there will not be an issue as you scale up your network horizontally. And of course, the most important one is that you can get very easy access to metrics as well, even though you might have a lot of different agents. So these agents, these Cilium agents are able to communicate between each other, and you're able to get logs based on each and every node as well at a node level with the help of these Cilium agents, because they're able to spin out or they're able to spit out these metrics that you can very easily manage with the help of Prometheus or any other logging tool that you might want to use. So, of course, these are the major capabilities that we covered. So that includes the load balancing, the network policy troubleshooting and monitoring, and the network policies creation, and the CNI. And of course, there are some limitations, right? So since Cilium is still, I would say, not a fully evolved project, so of course you do get kernel enforcement because it uses eBPF to inject your security capabilities inside the node itself. But there are some limitations, and those are primarily related to your L7 and specifically related to the policies that are defined for fine-tuning your L7 policies. And of course, the other one is the weakness with respect to identity-based services. So those are somewhat that will be taken care of as you combine both your kernel and your user experience together, which again we'll be covering in the remaining video. So you can play the video.
What can happen when you can use the users and kernel powers together, and you can achieve the various things, right? Because now you can work at the user space for the elf, like some capabilities are there only for the L4, right? And some capabilities are there for the L7 only. So what can be happen when we both connect these things, and we, whatever are the drawbacks in the one, whatever are the drawbacks in the one, we can combine them and we can solve everything, right? So that's why we are looking into this space. As you can see, what happens in the current Istio sidecar reduction. Whenever application goes talks to the Istio proxy, it goes to the socket, and then socket is the one who goes to the network stack. So it is really going to that application, and everything is dependent on the Istio sidecar, right? It redirects the sockets. But what happens if we skip the network stack? It is entirely removed, and eBPF is the one who will talk to the various things. So yeah, it is really right. Right thing means previously it was not that tough or something, but it just accelerates your path, and you don't have to focus on the minor things. Now you can give some push towards it, we can say, right? So same with the observability with your Istio sidecars. So previously, as you can see, if you have the sidecar, then you can scrap the application, Istio envoy matrix easily and put it to the Prometheus, your observability, whatever you use, right? So similarly, it is shown in the node one, like pet store is there and Istio proxy is there, and it is scrapping the data, right? But in the node two, as you can see, there is no sidecar, right? So how will it is scrap? Similarly, without Istio sidecars, what happens? Scrap. It just app metrics. It scraps. So what happens? Like enough data. What is the issues, right? Can we use the BPF for gathering additional data? What we can do? So here it is done. So here's the answer for you. As you can see here, you can directly scrap the application Istio envoy matrix from the eBPF, and similarly, it is gathered by the BPF programs. And what happens? It generates for your non-mesh workloads, custom metrics for mesh workloads, and scrapped via standard Prometheus infrastructure. So if it is like whatever it is needed, it scraps the non-mesh. Whatever it is needed, it scraps the mesh workloads, right? And it pass on to the Prometheus, and yeah, your desired things are achieved. So with the eBPF, we can solve various capabilities which was needed, right? Similarly, looking ahead, as you can see, Istio and eBPF are both exciting technologies. I really know and vouch for it, and individually provides a lot of benefits to, but can be layered together for even enhanced functionality, as we talked about layer 4 and layer 7, depending on the how we can combine them and use for the user kernel powers, combining to the better results and better performance. So Istio recently launched ambient mesh, and yeah, Solo and Google is the one who like deal with entire thing, and they were it's like we were really working extensively on this, and we can talk about it is the big thing, like you don't have to now restart your pods when you use the ambient mesh, and there are various things, right? So just check it out, like what is the ambient mesh and how it works. And if you want to know more, you can check my previous talks also. It is that. So lots of exciting development happening in this space, and reach out feedback and questions. Yeah, go ahead, and if you have, and you can reach out to my own handles also, right? Thank you.
And yeah, I'll be open to questions. But what we just want to cover from this particular talk, it is more of a beginner-friendly talk for those folks who might not have been from a traditional service mesh background. But the main capability that we want to demonstrate is that how you can leverage the power of eBPF in your existing H2-based networks and get those additional metrics and security with the help of the kernel capabilities that come with eBPF. So yeah, with that, I'll be open to questions now. All right, looks like no questions. So thank you so much. You can reach out to me or Rohit on our handles. And yeah, I hope that you have a wonderful rest of Native Rejekts and KubeCon. Thank you.
Thank you. So I will. All right, so for our next talk, we have Thomas, who's going to talk to us about paid path to production. Welcome, Thomas.
Thank you very much. And thank you all for joining. Today I'm going to talk about how to design and build paid path to production on Kubernetes. I work at Systematic, a Danish software company. I'm a software engineer and cloud architect there. I'm really passionate about anything cloud native. I wrote a book, it's called Cloud Native Spring in Action with Spring Boot and Kubernetes. And I'm a big supporter of open source technologies. I like contributing as much as I can. But before talking about technologies, I want to ask a question. And the question is, why do we build software? Now, I know that there might be different answers to this question, but we can agree perhaps that it's safe to say most of the times we build software after we identified a problem. We identified a problem and we realized that it makes sense to solve it through software. So we start implementing a software-based solution to solve the problem and finally deliver value to users, to customers, and to the business. That's why we build software. We want to deliver value via software, and that software solves some problems. So the way that we deliver value, the way that we go from the initial idea to production really matters. Because we start with this idea, at some point we involve a development team, we go through this path to production, which in our case would be Kubernetes today. But the way that we go there is really important in order to ensure that we get there as quickly as possible, but also in a safe and secure way. Because until we reach production, then our software is useless. It's only when it's running in production that actually delivers value to users and customers. So for today, I want to explore how we can build such a path to production. And in particular, I'm going to aim at achieving 3 main goals. The first goal is a rapid and continuous feedback loop for developers, so as part of the initial development workflow. Then the second goal is reducing the cognitive load. So I want to establish such a path to production, but I don't want to put too much burden on the development team. And finally, I want to establish a very clear and safe path to production. So these 3 will be our guiding principles for the analysis that I'm going to run through in this presentation. All right, we'll start with the development workflow. So we got the initial idea, we bootstrap a new project, we built a new cloud-native application, and depending on the language we are using, the runtime might change, but we know that in general, on top of that, we package our application as an executable and run it directly on top of this runtime. And this is a very nice and clean experience. The feedback loop is quite fast. Just think about a Go application. It's very fast to compile it and run it while we are working through it, for example, for a web application. And the cognitive load is not that bad because we basically need to know just about the language and the framework that we are using for our application. But this is not enough. So we are aiming at deploying our applications in production on top of Kubernetes. So the next step here would be to containerize the application. And when we start introducing containers, then the runtime will be the container runtime, like Podman or Docker. And on top of that, we're going to run the application packaged as a container. So just by doing that, the feedback loop got a bit slower, because now we have this extra step of building a container image. And then we need to know how to build that container image in a way that is performant, in a way that is secure. So the cognitive load also gets a bit worse. Now, Docker files are a simple way to get started with containerizing applications. Writing a Docker file is very simple, but writing a Docker file that is production ready is really not that simple. And there are ways that we can optimize and mitigate some of the issues that we encounter when we start working with containers. In particular, I'm aiming at not having developers being responsible for the Docker file, for the maintenance, for the security. And I really like a tool like Cloud Native Build Packs, a CNCF project to convert application source code into a container image without writing a Docker file. And the result is something that is production ready, so with all the security and the performance baked in. So as a developer, it doesn't matter what kind of language or framework I'm using, because it's a polyglot tool. I can run a command like pack build using the pack CLI provided by the Buildpacks project, and then I obtain an image. So at least, even if I have this extra step of containerizing my application, the cognitive load is not that bad, because I can use Cloud Native Buildpacks and I don't have to know all the details of writing a production-ready Docker file. But that is not enough, because we want to move to Kubernetes. So after building a container, we still have the container runtime, but now we introduced a middleware. We have Kubernetes right there, on top of which we run our application, and things now start getting tricky. Because after building the container image, we now have to deploy it to a Kubernetes cluster. The feedback loop gets even slower. And then we need to know, as developers, about Kubernetes. And the cognitive load is quite bad there. But now, I want to specify two main things here. The first thing is, I'm assuming in these examples that we are using Kubernetes because we need Kubernetes. It means that we have the problems that Kubernetes solves. We don't want to add unnecessary complexity. So just because it's popular and everybody's talking about it, I don't want to use Kubernetes if I don't have those problems. So that's the first assumption. I'm using it because I need it. But then I need to pay attention to not make a common mistake that is just throwing Kubernetes at the development team, because that's the problem. When we have Kubernetes like this, the feedback loop is bad, but the cognitive load, if we just tell the development team, okay, now you use Kubernetes, you have to learn all these cloud native tools, they're all amazing, they're great, I like working with them, but if I'm in a development team, I want to focus on the business logic of the application, and I don't want to spend too much time on all this extra complexity. So we need to manage that complexity somehow. And the trick is to give these capabilities to development teams, but without giving them also the responsibility. All the talking we do about shifting left, that should be about capabilities and not responsibilities. So once we have this situation, we need to find a way first to assign responsibilities and then to basically optimize the feedback loop, as we said, and reduce the cognitive load. Now, the cognitive load, I'm going to talk about that in a few seconds, but I want to start addressing the problem of this feedback loop, which now became slow after introducing this containerization step and Kubernetes step. And in particular, I can introduce a tool like Tilt or Scaffold in order to establish a continuous development loop. Because as a developer, I start by making some code changes to my application. Then I build a container image. I run it on Kubernetes, then I do some testing, some debugging, and then all over again. Using a tool like Tilt, I can automate all these steps. I still have the same cognitive load, because I still need to know about Kubernetes and how to configure my workloads, but at least it's automated and it's fast. So let's have a look at an example. Now, I have a very simple Java application. It could be any other language. The approach is the same across different languages and frameworks. It's a very simple application with 2 endpoints. Since I'm using Tilt, as a developer, I can start my continuous development workflow just saying Tilt up. And then Tilt will take care of compiling my application, packaging it as a container image, and then deploying it on Kubernetes. And then since I'm using Cloud Native Build Packs combined with Tilt, I can even establish a live reload cycle so that every time I make changes, the new files are automatically reloaded within the container rather than having to build a new container image every time. So this is a combination of what Tilt can do and what Cloud Native build packs support. So we even have a GUI for Tilt. We can see that for this application, the book service is started by using Cloud Native build packs. I'm using the Paketo build packs to build a new container image. After that, it will deploy the application using some manifest that I have to provide. So as I said, the cognitive load is still not that good. I need to provide a deployment object to tell Kubernetes how to deploy my application. I need a service object saying how to expose my application within the cluster, and then I need an ingress object in order to expose the application outside the cluster. This all works, but again, as a developer, if I put this manifest, even if they are auto-generated, but if they are part of my application source code, then it means I'm responsible for it. Same thing for the Docker file. So we can use tools in order to not having to write all these manifests manually, but if they lie together with the application source code, we don't really have a separation of concerns. It means developers need to know about Kubernetes and need to maintain these files. And I'd like to get rid of that from the developer. So we can see the application is deployed, is exposed through port 8080. It's running. Welcome to book service. Let's verify the other endpoint, books. So I get a bunch of books. And all of this is configured via a tilt file. So I'm pointing tilt to my deployment manifest. I'm telling tilt to expose my application through port 8080. And then I'm telling Tilt to use Cloud Native build packs to containerize my application. Now I can use the pack CLI, which works across different languages and frameworks. Since I'm using Java Spring Boot, Cloud Native build packs is part of the Spring Boot framework, so I can use it directly without having to install a separate CLI, which is quite convenient. All right. So this is our situation now after introducing containers and Kubernetes. So let's have a look at our initial goals. All right. So we saw that using Tilt, we can automate a lot of steps and still ensure a rapid and continuous feedback loop. Check. That is still good, but the cognitive load is still not that good. It's too much. So Cloud Native build packs is great, but if I ran it from my application source code directly, then I still have some responsibility as a developer. For example, what is the base image used? What happens when a new vulnerability is discovered? Like there's an OpenSSL vulnerability in the base image on Ubuntu, what to do? And then we have all this Kubernetes manifest that is too much. So I think developers should know a bit about Kubernetes because that's the runtime environment. So to knowing the constraints of the environment where we are deploying applications is important. But that doesn't mean being expert in writing the perfect manifest that can support and have all the different security considerations and policy assurance and all of that that we really need in a production scenario. And then I still don't see a safe path to production. These actions, I will perform them also as part of my CI/CD pipeline, but how are those actions related to what I do in my development environment? We'll find out soon, because if we look at CI/CD pipelines now, I have done my work as a developer. I pushed the changes to Git. We have a simple pipeline as an example. Every time I push new changes, my pipeline will check out the source code, will build a container image, will configure the workload, and finally deploy it. And now the standard way of implementing such a pipeline is using an orchestrator. So, for example, GitHub Actions, GitLab CI, Jenkins, Tekton. And that works in a lot of different cases. Like this is the approach. I call it an imperative pipeline. It's the approach that I use in most of my GitHub projects, for example. But when we start introducing Kubernetes, especially within organizations with multiple development teams, then we start noticing that this pattern, this approach, has some drawbacks, because it's a quite rigid system. Meaning that if I want to make changes to how I build a container image in isolation, I can't do that, because it's very tightly coupled. It's the definition belongs with the application source code, so I don't have a clear separation of concerns. If I have some security experts in my organizations that want to provide certain policies to my workloads as part of the configuration step, it's hard for them to do that if the pipeline is one single rigid system and lives with the application source code. And in general, it's hard to maintain. So of course, this is a very specific scenario where we are using Kubernetes. We have multiple development teams. What can we do to improve the situation? How can we solve these issues? The problem is that we need to consider not only developers, but all these other personas that still need a way to provide their skills and expertise to the system. Earlier, I talked about developers, but in the path to production, we need to consider other personas like application operators, security experts, platform engineers. We need a way to clearly define the boundaries between all these personas, between different teams, so that each team then can be specialized in what they're doing. In a development team, I expect developers to really focus on the business logic part, that is what provides value to the end users, but not necessarily about how to containerize an image or how to configure a workload for production with all the security and performance and compliance that we need in a production environment. And this is even more important in highly regulated industries. So we have a pipeline, an imperative pipeline. What can we do to solve those problems? We can try to look at how we build applications. If we have a single rigid application and we have the need to change independently some components, some areas of it, and have different teams being responsible for different components, what do? We break the monolith down. So let's try to extract the deploy workload functionality outside and say that now the first part of the pipeline will output some Kubernetes manifest, perhaps pushing them in a Git repository. And then the deploy workload component will watch the Git repository, and every time they change, then it will fetch those new manifests and deploy them. And look at that. That's what we do with GitOps, right? So what if we extend this GitOps, this GitOps approach to the entire pipeline? This is an event-based system, right? So let's try and move out configure workloads. Now, every time a new image is built, configure workloads is triggered and will configure new workloads with a new image reference, for example. And we can do the same for all the steps that we need to be independent from each other. In the first case, there we have the source code. Every time it changes, we build a new container image. This is a reactive system. And if we consider the reactive manifesto, a reactive system, among the other things, is message-driven. So we just turned the original imperative pipeline into an event-driven system, where each of these components is independent from each other. They don't know about each other. They just know about inputs and outputs, which is quite convenient because everything is loosely coupled. I have a clear separation of concerns. If my security team want to change something about how we configure the workloads, they can do that. And they won't have to trigger the entire pipeline from the beginning, and they won't have to coordinate with all the development teams. We get a flexible system. Since it's event-based, we can swap each of these components with something else, maybe different implementations. We can add new components, remove components, without affecting the rest, which is quite convenient. And this is a key aspect to build this consistent path to production. But we changed the architecture of the pipeline, but we introduced two new problems now, because the API up there towards developers now needs to be different. So we need to find a way to interface the developers with this new way of building a pipeline. And then we need a way to pass messages around. Just said it's a message-driven system, so how do we make sure that we pass these messages between components? The solution I'm presenting today is based on a project. It's called Cartographer, and Cartographer is defined as a Kubernetes native choreographer. Once again, if we consider how we build applications, in particular event-driven systems, we have the choreography pattern there that we can use in order to define how to exchange messages between microservices, for example. So we can use the same approach here. Now, the way I like to define Cartographer, besides like the official definition, is as a framework to build paved path to production. So we have two challenges, right? Two new challenges in this setup. The first, I said, is the API towards developer. And Cartographer offers the workload API. Think about it. As a developer, if I'm working with a new application, there's a set of information that only I, as the developer, know, like the name of the application, the Git repository where my application is, the branch, and maybe some additional metadata like what language I'm using or what type of application is. That's it. So the workload API allows me to provide exactly that information. I can provide the name of the application, the type, for example, it's a web application, the Git repository where I have my application, and the branch. So as a developer now, instead of dealing directly with Cloud Native build packs with Kubernetes manifest and deployment configuration, I just use the workload API to submit my request to a platform that will use Cartographer then to trigger my reactive pipeline. So, I'm now in a different situation. I have a platform team that provided the platform to me as a developer in a product team. And I have a workload configuration now, so I won't have any more the deployment, ingress, service. I don't have any of that. I just have a workload. And I can apply directly to the cluster with the Kubernetes CLI, but I can still use tilt. So my experience won't change that much. I can say tilt up, but now tilt, instead of running the containerization process and deployment process, will just submit this workload resource to the cluster. And then Cartographer takes care of the rest. We can see here we have a reference to my repository at the subpath also, because it's in a subdirectory. And if we look at the tilt GUI, we can see that the application is up and running. It's still forwarded through port 8080, and I still have the live reload capabilities. So I didn't miss any of the nice features that I had at the beginning, but now the way that is containerized or the way that is deployed, it's out of my hands as a developer. It's provided by the platform to me. So I can focus on the business logic. And next, the other side, so the side that will be more interesting for application operators or platform engineers, is what happens when we send a request via the workload API. So how can Cartographer pass messages around all these components? It does that by intercepting inputs and outputs. Basically, it wraps all of these components, so the components will know nothing about Cartographer, and Cartographer doesn't need to know how they are implemented. It's quite flexible in that sense. So I can say that I want to use Flux CD for watching the source code. I can use Tecton to build a testing pipeline for my application. I can use Cloud Native build packs to build a container image, in particular Kpack, which is the Kubernetes native implementation of build packs. I can use Knative to define my workload configuration, and then I can use Carvel for doing the deployments. But again, this is flexible, right? One of the points was being able to change parts of this pipeline independently without breaking the rest or affecting the rest. So perhaps I'm working in a team where I already have Jenkins for my testing pipeline. That's fine. I can replace Jenkins with Tecton. As long as the inputs and outputs are the same, I can change the implementation, and Cartographer doesn't need to know about that, and all the other components will not be affected. So it's all based on the contracts, like in an event-driven system. What matters is inputs and outputs. I can use Argo instead of Flux. I can use Canico if I want to work with Docker files instead of build packs, or even with plain Kubernetes manifest if Knative doesn't fit my use case. That's fine. I can do that because being an event-driven system, as long as I keep the contract, I can swap all these components with different implementations. And really, like, sky's the limit, right? So Cartographer can integrate potentially with any tool as long as we have the same input and output. And this is great because every organization, every team will have different needs, right? So we always need to consider what are the user requirements before implementing these things. And having this kind of flexibility really helps ensuring the best experience for the end users of the platform. Nice. So another important part is how Cartographer can do that. How can Cartographer know how to pass the output of a component as input to another component. He does that via the concept of a supply chain. The supply chain is basically the way we use in Cartographer to describe the path to production. Now, this is a simple example. I define a supply chain that handles all the workloads of type web. So this is a key part. Like, I don't have a one-to-one mapping between application and a pipeline. But I can reuse and centralize my supply chain and use it across multiple teams and application. And I have 3 components here. The first component checks out the source code. The second component uses that output as input to build the image. And the third component gets the image and then deploys it to the cluster. And you can see there's nothing about Flux or Buildpacks or Knative here. The way that we do that integration is via a third API. So we talked about workload API, supply chain API, and finally at the low level we have the template API. For example, FluxCD, we could use it to check out the source code. FluxCD provides a Git repository object where we can specify the Git repository name and branch, but that information is provided by developers via the workload API already. So we can ask Cartographer to provide that information dynamically, because we already have it. And then we need to specify how to get the output from Flux. This will be different depending on the implementation. So we use the concept of the template, where we specify the output based on the type of the output itself. In this case, the output is source code, so the output will be URL and revision path. In the case of an image, it will be an image reference, and we're going to use a cluster image template. So we have a few different template types based on the type of the outputs. Then finally, we can put all of these things together because we looked at the developer experience. Once I'm done, I push my changes. And then in a different cluster where I have all these build capabilities, I can look, moving here, so I can look at the workload for book service and see that every time that I push my changes, let's adjust the size here. Yeah, so this is the supply chain applied to my application. I have a few different components. I'm using FluxCD to check out the source code. I'm using Tekton to run a testing pipeline. I'm using Trivi to scan my source code and image, orchestrated by Tekton again. I'm using KPack for building images. Trivi within Tekton to scan my image. I apply conventions, configuration, and finally, either I push my workload manifest directly to a repository, or I open a pull request. And in this case, I open the pull request. So let's check the repository here. I get a pull request from Cartographer. We can see that we get a new image reference. So if I merge the pull request, that will trigger a new change in my production environment. Pull request merged. Let's go to the production cluster. I am using Knative. So if we check at the Knative services here, I get the URL for the application. And you can see that it's using HTTPS. It's based on Cert Manager with Knative and Let's Encrypt. So it's producing a production-ready certificate for that. And there it is. Welcome to book service. So this was the entire supply chain, but we are missing one final part, because I started by having already the project opened in my IDE. But I still need to provide the workload configuration manifest myself, and I have to provide the configuration for Tilt. So rather than doing it manually, I can even further improve the developer experience. And if I'm using something like Backstage, I can provide this bootstrapping capability through a developer portal. So I can, if I want to create an application similar to my example with Spring Boot, I choose the specific template that is part of a golden path. So I can have demo Backstage as a name. Let's say I'm in team B. I want to create a repository, and let's name it Demo Backstage. So I can automate even the bootstrapping phase so that developers don't even need to worry about how to create that workload configuration. I get a repository, and you can see I get a new repo in GitHub, and the important part is that I get the workload configuration with my application name, and I get the tilt file with tilt configured. So as a developer, I check out the source code from GitHub, and then in my development cluster, I can just say tilt up, and that's it. I can start working on my business logic. So to sum up, we can support multiple development teams working with different languages and frameworks. It doesn't matter, because through the workload API, they can take advantage of the same supply chain. And that supply chain ultimately will make sure that the applications are deployed in production, which is the whole point of this, right? We want to go to production quickly, but also safely and securely. And since we are working with this supply chain abstraction, we can have all those different personas like operators, platform engineers, and security experts providing their skills, their expertise into the supply chain to ensure policy, compliance, and security, and any other aspect that we might want to enforce as part of our delivery process within our organization. Yeah, so continuous feedback loop is still rapid, still same experience with Tilt, but now we got reduced cognitive load. I can bootstrap a new project. I only need to know about this workload API, but that information I know as a developer, like it's the Git repo and the name and the type, that's fine. And I also get a clear and safe path to production, because I don't have to worry about building new pipelines every time I create a new project, because the platform using Cartographer provides that functionality for me. So that was it. Thank you very much. All the source code is on GitHub. You can see like the platform that I've been using, and the Cartographer configuration is there, examples of applications and other useful content. Thank you very much for joining, and have a great rest of the day.
We actually don't have time for questions.
Yes.
So, yeah. So if you have questions for Thomas, maybe...
Yes, find me around.
Ask them, yeah. After.
Thank you.
Yeah. Thank you.
Are you ready?
Something happened. 1 second.
Okay. What's up?
It got freeze.
What is not working?
I want to minimize things, but
We have Pratik, who's going to talk to us about Kyverno and how it can help us manage our supply chain, your software supply chain. Welcome, Pratik.
yeah. Hello, everyone. Good evening. My name is Pratik. I'm here to present about the Kyverno, how Kyverno can help you secure your supply chain, right? So let's move on. So what's today's agenda is why policy, right? Why we need a policy? First of all, first question comes in my mind. And how Kyverno helps here and what is Kyverno is all about, right? Then we'll see how Kyverno policies work, about the internals of Kyverno architecture, right? And then I have some demos, how things work with the demo. I'll show you some stuff, right? And then what additional features we have built in Kyverno as part of new releases, right? So I'll talk about that. And then summary and Q&A at the end, right? So let's move on. So about me, I'm a senior software engineer at Nirmata, right? I'm a Kyverno maintainer. I'm one of the founding members of OpenEBS as well. It's a OpenEBS is nothing but a storage solution for Kubernetes. So yeah. So first question comes, right? Why policies? So if you have a Kubernetes cluster, you're maintaining multiple Kubernetes cluster, at the end you need a policy, right? Because if you don't have a policy in your cluster, things go haywire, right? If you're not secure properly, there will be chances that you can deploy some bad images, right? So there will be security concerns and everything can happen. So if you don't have policy, your cluster can be look like this, right? In 5 minutes. So with the rise of Kubernetes platform, because there is as you can see, there is a CNCF survey that says that there is a 96% of enterprises that are going to use Kubernetes or in the phase of evaluating Kubernetes, and they're going to deploy containers and everything Kubernetes, right? So that's why we need a policy, because we want to maintain everything, and you need a policy management tool to maintain all the stuff and secure your cluster. Yeah, so with the Kubernetes uses, things got deployed in Kubernetes, so cost of missing of Kubernetes guardrails will increase as well. So if you have any misconfiguration in a cluster, that will be costly to maintain and maintain the cluster as well in the pipeline. So yeah, you should at least use a policy. So what are the policy, right? So policies are a developer's contract or operation contract. So you can deploy a policy in a cluster and you manage those stuff using a contract, right? So, and how does Kubernetes helps you with as a Kubernetes, as a DevOps or as a platform engineers, right? So policy gives guardrails to, you can secure a cluster and produce a compliance into the cluster. You can automate the stuff. You can basically bootstrap things using Kaveno, with a generate feature, right? You can have a policy reporting thing for all the vulnerabilities in your cluster. You can generate the reports and you can analyze later as well. And next is what policies provide, right? So with the different team of concerns, you can have DevOps, you can have SecOps people, you can have platform admins, right? You can and they have their own use cases, and using Kaveno you can achieve those use cases, right? You can secure a cluster, you can validate the resources, you can enforce the policies, right? And you can have them as a background scan as well, so that later, if there is any vulnerability has been found in a cluster, that can be generated as a policy report, and then you can analyze that as well. Yeah, so why Kaveno? I already talked about. You want to write a policy as a Kubernetes way using Kubernetes API. It's easy to write, it's easy to understand in a whole Kubernetes API's way. So you can write the policies. It's like a custom resource in Kubernetes. You can, it's easy to write. You can validate the resources. You can do audit or enforce, right? Audit is to generate a policy report in the background scan. Enforce, you can just enforce it instantly, right? And then you can meteor the resources, and you can generate as well. Meteor is and you want to patch something on your, whatever you're going to deploy. For example, a pod, you want to set certain labels. You can use the meteor feature of Kaveno policy, and then generate, right? So with the generate, you can bootstrap any resources. For example, you're going to create a namespace. As admin, you want certain resources to get created. For example, a network policy. So a network policy, pod description budget, it can be a cluster role bindings, network policy, and quotas as well, right? So you don't need to have a third-party resources, like third-party tool, like a Terraform or something. You can use policies to write those bootstrapping things. Even you can policies can be written on a custom resources as well, and not just a native APIs. You can use any custom resources and write a policy around that. Okay. So there is a two different engines currently in Kubernetes ecosystem. One is called Kaveno, and the other one is OPA. OPA is a general purpose rule engine. You had to learn a different language called Rigo to write their own OPA policies. But with Kaveno, it's like Kubernetes native. It's built for Kubernetes, right? So policy can be write as a declarative Kubernetes resources. You write a policy, and then you can instantly update the policy, and the resources will be updated based on that, right? So based on the policy changes, your resources get updated as well. You can, as I talked about, Kaveno has validation, mutation, generation, but OPA doesn't support these features. With Kaveno, image verification is one of the good feature which comes with Kaveno, which with using that image verification feature, you can achieve the supply chain security and SecOps things. Right? It's a native CNCF Kaveno as well supports the reporting mechanism as well, which I talked about earlier. So it uses a CSI benchmarks to generate those reports, and you can analyze using that as well. Yeah. So there is a comparison. There is one of the folk called Victor. He's one of the famous in the Kubernetes community. He has some comparison between Kaveno and Gatekeeper, OPA, right? So this video can be referred as well to understand more about these policies and comparison among these projects. So so next is how Kaveno policy works, right? So this is about architecture of Kaveno. So Kaveno is admission controller. So Kubernetes make it very easy to write admission controllers or any way to extend the Kubernetes APIs. So there's one other feature called admission webhooks. So Kyverno uses that feature to validate the resources, mutate the, basically all the requests comes as a mutate and validate based on the API handles and has been exposed, right? So it can be mutate after authentication, authorization, resources can be mutated, they can be validated based on the policy you have written, right? So in case of a webhook, there are different components to achieve that. So there is an admission report, there is a background scan reports, which can be, if you're not enforcing the policies, this can be generated using these features, right? And update request. Update request is nothing but a generate, which is in background running. It's a background controller, which basically look into the resources and basically it's looking into a pattern or a kind, for example, a namespace, and based on the namespace and policy rule, he's acting on that, right? Yeah, so we have a policy and custom. So Kyverno has two resources. One is called policies, which is specifically for namespace resources, or basically applied on a namespace, and then there is cluster policy, which is a cluster scope resource. Yeah, so these are the different use cases based on the different teams, either SecOps, DevOps, or FinOps. So SecOps can have a pod security, workload security, granular RBAC control. They want to achieve a multi-tenancy and those kind of stuff. They can do the workload isolation as well. Image signing and verification, which I'm going to talk about, and I will show the demo as well. And similarly, we have a DevOps use cases. You want to mutate the resources. You want to manage the certificates. You have a config map which get updated. You want to, based on the config map, you want to restart the pod as well, those kind of policies and those kind of use cases as well. And similarly, we have some use cases for the FinOps. So Kyverno is all about, it has a very widespread use cases for each kind of team as well. Yeah, so how the Kyverno policy look like, right? So you can see policy is a custom resource. Then we have a rule. So inside a rule, you have a match and exclude resources. So basically on the match, you can, based on the resource and kinds or names, or maybe example, labels as well, right? You can match the resources, and then based on the match, similarly, you can exclude the certain resources as well. So for the matching kind, for example, you are matching a namespace, you can, in the exclude block, you can mention about the excluded namespace, so that policy will not be applied on those particular namespaces as well, right? So, and that each rule contains match and exclude. Similarly, it has a rules to either you want to mutate the resource, or you want to generate the resource, or you want to validate, or either you want to have a image verification feature, right? This is one of the example of validation. So you can see the kind here is cluster policy, and you can see the metadata name, so it's more of a Kubernetes API way, right? Under spec, you can see the validation failure action, which is set to enforce. So basically, you want to enforce the policy to all the resources which is coming into the API, right? Or coming into the Kubernetes API server. After that, we have a rules, right? So a single policy can have number of rules. So there is the first rule, which checks for the labels, right? So it's checking, and the matching resources, it's a pod. So what it does is, it's matching the resource pod and checking for all the labels. And because its policy is written to validate the resources, so I have a validate rule. You can have a message so that it can be easily understandable for everyone. So a message, I said, label app.kubernetes.io/name is required, right? So it's looking for the pattern, and it will look into the metadata labels of all the resources of pod kind, and it see that this key has been set or not into the labels, right? If it's not, it will throw the error in front of. When you do kubectl apply, it will just enforce the policy and it will block the resources. Similarly, you can write a validation policy for all the deprecated APIs as well. So in Kubernetes, there are different APIs or resource APIs which getting built in each quarterly basis, and they are getting deprecated as well, right? So you can write a policy so that if you're somehow using a deprecated policy itself, deprecated API version of any resources, you can just block those resources using this API. So here I have a set of kinds listed. under the matching rule, right? And I'm validating those resources, which has been deprecated and removed in Kubernetes 1.25. So that will not allow to be created inside the Kubernetes cluster itself. Similarly, a mutate policy example, right? So I have a I have a mutate rule. I can see here similar to validate. I'm looking to create a patch. So I'm just ranging over all the containers and doing an operation add, right? And it can patch all the containers, either an init container, either a ephemeral container or a main container itself, and it can do a kind of port patching and etc. Right? So it can support different use cases, different condition logic or anchors using if then else or if not defined then patch itself. It can be used. It uses a JSON patch and a strategic merge patch as well to patch the resources. Yeah, third is generate policy. So generate policy is you can see generate rule as well. So I have an example of generate, which is kind of generating a spec called using a Kubernetes API called network policy. So you can see it's a whole object itself, right? Apart from its metadata itself. Apart from its metadata, right? So so this policy is all about watching a namespace. So if there is a namespace got created, it will be generating a resource called network policy. I have given the name called deny all traffic, and then I have all the spec inside the resource, right? All the network policy resources. Either match labels, match expressions, or anything inside the resource itself. So with generate, you can have different use cases as well. You can clone the resources. You can sync the resources as well. So if you have created a resource, you want to clone to the new namespace. Whenever you create a namespace, you can clone all the resources to that particular new namespace kind itself, right? And then there is a sync feature. Basically, if you have any update on the source resource, for example, in a default namespace or in a production namespace, you have a network policy which has been updated after some time, and that if synchronize is enabled, that sync will update the other resources which has been cloned or copied from that. So that is one of the use cases as well. Yeah, let's move on. So this is image verification policy. Right, so we are using cosign to validate the resources, validate the image verifications. If you have signed the images, you can automate all the stuff, how to verify, right? So you can use Kyverno to verify the images, certificates, right? Their SHA-SUM, everything. You can use Kyverno itself. You can use wildcards can be used as a matching all kind of images. You don't have to specify a name. So yes, you can verify the signatures, right? We'll see some demos around that to understand more. So yeah, so this policy is all about check the image. So you have seen this. There is I'm verifying an image, right? Under the image verify image rule, I have an image to get verified. It doesn't have any tags, so I just put star there so that all kind of tags will be verified. And I have a key which has been signed using cosign, and I'm verifying that image as well. Yeah, let's have some demos. Yeah, so I have a single. Is it fine? Yeah. So I have a single Kubernetes cluster running single node Kubernetes cluster. Right, I have Kyverno installed running in a Kyverno namespace. Okay, I'm going to deploy certain resources and policies and see how it behaves on the based on the policy routes, right? So to automate this one, I written a policy, written a script basically, just to save my time with the writing. So I'll run that script and I'll talk about, I'll go with the flow itself. Okay, let's start that script. Yeah, so I have a first demo to block the root user. Basically, if image has been built using a root user, you want to block those kind of images, right? You don't want to create those or deploy those type of images into the cluster itself. So how the policy look like, right? So you can see I have a spec. Again, I'm enforcing that policy using a validation failure action field. I have written rules called only allow non-root container images, right? I'm watching a matching kind called pods. So all pods will be validated, right? And I have a precondition set for the delete rules and those kind of stuff. I just want to see under the validate rule, I just want to verify the images with the root user are not allowed, right? So this will be looking for API lookup for all the containers into which is coming as a part of pod request, right? And it will verify the image data. It will look into the image registry. It will look into that, for example, a Docker registry or any container image registry, and it will verify the image data, and it will verify the user of that image data. And if it's equals to blank, if the root user is not set, it will just allow the image, right, to be deployed in a cluster. Let's see some demo. For example, I have, so let's deploy this policy first. So I can use simply kubectl apply and -f policy name. Right, so cluster policy called block root has been created into the cluster. Let's deploy some image. For example, I'm using kubectl deployment command to I'm using a busybox image here. I'm just doing a dry run server instead of creating. I'm just validating using a Kubernetes API server, right, as a dry run request. So let's see what it does. Ideally, it will block the image because busybox has root user configured, right, while building the image itself. So let's see, yeah. So you can see you got the error saying that failed to create deployment, admission webhook validate.kaiverno.service.fail denied the request because it failed that rule, right? The image has been root user configured. So you can see that. Let's deploy image which has non-root user configured, right? So here I'm doing a Kaiverno because Kaiverno image has been built using a non-root user, right? So let's see it's get deployed into the cluster or not. Yeah, so you can see it's simply dry run. Let's just to prove it. Yeah, so I think it didn't show. I just removed that policy which is blocking the resources, and then I try to create the busybox container image again, and it's allowed, right? Because policy is no longer there. Yeah, let's move on. Next demo called block stale images. So you can, first, one use case we have seen that we can block the images using if non-root user has been configured. Next use case can be I want to block the images which is very old images, right? For example, I'll try to, so in this policy, how it's look like. So again, we have a validation failure action. I am watching a resource called pod, and again, a validate rule will be written. Again, it's looking at all the containers, right? Doing a API lookup image registry call to gather the data, and again, it's verifying the data when the image has been created, right? You can see some inbuilt function of Kaiverno, which is called time sense. It's looking for the greater than, there is an operator, greater than operator has been used here, and it's looking for the value of, it should not be greater than 4380 hours, right? So it's a bit older image, all will be blocked and get deployed in the cluster. So let's apply this policy, right? Policy has been applied. Let's deploy a container image called Ubuntu, which is 18.10 version, is a bit older. I'll deploy this. This will be blocked by the policy. Yeah. It says image built more than 6 months. So it has been blocked. Just to test it, I'll deploy a new image of Ubuntu itself, and it should get into the cluster. Yeah, it's successfully dry run. Let's see the next test case called Meteor Tag to digest. So in certain cases, you want to have so you tag the images, but there is a chances that that image has been tempered, right? And you want to calculate a digest for each commit, whatever you commit to the GitHub or any service, any version control system, right? For example, GitHub. And if that image has been released using a SASHAM, you can verify those things. So in this policy, I'll see what is doing here. Again, a validation failure action. It's running in the background, right? Here I'm doing a mutate action or mutate rule. So it again looking for all the containers, right? It's trying to read the data using image registry lookup, right? And then it's patching the SASHAM of the image as a tag itself. Okay. Let's run some examples. So I'm again using a Kaiwano image, for example, right? I'm creating a deployment using that. So currently, I didn't deploy that policy. So you can see that under the image, I have just, there is no tag, right? You cannot see the SASHAM of the image or digest, right? Let's deploy that policy, right? I just created that policy. Wait for a couple of seconds. And let's deploy the image again, okay? You will see that SASHAM get calculated and it append to that. So you can see the image and it's appended the SASHAM of the digest of the image itself. Okay, so this kind of users can be done using Kaiwano itself. Similarly, now the image verification, you have verified all the stuff. Now you want to verify the image using certificates, right? So here we are using here the image has been signed and pushed to the GitHub using a cosign and Fulcio for the root verification as a keyless feature. So you can verify using a certificate as well, but if you want to use a keyless feature of cosign and Sixto, you can use that as well with using a Kaiwano. So let's see what this policy does. So you have this policy, again, validation failure action. Here, verify image rule has been written, right? So image reference has been given as a wildcard. So all kind of images which is going into the cluster will be going to be verified, right? Under the attester, you can see the count. I'm looking for the count 1, at least one count should be matches, and it's looking for the so image. It verifies for the keyless feature the subject who has built this image and verified, right, and tag that particular image. So I'm using one of the colleagues' build system, right, and GitHub action, how it's been configured, and how GitHub action build the images, sign those images, and push to the GitHub using that GitHub action itself, right? And you can see I have configured for the Fulcio root configuration and verification, and then additional extension has been given. So just to verify the particular GitHub action of flow, right? So I have a trigger, flow trigger has been used as a push. Shah just committed out just to test some scenarios, so just ignore that. You can just name, you just can share the name as well, which, yeah. So you can have a workflow name as well, and then you can point to the repository as well, where the workflow has been created or has been run, right? So let's deploy this policy. Yeah, created that policy. Wait for a couple of seconds to get registered. Let's have some. Let's create a deployment using a unsigned image. So I'm using just generate simple Nginx image, which is not signed by me or by action itself. Let's see this get deployed or not. Ideally it should be blocked because it's not signed. And it's not matching any whatever the keyless entry or subject or issuer has been configured using a policy, right? So you can see it says failed to verify image. It says attester entry keyless no matching signature, right? So just to test this one, I have exported the cosign experimental feature just for using the keyless things. Let's deploy image which has been okay. I'm verifying this image has been verified. So cosign verifies the images. So I'm just doing the unsigned image, right? Let's see, does it has any information about the verification? So it says no matching signature, right? You can use cosign feature, cosign CLI to verify those kind of images as well, whether it's signed or not. Let's have a deployment, which is basically Java Tomcats application, which has been signed using GitHub Actions and has been pushed to the registry, right? So this is signed, so this should be allowed to the created in this cluster. So you can see the dry run has been successfully, and you can see the SHASHAM has been calculated and everything. So it's been allowed in the cluster. Again, I can verify this particular image. Does it has all the information, right? So let's see. Yeah, you can see all the secret information. You can see the subject, what I configured inside the policy, right? GitHub, or the workflow or the GitHub action repo. And you can see the verify message says the cosine claims are, all the cosine claims are validated. Existence of claims in transmission log has been verified, right? All the signature has been used against the false roots has been verified as well, right? So yeah, this verifies successfully. Let's have next example using a multi-cluster tester. So we have seen that keyless feature. Now, if you have a multiple testers, right? So how do you do that, right? So for example, I have different use cases. I want to deploy images on certain namespaces and should be blocked if you going to deploy that particular app into the other namespaces, right? So for example, so this is a policy. So here I'm again doing a verify image things. Image reference I gave as that particular image I want to verify, which is getting deployed to the cluster, right? Have count is 2. Basically, I'm looking for 2 values to be successfully passed. Then only I will going to deploy the image into the cluster. So I have written a config map. It's looking for the public keys and the secrets as well. Let's look into the how the config map look like, right? Yeah, so you can see I have a config map. So I have created a config map. Under data entry, I have production app 1 and app 2. So image has been signed using these certificates, right? So in the production, all the if the app is going to deploy in the production, that has to be verified using the certificates. And then app 1, if application is going to deploy in app 1, it should be validated against this certificates. And app 2, it has to be verified with this particular certificate, right? So let's apply this config map, right? It's already applied, so it's changed. Let's apply this policy which verifies the multi-attesters things, right? So yeah, so I have applied the policy. I have created the app 1 namespace and app 2 namespace as well, right? Let's run the application app 1 in a default namespace, right? So because I'm running a default namespace, and app 1 has to be deployed in a app 1 namespace, okay? So let's deploy this one and see what happens. So see, it blocked, right? It says, okay, so 2 rules has kicked in because I have 2 policies, right, in the cluster. So both are getting executed. So you can see it says no matching signatures for a certificate found on signature for the default namespace, right? You can see it says failed unknown key default in path. So because it has been verified against app 1 and app 2, not for default. So next is I will try to deploy this app in a app 1 in a app 2 namespace itself. So let's see what it does. It says, yeah, it blocked, right? Because app 1 is not certified to deploy in an app 2 namespace, right? So it blocked with the signature keys. It has to verify two fields, entry 1 and entry 0, right? So you can see a production as well as a namespace as well, which is app 1, right? So it validated against 2 signatures. Now let's see if this app get deployed in app 1 namespace, right? So here I'm just going to deploy it again. And let's see what happens. It should, yeah, it's okay. So it got deployed, but it got blocked by other policy mistakenly, which was because I didn't clean that up. So yeah, so it has been accepted as a resource in that particular namespace. So this way you can have a multiple attester, and you can verify against those certificates to be deployed in different namespaces, and you can block if that same app has been going to deploy into the other namespace. Yeah, so that's the use case. Yeah, that's what it is for demo. Yeah, let's move on. Slides. Yeah, so apart from these features, Kyverno has some other features as well. Built-in custom variables, you can have, what I have seen in some of the demo as well, you can have inbuilt functions to create some of the things, to do a logical operations and validate the stuff, right? You have James path to basically go to traverse over the resources and get some important information as well. You can do API lookups. For example, you can do API lookups for any certain type Kubernetes inbuilt resources, right? And based on those resources, you can act on that, right? You can register OCI registries as well, for example, Docker or any other GitHub registry, for example, or AWS as well, to validate or image verification features itself. Kyverno also provides some metrics and spans to basically analyze the stuff. Right? We have a policy report feature, which policy reporter as a third-party resource, which can be deployed in cluster to visualize the reports and other data to analyze further. And we have a policy exception feature as well, which where you can write a policy exception as a policy, right? And then you can have those policy. You can have a main policy which can be provide exception to get deployed in other resources or policy itself, right? So. Yeah. Yeah, so it is summary, right? What we have seen till now. We have seen the policy is a must for Kubernetes. If you don't have policy, you can be difficult to manage your cluster down the line, right? And Kyverno is a CNCF policy engine built for Kubernetes. You don't have to learn any other specific language. You can just use Kubernetes API where you can write a declarative policies and use it. It's easy to write, easy to get started, and easy to understand as well. Yeah, so Kyverno has a community as well. There's a website, and for the docs and the sample policy, there are so many sample policies has been written by the community itself. You can look into those policies to understand more how we can write those policies, how we can run those policies with examples as well. So you can visit kyverno.io for the website. And we have a Slack channel as well in the Kubernetes Slack. You can reach out to our developer or community member will be there to help you if you have any queries around that. And then we have monthly and weekly contributors meeting as well, where you can join and ask your queries, and basically you can get some help to develop some issues, or you can start working on certain uses to contribute to the Kyverno project as well. Yeah, thank you. I'm open for Q&A. Any questions if you have?
Yeah. No, we don't have time for questions, but yeah, thank you very much.
Thank you. Thank you, everyone.
All right, so last talk of the day. We have Rashid, who's going to talk to us about a large-scale Kubernetes deployment. Welcome, Rashid.
Thank you. All right. Before moving any further into this talk, I just want to take a few seconds to say thanks, a very, very big thanks to a few companies, Snyk, which has a booth at KubeCon, OVH, and Clinic. These are the companies that made this talk a reality. So a big shout out to them, and at least but not last, my lovely wife. So who am I? I'm Rashid Zarwali. I'm a freelance architect. I run different communities. I'll speak a bit about that later on. And if you want to see what I do, you have my Twitter, email, and my website. What I do, a lot of things. Obviously, I work with my clients. As a cloud architect, I try to crawl the whole cloud scope. And I also run different communities, organizing events, speaking, reasons why I'm here, and so on and so forth. So how the project started. When I joined OVH, Kubernetes deployment were one deployment at a time, meaning using RKey provider with Terraform, leveraging OVH. If you don't, OVH CDS, sorry. If you don't know what OVH CDS is, it's an open source solution that does continuous deployment that has been built at OVH, and it's completely open source. And it leverages also different internals API for bare metals and other stuff like that. One Kubernetes cluster at a time. We had known few issues, node management, issues with Terraforms also. We don't have any reconciliation mechanism. Scaling is at some point a pain, especially when you have very large platform into your states. We also had serious concerns about RKey long-term support as the V1. We didn't have any clear answer about if this RKey V1 will be still supported or will disappear in the coming months. And other different issues with internal API that has been rewritten or are in the process of rewriting, especially the bare metal management, which is kind of specific at OVH in a way that you don't order through the APIs bare metals, you order a system, and then the APIs gives you back a bare metal instance. What I mean by that is you don't know beforehand what is the name of the instance itself or the instances. And it has some drawbacks in managing nodes in your Kubernetes clusters. We don't know in advance how to easily drop out of the cluster a node, especially because we don't necessarily know it in advance. It's the API that draws the system installation, and once the system installation is done, it gives us the system name. Basically, this is how it works at first. So you do a commit, go through TDS, Terraform, then Terragrunts, and some linting above that. OpenStack, which is the underlying platform, RKey and OVH providers that are used in this case, and you deploy a very single Kubernetes cluster. What we were looking for is how we can move from one cluster to thousands of clusters at once. Meaning, if we want to spin up a full region, we just want to spin up the full region with a single Git commit and leave it out to whatever the system to manage the whole deployment of these hundreds and thousands of clusters at once, with reconciliation, with all the control mechanisms that exist. So how I started? Basically, I started to crawl the internet and GitHub and look for tons of projects that exist You have few of them, but the list is very short. I started with 100 of projects and going through each and any of them. Are they able to do multi-tenancy? Are they able to do large management? Are they able to deploy on OpenStack? Are they able to deploy on bare metal? Blah, blah, blah. It was a mess. So we just settled down a bit and write down simple criteria. What are the main criteria that we want to answer for the final solution? A single endpoint. We don't want to have to leverage several applications or mechanisms to do this large-scale deployment. Seamless node management, I've spoken about that. We want to be able to select which node to drop, which node to add, and so on and so forth. Full GitOps, reconciliation, obviously zero downtime upgrade. We don't want to have all those clusters down during the upgrades. Long-term support, especially regarding RKE, maturity, obviously, and down the road, I'll speak about that later on, hybrid clusters. Are we able to deploy thousands of clusters with nodes that are bare metal and nodes that are VMs on top of that? So once that we wrote down those criteria, I just went through this whole project that I've selected. And I came with a short list, basically cross-plane from Upbound, and the cluster API. We had two last criteria, which were the final decision for this project. Is there any production-grade OpenStack support? And are we able to leverage this solution to deploy Kubernetes on top of existing bare metal or existing virtual machines? In this case, Cloud API won, especially because OpenStack support in Crossplane was, let's say, not that stable. And Crossplane is, how could I say, leverage different mechanism. It triggers API, and those API will have the responsibility to deploy the bare metal and then deploy the Kubernetes clusters, and this wasn't exactly what we were looking for. So what is Cluster API? Basically, Cluster API is a way to use Kubernetes to deploy Kubernetes clusters. Your Kubernetes clusters can be everywhere, VMware, Azure, Google, Amazon, whatever. It leverages what we call providers, and these providers helps your management cluster to deploy your workloads in the end. In depth, what we do is we deploy into a management cluster, a seed cluster, if I can say that way, all the mechanisms that we need to deploy these workloads cluster. So basically, we have different steps. We have the bootstrap, infrastructure, the control plane also, and the machines. Regarding OpenStack, we use a tool, well, all the Cluster API providers use a tool called Cluster CTL, and this tool helps you into generating your manifest and managing also your deployment. So what we do here, we leverage OpenStack provider named Capo to target the OpenStack platform and deploy the platform. The OpenStack cluster controller is responsible for the infrastructure, so booting up the VMs, and machines is connecting into the VMs and deploy your Kubernetes instance. And then you have the kind of things. I have a demo. It's quite long, like close to the talk length. So I won't go through the demo, or else I'll stick with you for an hour. If you want to just see the full demo, I have a recording that is in progress. Just scan the QR code. You will go to the upcoming YouTube channel that I'm working on, and I just push the full demo, which shows everything from setting the cluster to deploying several clusters, workloads clusters in the end. What I will show you here is how I made this project and how basically it works. So, how is it? Let's go there. So basically, I'm using a Helm charts that I built with few templates. So I have the Bootstrap, cluster, kube control plane, machines, and OpenStack. And this Helm charts leverages Cluster API and the OpenStack provider to deploy my clusters. I have definitions of clusters that are here. And these definitions of clusters are using Argo application sets. And I'm simply using a plain YAML file where I pass all the values of the Helm charts. And it's very simple. And if I want to add more clusters, I simply have to create more directories, and in each directory to create a simple YAML file, like this one. That will trigger Argo CD, and then Argo CD will manage the deployment of my full cluster. A brief overview is, so this is my Argo instance. I have my project that is here, and I have here this one and this one over here. The clusters that has been deployed with the Helm charts that I built into OpenStack to the virtual machine on top of it, and then Kubernetes clusters. So you have here all the mechanism. What do you have here? So these are the machine deployments that you have here. I have the control plane. All the definitions that creates my clusters are managed here by Argo. If I want to create another one, I simply do, let's try it out fast. Where am I? I go to clusters. Let's say KRS 3-capo. Let's take this one. Copy paste. There we go. KS3. Give it a name. Correct name. KS3. Should be it. Okay. Oh, it's challenging. All right. Let's go here and call it, as I said, kas3-capo.yaml. Okay. Now let's do git commit -am demo test. Oopsie. Yeah, it didn't get clusters. Come on. All right, let's do it fast. All right. Demo test. There we go. Git. I'm lazy. And if the demo gods are with me, I should have here another instance of the cluster that has started there. So this is my new cluster, which has started to be deployed. And if I want to go, if my deployment is ongoing pretty well, I can go into a simple shell here and do, oopsie, there we go. Let's get to the cluster, let's get logs. And as you can see, it goes pretty fast. So it's creating all the instances, and in a few minutes, the cluster will be boot up, and I'll be able to leverage it. So I do it with a simple one. You can easily imagine how fast you can go if you want to go through deploying thousands of clusters at once. It's the same mechanism. But things didn't go that well into, woohoo, where are you? Okay, I missed my, right. Few issues, because we had issues. Basically, I ran into a rate limit into Keystone. Keystone is the component into OpenStack that is responsible for everything around authentication. I left the seed cluster running for days, and at some point, Keystone just dropped me out, and if Keystone drops you, there's no way to deploy more clusters. Few documentation glitches, especially the fact that in the cluster API since 3 releases, all the providers are out of 3. So you have to adapt your YAML to use an external controller that will be deployed into your workloads cluster to interact with the underlying platform to deploy everything that you need, load balancers, IPs, storage, and so on and so forth. A certain instability also, KP did few things, like deleting clusters, and once you delete the cluster, the KP providers dies, don't know why. And a known issue with the latest LTS of Ubuntu, which simply doesn't build. I don't know why. There's an issue open, you can look at it. It takes hours and just in the end crawls. So if you want to leverage Ubuntu, quick tips, switch to Flatcar. It's easier. This is the kind of message that you can have when you play with it that tells you nothing about what's happening. The issue here is very simple. I missed a configuration into one of the files that OpenStack uses. There's no way in this message to learn what's going on. Absolutely no way. I'll challenge you to find it out. And if you find out, I'll buy you a beer. Limitations, because there's also limitations. We wanted to leverage hybrid deployment. This is a no-go. There's no way for now to deploy a single cluster that leverages bare metal instances and virtual machines. It's either full bare metal or full virtual machines. This is something that's, I think, in progress, but for now, there's no way to do that easily. OVH leverages for everything around routing its own solution, which is called IPLB, and it works completely differently than Octavia, which is the component responsible for everything around load balancers and IP attribution. And again, these were some issues that we have to deal with. And one of them, the last one is, if you want to leverage OpenStack, you have to build your own images. Default images doesn't hold everything needed to deploy Kubernetes using the cluster API. There's a image builder project that you can easily leverage. You just have to go for it. And again, don't use the Ubuntu, use the Flatcar. Key takeaways. Node management is now a breeze. We have a list of node management. You can easily drop a node, then automatically the cluster API will spawn a new one, integrate it into the cluster, no issue. Kubernetes upgrades are done in place, almost zero downtime, like few ICMP packages that you lost in the process, but it goes very smoothly. I can't show it now again because it takes too long, but it's very easy. You just change one of the values that you have, you upgrade the Kubernetes version, and that's it. Simply as that. Cluster set is very, very interesting. What is cluster set? Cluster resources set is a way to use cluster API to deploy into the workload clusters whatever you want. CLI, controller managers, applications, and so on and so forth. And one of the main key takeaways that we wanted and that we leverage throughout this POC is we now are able to leverage Kubernetes to deploy Kubernetes at once from 1 to 1,000 clusters. Next steps, because the road is very long, trust me. OVH has its own, let's say, OpenStack integration, and we wanted to leverage the hybrid system. So this is where we needed, and we still need to do some customization, either build our own cluster API provider or use an existing API provider, cluster API provider like the OpenStack, and add the support of Ironic. Ironic in OpenStack is responsible to manage everything around bare metal. And as I said, work around this IPLB and storage API to be able to also use this routing mechanism that exists at OVH and use everything around storage, block storage, that are available throughout their own APIs. In a nutshell, if you want to use cluster API to deploy thousands of clusters on top of OpenStack, OVH or not, it's a go. It works really, really, really easily. If you want to go the hybrid way, this is a work in progress. Go to the cluster API channel on the Kubernetes Slack. There are discussions around this in how we can create something that can do this hybridation. It doesn't work for now. If you have any questions, I'm up for it.
Questions?
Great talk, by the way, on using GitOps as the principle of using GitOps to deploy Kubernetes clusters. Can you talk a little bit about maybe about crossplane, on your thoughts on your findings of why it didn't work, or what could be the things that they can do in the project? When you were comparing the other solutions.
No worries. The fight between crossplane and the cluster API is very easy. We wanted to leverage OpenStack. OpenStack is not supported at crossplane, and we wanted to be able to deploy Kubernetes on top of whatever exists, bare metal or virtual machines. If we wanted to leverage basically crossplane, we would then have to build our own crossplane provider to deploy everything at once. And this is a road that we didn't want to go through at this project stage. This is as simple as that.
More questions?
Hey, thanks. So you mentioned the authentication issues that you faced when bootstrapping.
With Keystone, yes.
Yeah. So what other potentials APIs can break basically when this kind of when you're spanning up I don't know, hundreds of clusters? Or
basically, if you are not able to authenticate with Keystone, there's no way that you can deploy anything. You have to authenticate with Keystone at first, and then be able to leverage OpenStack APIs. So what happened is I built the seed cluster. I deployed 3 clusters just to play with them. I left them for days and weeks. And at some point, I was like, okay, it worked for 3. How about 30? Just to go a little bit higher. And I had some issues. And digging in, I didn't see at first what happened. But I just saw in the logs that I have authentication issues. And when I went to the team that manages the public cloud at OVH, that's where I learned about this Keystone rate limits. This is a safe mechanism to avoid that application, hammers Keystone, because if Keystone dies, OpenStack dies.
All right, that's it. Thank you very much.
Thank you very much.
All right, so this was the last talk of the day, but we have another full day tomorrow. So see you tomorrow.
Ciao, see you.